in which I would like to tell you about the C++ programming language. So just a brief outline about the course and just a brief, preview of the course, what I'm going to tell in this course. So we are going to strongly study the object-oriented concept of the C++ programming languages in great depth in these videos, in the upcoming videos on C++, and we will thoroughly study the objects of classes, object constructors, friend functions, and then polymorphism, inheritance, and then exception handling, and all these things we will cover in great detail. At least what is my capacity, I will try to tell you all these concepts in good amount of detail. So this is what I plan to do in this video. So my effort will not be in this series of videos I will not go on to the basics of programming. I will be assuming that you have some amount of exposure to programming, you have some experience of writing basic programs involving loops and if conditions and everything. This I assume. So if you have not studied it, so then better is that you take some introduction of C programming language and then you watch my videos. So this will be very good. So let us start with the introduction to C++. So C++ was developed by Bajan Stroustrup in Bell Laboratories. So Mr. Bajan Stroustrup developed, so he was previously working on one language that was called Simula, and that had some features of object orientation, and through that he developed C++. So initially C++ was developed by him in the years somewhere around 1980s, and then previously it was previously this language was named as C with objects, but later in the year 1983 it was named to C++. So this is a brief history of C++. I would not go into very deep historical details of C++. So what is C++ is the most important question to ask. So C++ is an object-oriented programming language, and if we have studied C language, then we have seen that C is a structured program. It is a procedural programming language, or a language in which you think in terms of functions. But C++ is an object-oriented programming language. So that means in C++ we think in terms of objects and classes. And then you can always say that C++ is a superset of C. That means in your C++ program you can also write a C application. That is why C++ is backward compatible with C also. So it is like in C had some amount of features, and then C++ added some more features. So that is what is so very specific about C++. For example, if I just I would like to explain. For example, if this is your no, I'm sorry, I'll just if this is suppose your C language, and then this is this outer subset is this is what is called C++. So C++ is a superset of the C programming language, and it adds object oriented features to C programming language. And C++ can also be defined as what? It can also be defined as C with objects. So this is some amount of brief details about C, and my advice watching all these videos is that you please so programming, as far as what I have seen, is that programming is a task that you have to practice a lot. So you keep on practicing, and you get some errors, you try to resolve those errors. With that, with this getting a lot of errors and resolving those errors, and slowly and gradually you become expert programmers. So it's not like that you can become a good programmer within short duration, a few days. It requires a consistent effort. So be consistent in your efforts, and C++ is a kind of object-oriented programming language. So it is a good start to learn object-oriented technologies. I mean, there are some other object-oriented programming languages like Java or C#. So you can choose any of them, and basic motive is to understand what is object orientation. And C++ you can choose to be one of the very popular languages, so you can choose this language also for studying what is object orientation. Okay, thank you so much for watching my videos, and please my advice, follow my advice and try to practice a lot. I'll be giving a lots of hands-on in my videos. So whatever application I develop, just try to develop those applications on your own as we go along with the video series. Okay, thank you so much, and please do keep watching the rest of the videos. Thank you. So before trying to understand friend function, let us try to understand the need behind friend. So in general, suppose you have a family and there are some close family members like your mothers, your father, the brothers, sisters. They all form a unit. But there are also some friends of the family which can come inside the family and they can meet the family members. So this is the case with my object oriented programming in C++ also. Like I have a class, and inside a class, suppose I have a private variable. Suppose I have a private variable, and suppose the variable is, say, suppose x. I have one private variable. So what does private variable means? Private variable means that it is only accessible from within the class. I cannot access a private variable from outside the class. See, if I make an object of my class, say suppose m1, then I cannot write something like this, m1.x. I cannot do it. Because why? Because x is private to the class. But this private variable cannot be accessed from outside the class. But there is one provision, that is a provision of friend function. So friend function of a class have this, friend functions of a class are allowed to access the private members of a class. So how do we declare friend functions, and how do we create friend functions? All this we will see in this video lecture. So before studying friend function, I will just try to first of all present it, and let us look at some point of friend functions. So friend functions are not member functions of a class to which it is a friend. Okay, and friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Friend function can access any member of a class to which it is a friend. So let me do one thing. Suppose this is my class. What is the name of my class? My class. So over here I will create a function. Suppose the name of the function is function1. But now this function is not an ordinary function. It is a friend function. You see, if you go to this presentation over here, then what I have written, friend functions are declared inside the class using the friend keyword. So whenever you want to make a function as the friend function, you in its declaration you write the keyword, that is the friend keyword. So over here I have written the friend keyword. So over here my function, that is function1, this is the friend function. So I'm just going to remove it from here. So again, if you go over here, you can see friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Okay, so friend functions are not member functions of the class. Okay, so what does all this mean? See, inside my class I can just have a declaration of the friend function. I just declare the friend function. Then I need to define the friend function somewhere outside the class. So how am I going to define the friend function outside the class? This is what I'm going to tell you. So if you want to define the friend function outside the class, then what is the return type of this function? It is void. And what is the name of the function? It is function1. So first of all, over here, this is a friend function. Okay, function1, it is a friend function. So let us go point by point. Friend functions are not member functions of a class to which it is a friend. See, over here in this my class, the function1 is a friend function. This friend function does not belong to my class. It does not belong to my class. See, I cannot write something like this. M1 is an object of class. Which class? My class. Through M1 I cannot access function1. You see, if I write, then it results in a compile time error. Unable to resolve identifier function1. Because function1 does not belongs to the class, we cannot access function1 through the object of the class. So always remember that friend functions are a kind of very special type of functions which do not belong to the class but still have the capacity, or they are allowed to access the private members of a class. Okay, like this. Now what I do is that suppose this function, this friend function, takes an argument of my class, suppose m, my class. This is just a declaration, and over here I write something like this, my class m, and now I write cout m dot x. If I write like this, then what does this mean? Suppose in this class I also declare a constructor. So how will I declare the constructor? My class integer x. Now we have studied about the this pointer, so I can use the this pointer, this dot x equal to x. See, over here my instance variable name is x. What is the name of the instance variable? It is x. And what is the name of this variable? This local variable is also x. So I can write this arrow x is equal to x. Alright. So when I write this arrow x, that means the x of the current object, and this x is the local variable. Alright. So I have created a constructor of the class. So now I can do something like this, 10. Alright. Now that means for object m1 the value of x is 10. Now there is a function. What is the name of the function? Function 1. This function 1 is not a member function of my class. Instead it is declared in the global scope. You see, it is defined in the global scope. So if I need to call function 1, what will I do? I will just write the name of function, and then I will pass the argument. And what is that argument? It is an argument of type of object of my class. So I have an object of my class, that is m1, and this function 1 is expecting an argument of what class? It is expecting an argument of my class. So over here this m1 gets passed on to m, and then I print m dot x. So you can see this x is a private variable. If this x is a private variable and my class is ending over here, see, this class only is from here to here. Okay, and I am accessing this x variable from outside the class. I am accessing this x variable from outside the class. If x is a private variable, then generally it is not allowed, but friend function can do this. Okay, like if there is some family friend, then he can come inside your family and he can, have some personal interactions with the members of the family. Similarly, the friend function can access the private variables of a class, private members of a class. All right. So now I will clean and build this application. Build successful. And then once I go to, I will just run this application. So let us see what is output. See 10, it is coming out. So I can write something like this. Inside the friend function, the value of x is, alright, like this. And then I will, I will give a new line marker like this. Alright. And then again I will go to clean and build this application, and then I will run this application. So once when I run this application, inside the friend function the value of x is 10. See, x is a private variable and the value that has been set for m1.x was 10. m1's x was 10, and that x I am accessing somewhere outside the class. So this is a friend function. Which function? The function 1, it is a friend function. So again let us go to my presentation. Friend functions are not members of a class, or not member functions of a class to which it is belongs. Yeah, we saw that just because if I were to write m1 dot function 1, then it was giving an error. See, m1 dot function m1 dot function 1. If I write like this, then it will result in a compile time error. I cannot do this. That means function 1 does not belong to the class because it cannot be accessed through the object of the class. Friend functions are declared inside the class. Yes, I declared my friend functions inside the class. How I declared my friend function inside the class? I did it like this, and then I defined my friend function in the global scope outside the class. Okay, like this. Friend function can access any member of the class to which it is a friend. So over here, this function 1 is a friend to my class. So it has access to all the member variables and functions inside my class. So here the thing is that x is a private variable, but inside the friend function I can access the private variable. But there is a there is a specific condition. What is the specific condition? I cannot do something like this. I cannot directly access x. See, x is a private variable. I cannot write directly accessing x. The value is, suppose I cannot directly access x. Okay, if I do like this, then it will result in an error. It is giving a compile time error, unable to resolve the identifier x. So you cannot directly refer a instance variable inside a friend function. You only do it indirectly through the object of the class to which the friend function belongs. See over here, friend functions are not associated with any objects. And then if you see the last point, friend functions access the members of a class to the object of the class. So if I want to access this private variable x, I cannot directly access. I cannot write cout as we saw. I cannot write like this. If I want to access x, then I have to write something like this. I have to access it through the object of my class. See, friend function belongs to my class. It is a friend of my class. Then if I want to access the private variables of my class, then I need to have an object of my class. And what is in this case the object of my class, my dear friends? It is m. So these are friend functions. So in the next video also we will study about friend functions. We will create a friend functions that will belong to two classes, and that will then access the private members of both the classes. So we will see it in the next lecture. What we are going to do in this video is we will study about the if condition in C++, and that is pretty much the case. If you have studied C, then you must have studied about the if conditions, but still if you are not clear, then I would like to explain it. So if basically takes a Boolean argument, so it takes an argument that is Boolean. And what is a Boolean argument? It is either true or it is either false. So if it is true, then if whatever condition, you give some condition inside the if it is true, then this part this part runs, and if it is false, this condition stands out to be false, then the else part runs. So this is your basic running of if else condition. Now I think you must be aware of it, but still if you are not aware of it, let us try to write a very basic program for it. Suppose I have two numbers. I have one number a and I have another number, suppose number b, and suppose b is equal to 20. So I have two numbers, and now what my task at hand is that I want to find the greater number among these two numbers. So what program will I write for this? I will simply write this, if a is greater than b. See, this is a Boolean condition. If a will be greater than b, then this will return true, and if it will be less than b, then it will return a false. So this will evaluate to a Boolean value. So on the basis of this, I'm going to write something like this. Suppose if I write like this, and then inside I can write, suppose if a is greater than b, then I can write a is greater, and if a is not greater than b, and in this case if we observe b, this condition stands out to be false, in that case a will be less than b. So here I can write what? Here I can write cout what? I can write b is greater, and so this is basic. This is our very basic first program involving finding the maximum among two numbers. So let us try to run this application once I go and clean and build this, and if I just go and run this application, let us see what is output. If I run it, see, b is greater. And now if I do something like this, suppose I say I don't make a equal to 10, I make suppose a equal to 100. Suppose if I say is equal to 100, then what will be the output of this program? I think it is self-obvious and very explanatory, but still for your clarity, I'll just run this program once again. Let us see what is the output. Okay, in this case a is greater. So this you are getting. Now suppose our task in hand is that I want to find the greatest among three numbers. So I will declare a third number, suppose it is equal to 30. And now if I want to find, suppose I will just say not equal to 10, suppose it equal to 5. Alright. So now what I want to do, I want to find the greatest among these three numbers. So what program will you write? Can you write this program? I'll just pause this video give it a try, give it a shot. How will you write this program? You have to find the greatest among three numbers. Alright, if you're not able to get it, then I will write this program. I'll just remove it, and suppose I say something like this. First condition I give, if A is greater than B. And here suppose I give the else, and yeah. So if you are in, either this part is going to execute, or this else block is going to execute. Okay. And if this part executes, if the if parts execute, the else part doesn't execute, that means A is greater than B. This means A is greater than B. So B is not into consideration because A is already greater than B. So now what I need to do is that I just need to compare A with C. If A is greater than C, if A is greater than C, then I can write something like this. What I can write, A is greatest. And if it is not the case, then what will I write? I will write something like this. I will say C is greatest. All right. And now I just go and copy it. And I just copy it over here. And if this, if this condition comes out to be false, that means A is lesser than B. So we do not need to consider about A. We only need to compare now B with C. So here I can write something, I can write what? I can write B. And here also I can write what? I can write B is greatest, or else what? C is greatest. All right, if I just go and save this program, and if I run it, let us see what is the output. Clean and build. All right, and now if you go and run this application, so what will you get? C is the greatest. So you have find the greatest among three numbers. All right, so now what I'm going to do is that I'm just going to quickly demonstrate you if, else, if. Okay, so it is suppose I have so if, else, if is basically it is meant for some kind of mutually exclusive conditions. Mutually exclusive means that only one of those conditions will hold to be true, and for that we use if, else, if. So what I'm going to do is that I'm just going to remove it. And suppose what I need to do is that I just need to calculate the grade of a student. So I have been given the marks of a student, and I say suppose one student has got 90 marks, or say suppose 91 marks. Okay, so I need to calculate the grade of students, and what criteria do I hold for calculating the grade? I would say something like this. For example, if the marks are greater than or equal to 90, okay, greater than or equal to 90, then the grade will come out to be A. All right. If the marks are greater than or equal to 70, but they are less than what? But they are less than 90, then the grade will come out to be B. If the marks are greater than or equal to 50, but they are less than say suppose 70, then the grade will come out to be C. And now if suppose the marks are even less than the marks are less than 50, then what is going to happen? Marks are less than 50, then in that case I will give a D, D grade to the student. All right, so we need to calculate the marks of student based upon these criteria. So what I'm going to write, if I say suppose what, if marks is greater than or equal to what, it is equal to 90, then I can straight away say, I can say the grade is A. I can write like this. If this condition doesn't hold true, then what will I write? Then I will write something like this. I can say if marks is greater than or equal to 70 and what? Marks is less than what? Marks are less than 90. In this case, I will say cout the grade is B. And then I can just copy it, and I can just paste it over here, and I can write like this. I write 70 and then 50, and finally the one condition that is going to hold true in the end, that I will specify using else, and I can write what? Cout what? Cout the grade, sorry, the grade is B. All right. just I will do this. All right, and here also I will just turn it to cap. All right, so here I've written this program. Let us just go and try and run this program. Clean and build. Yeah, build successful. And now if I go and run this application, suppose run. See, the grade is A. All right, and now suppose the marks are, say, suppose 43. Then let us see what will be the output. If I go and just again clean and build this application, and if I run it, then the grade is D. Sorry, here I'm just going to write not B, I'm going to write C over here. All right, this seems to be correct. So what is actually happening is that, if the marks are greater than 90, then this condition, these are sets of mutually exclusive condition. Why? Because only the marks will, it will get into the range of any of the one. Either it will be greater than 90, or between the range 70 or 90, or between the range 50 and 70, or they will be less than 50. All right, so this way we are writing it, and we are testing each and every mutually exclusive condition, and if none of the condition holds true, then finally this else loop is going to execute. So here I have also calculated that marks do not also belong in the range 50 and 70. They are also not between 70 and 90. They are also not greater than 90. So that means the marks are less than 50. In that case, I will give the student a grade of D. All right. So this way we work with if conditions in C++. So always remember that your if takes a Boolean value, and it evaluates it, and based upon that evaluation, it either remains in the if part or goes to the else part. Okay. In this video, we will study about the working of for loop. So for loop, so there are three things that you have to keep in mind when you're designing for loop. The first thing is the initialization condition, and the second is your condition, and the third is your increment or decrement. So this way we commonly design for loops, and then this is the body of the for loop. So this is generally what I have, basically what I've in a way just in an abstract way trying to explain what is a for loop. So let us try to understand with the help of a concrete example. Let us just for example, I want to print number from 1 to 10. So I will declare one variable I. So how I want to do it? What will be the initialization condition? See, first I have to give the initialization. So what will be the initialization? I have to initialize the value of I equal to 1. Why? Because I have to print numbers from 1 to 10. This is what I want to do. I want to print numbers from 1 to 10. So I have to initialize I equal to 1. And what is the terminating condition? What is the condition? The condition is that I should always be less than or equal to 10, because I have to print numbers from 1 to 10. And then I can keep on incrementing the value of I. All right. And inside this, suppose I say cout I. And let us give a space after it. All right, and once you save this, and if you go and actually clean and build this application, and if you go and run it, you will get numbers from 1 to 10. Suppose now what I want to do, I just want to print the odd numbers from 1 to 10. So I can say, so I want to print odd numbers from 1 to 10. So I have initialized the first odd number will be equal to 1, and I will continuously increment the value of I by what? I will continuously increment the value of I by 2. I equal to I plus 2. So what I've done over here, I have incremented the value of I by 2. All right. So let us clean and build this application. And now when you go and run it, you'll get all the odd numbers from 1 to 10. So this way we do it. So let us try to do one more example. Suppose I want to print the multiplication table of a number. So I take a number, suppose num, and now if I want to print the multiplication table of num. So multiplication tables are generally from, you print multiplication tables from 1 to 10. So this way we do it. So let us take one more variable, suppose I, and this num variable is a number for whom I want to print the multiplication table. Suppose I want to print the multiplication table of 5. So what will I write over here? See here, I'll just remove it. What should I write over here? See, I print the multiplication table from 1 to 10, so that is why I've run this loop from 1 to 10. Now I can write something like this: cout what? See, I can write num and then into and then I can write I, and then I can write equals and num into I, and of course I can give a new line after this, and I think it should run. Let us clean and build this. And now once when you go and run this application, see, you are getting the multiplication table of 5, and you are running the loop from 5, it is coming from 1 to what? 1 to 10. So that's why you're running the loop from 1 to 10. So many times it is a case in for loop, you have to decide for how many times, for how many iterations your loop is going to run. Alright, this is the basic working of for loop. Now let us try to create one pattern using for loop. So I'll just tell you what is the pattern which we want to create. Alright, so we want to create we want to draw this pattern: 1 1 2 1 2 3 1 2 3 4 and 1 2 3 4 5. So whenever you are given such kind of problem, see, in this case there are how many rows? There are 5 rows, 1 2 3 4 5, and in the first row there is only 1 column, in the second row there are 2 columns, in the third row there are 3 columns. So whenever you have to iterate like this, it's a kind of matrix kind of structure. So first of all, you iterate over the number of rows. So what is the number of rows? The number of rows is equal to 5. So how will I iterate over the number of rows? I will say for I equal to 1, I less than equal to 5, and then I will say I plus plus. If I use this loop, then I can iterate over the number of rows. Suppose now if you are in the third row, then how many columns are there in the third row? There are 3 columns in the third row. If you are in the fourth row, then how many columns are there in the fourth row? There are 4 columns in the fourth row. So if if you are in the third column, for example, if you are in the third column, then what will be the value of I? The value of I will be equal to 3. So in the when you are in the third row, you have to print 3 columns. So inside this you'll have to write this is a classic example of nested loops. So here you have to create some more 1 variable. Suppose j is equal to 1, and then I can say j is less than equal to what? J is less than equal to I, and then j plus plus. And here I can I can print j. I can write cout j. Okay. Let us try to work it out. Alright, I'll just clear all this. I'll remove the draw tool and I'll just minimize it. Let us try to actually work it out. So here, though when I have to print this pattern, I have to first of all initialize I equal to 1. I can say it's an integer I equal to 1, I less than or equal to what? 5, and then I can say I plus plus. So what will be the initial value of I? It will be equal to 1. So once the value of I is equal to 1, how many columns you have to print? That means you are in the first row, and in the first row you have to print how many columns? You have to print 1 column. So I can say for integer j is equal to 1 and j is less than or equal to what? This is the important part. J is less than or equal to I, and then I can say j plus plus. And here, this is the nested for loop, and inside this I can just print what? I can just print j, and then I can give a space after this. Alright, and once I get out of the body of this for loop, I can say cout new line. Let us see if this is working or not. Clean and build, and okay, and now if I go and run it, let us see if it is coming on. So yeah, it is coming. So this series is getting printed. If you are not able to understand it, then I'll just explain it to you. I'll just again take the draw tool and let me minimize it, For example, just let me okay, here I don't think, okay, all right, so here let us do this thing. All right, you have I and then you have j. Initially what is the value of I? The value of I is equal to 1, and then suppose this is what I say, this is the for example, this is the output. All right, now I is equal to 1. With the value of I is equal to 1, it will go inside this for loop. It will go inside the for loop. So inside the body of the for loop, what I have written, I have said for j is equal to 1, and since I is equal to 1, it will run only 1, and it will print what? It will print the output as 1, and then it will come out of the body of this for loop. See this for loop, and then it will print what? It will print a new line. So it will come to the second line. The output will come out to the second line, and now the value of I will again increment, and it will become what? 2. So with the value of 2, it will go inside the for loop, and it will go to the inner for loop, and j will run from 1 to what? J will run from 1 to 2. So what will be printed? 1 and 2 will be printed, and then again what I am saying, I am again printing a new line. So it will come to the third line, and then I will become what? I will become, in this case, it will become I3. So j will run from 1 to 3. So it will print 1, 2 and 3, and so on. This will continue. Okay. So I'll just clear all this. All right. Thank you. So this is basic working of for loops. And suppose I want you to draw this pattern. Suppose you have to draw this pattern: 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and 5, 5, 5, 5, 5. What changes will you make? See, this is not properly, spaces and indentation is not there, but still, what change you will have to make to this program to make it run? So here I think you have to make just one change. If you just in place of j, if you replace it with I, then it will give the required output. See, if I, for example, I just again clean and build this application, and now when I go and run this application, see, it is giving the required output. Why? Because initially the value of I, see, in this outer for loop, the value of I is equal to what? It is equal to 1, and then with this value it is going inside this for loop. So this for loop is going to, this inner for loop will execute only one time, and it will print what? It will print 1, and then it will come to a new line, and the value of I will be incremented to 2. So now with this value of 2, this inner for loop will execute from j is equal to 1, so j less than equal to 2, and it will print what? It will print only I. So I is equal to 2, so it will print 2 times 2, and similarly in the case of 3, 4 and 5. So you will get this output like this. Okay, so I think I will not I will not go into the very great details of for loop and solve some complex problem using for loops, nested for loops. I'll not do all this. I think you can have many other books regarding it, so you can refer some other resources regarding it. My basic task over here is to try to explain you the concepts of object-oriented programming using C++. This, I think, all we have covered in when we studied C. So this is just a kind of refresher if you are not clear with the concepts. Okay. In this video, we will study about the functioning of arrays in C++. So arrays, you must, if you are not aware of it, then arrays are a contiguous allocation of memory. For example, so why do we need exactly contiguous allocation of memory? For example, I have a class, and in that class, suppose there are 5 students, and I want to save the name of every student. So what will I say? Will I create 5 variables like this? String name 1, and then name 2, and then name 3, and then name 4, and then name 5, because there are 5 students in my class and I want to save the name of every student, though I must create 5 type variables of type strings. But this is not a very very good approach. Why? because okay, in this case acceptable, there are 5 students in the class, but what if there are 50 students in the class, or maybe what if there are 100 students in a class? Are you going to allocate 50 or 100 variables for for saving the names of every student? This is not a very viable or very feasible approach. This can be done, but that will make your program very tedious and very difficult to debug and understand. So for that purpose, we use the concept of what is known as a array. So an array is a contiguous allocation of memory elements. All right, so I'm just going to open a notepad and I'm going to write. So what is an array? Array is contiguous allocation of memory elements of same data type. So what does this mean? Suppose I want to save the names of 5 students in the class. So instead of declaring 5 variables, I can declare an array. And how will I declare the array? First of all, I will give the name of the array, and then I will give the first of all I'll give the data type of the array. So what is the data type of the array? I've given the data type to be string, and then I will give the name of the array. So suppose I give the name of the array as stu names. All right, suppose stu names, student names, and then you have to give a array subscript. So this, when you write this subscript, so this means this is not an ordinary kind of variable, this is a kind of array, and then you give the size of the array. So for example, in this case, I want to save the names of 5 students, so I will say something like this. Okay, so this is the declaration of an array. For example, I want to have the marks of say suppose 10 students in my class. Then I can, so what, for holding marks, I have to declare a variable of type what? I have to declare a variable for marks. For storing marks, the array has to be of type int, and then I have to give the name of the array. Suppose the name of the array is marks, and then I say the size of the array. Size of the array is 10. Why? Because there are 10 students in my class and I want to save the marks of every student. Okay, so what is happening behind the scenes? If you just try to see what is happening behind the scenes, then you will be getting this picture. So what is exactly happening is that there is a contiguous block of memory that has been, in this case, there is a contiguous block of memory that has been allocated. I think I'll remove it. I'll just take the draw tool and like this. So what is happening is that there is a contiguous block of memory that has been allocated. How many, what is the size of this memory? It is the size of equal to 10 ints. So it is something like this: 1, 2, 3, 4, 5, 6, 7, 8. I think 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. And then there is one more. Suppose this is the 10th. Okay. So contiguous blocks of memory has been allocated, and this much memory is, it is the size of an int. Why? Because we have created an array of type what? We have created an array of type int. Suppose, so somewhere in the memory, this array will be allocated. Do you agree on this point? Oh, sorry. I think there is some, I'll just clear it. I'll undo it. Okay, yeah. So if you do agree with me, then somewhere in the memory, this array, this whole array, it will be allocated. Somewhere in the memory it will be allocated, and if it will be allocated, then it will be having some memory address. Suppose it is starting at the memory location 2014. This element is starting at memory location 2014, and if integers are of size 2 bytes, then this second element will be allocated at memory location 2016. Then the third element will be allocated at the location what? 2018. Why? Because the size of an integer is 2 bytes. So these memory locations are allocated and in an incremental fashion of 2 bytes, because the size of an integer is 2 bytes. So this is it is not like that one element is stored somewhere else and the second element is stored somewhere else. They are stored in contiguous memory locations, okay, side by side. All right. And how do you access the element of an array? You access the element of an array by its index. So always keep this thing in mind, that arrays in C++ are indexed from the index location position 0. How? The first element in the array has an index position 0. The second has the index position 1. The third has, this element has index position 2, and this has the index position 3, 4, 5, 6, 7, 8, and then finally 9. Alright. So this way. So because the array indexing is starting from memory location 0, and the total size of the array is what? 10. Okay. So the maximum element will be 1 less than the size of the array. See, the size of the array is 10, and the maximum index in this array is what? It is equal to 9, which is 1 less than the size of the array. So this thing has to be kept in mind when you're designing, when you're thinking in terms of working with an array. Alright. So this way we work with an array. So let me do something interesting, and let me actually so in order to so suppose I want suppose to make it simple, I would just say, for example, I just want to save the details of 3 students. So in this case I will first of all I'll just clear all this, and this means that what has happened is that an array of 3 elements have been allocated. An array of 3 elements has been allocated. See, 3 elements. This element will have the index 0, this element have index 1, and this element will have the index 2. So for example, this memory is suppose 2000. Alright. So, and in the size of the integer is 2 bytes, then this this element will have the address what? It will have the address 2002, and this element will have which address? This element will have the address as 2004. Okay, this way it is gonna work. Now let us try to verify all this, and let us try to actually see how can we initialize an array. So in order to initialize an array, suppose I say, how will I access the the first element in the array? I will access it by its index position. So what is the index position of the first element? It is equal to 0. Suppose with the marks of the first student is equal to 98, and then let me copy it, and then I'll just paste it. Okay. Suppose the marks of the first, the second student, which is accessed by the index location 1, his marks are, say, suppose 75, and then suppose his, this third student marks is what? It is equal to 86. Alright, so like this way. And then if I want to, if you want to always access the array elements, then the best approach is to always write a for loop. So how will you process all these elements in a for loop? You start from, you start from the very basic index position. The first index position is 0, so you declare an integer variable and initialize it to what? You initialize it to 0, and then you have this condition: I is less than 3, and then what do I write? I plus plus. And suppose over here I just write cout the marks of suppose the marks of I say student is, and then I say marks I. Alright, and then I can give of course I can give a new line marker after this, and I'll just save all this. And so if I go and actually run this program, let us see what will be the output. If I go and actually run this program, clean and build, okay. And then once when I go and run this program, okay, it is not again let me go and run this program. See, you're getting the marks of the 0th student is 98, the marks of the first student is 75, and the marks of the second student is what equal to? It is equal to 86. So in this way you are getting the marks of every student in the class. Suppose I want to calculate the average marks of the students in the class, then what will I do? Naturally, you try it on your own. I'll just pause the video. If you want to calculate the average marks, it is very simple. I will declare variable avg that will represent the average, and I will initialize it equal to what? I will initialize it to 0. Suppose not let me declare a variable sum, and let me initialize sum to 0. And what will I write? I can write something like this: sum plus equal to what? Sum plus equal to marks of I. And then once you get out of this for loop, I can write something like this: cout the average marks is, see, the sum of all the three students marks is saved in which variable? It is saved in some variable. So what will the average is equal to the total sum of all the students divided by the total number of students. So what is the total number of students? It is equal to 3 in this case. The total number of students is 3. So you can do something like this. See, initially the value of sum is equal to 0, and then it is adding, initially the value of I is also equal to 0, so it is adding 98 to sum, and then it adds 75 to 98, and then it's add 86 to the sum of 98 and 75. So I think it is very simple to understand. And now when I go and run this application, clean and build, and now if I go and run this application, see, the average marks is 86. So you are getting the average marks also. Okay, you can even try to do it, calculate on your own. And now suppose I give you again, now we have calculated the average marks. Now suppose I want to calculate the maximum marks amongst all the students. So what will I write in this case? I think it is also very simple. You can declare a variable, and suppose the name of the variable is max, and you initialize it to 0. And then if you want to calculate the maximum marks, then you can write what? If max is what? If max is less than marks of I, then I will write max equal to marks I. Alright, like this. And then I can, once I get out of this for loop, I can write something like this also. Let me copy it, and suppose I say the maximum marks is, okay, and here I will write what? The maximum marks is what? It is equal to max. So let me again just go and try and run this application. Let us see what will be the output of this program. Clean and build. And now if I go and run this application, see, the maximum marks is what? The maximum marks is, it is coming out to be equal to 98. So how is this happening? This is happening because you are initially you have set max equal to 0, and then you take each and every element. First you take 98. This is equal to, when the I is equal to 0, then max I will represent what? It will represent 98. So max is equal to 0, and it is less than 98. So max will be set to equal to what? It will be set to equal to 98. And then marks 1, then I will become 1, and then max will be greater than, because max is containing 98, so it will be greater than 75. So this condition will not run. Similarly, in the case of 86, it will not run, and then we will get the maximum element. If you want, you can just you can do a dry run of all this. So I think this is very basics and simple explanation of an array. Suppose one more thing, you can have the declaration and definition. You can initialize the array when you declare the array. How will you do it? You can do, suppose you want to store the age of all the students. Suppose you have 5 students and you want to save the age of everyone. So you can do something like this also. When you are declaring the array, you can also initialize the array. For example, I can say something like this: 21, 34, 55, 43, and suppose 22. Alright, so see how many elements I have given. I have given 5 elements. Okay, so alright, there is some problem. Yeah, I have to add a semicolon. I think now it will work. Alright, so here I will just, let me go and comment out all this code. I will not use all this code. I'll just comment it. And now if I want to print the age of every student, and this is also very simple. Then again, for that purpose, I will have to run a for loop, and for loop will start from 0 and to which it will go to till 5. Why it will go till 5? Because there are 5 elements in this age array, because I want to print the contents of this age array. And then I can write what? I can write age, and then I can give the index position that is equal to I. So if you actually go and run this, suppose let me add a white space also after it, and if I go and actually run this program, clean and build, And now if I just run this application, then you see you're getting every element of, you're getting the 5 elements of the array. All right. So what are multi-dimensional arrays? And so multi-dimensional arrays, so we have already studied arrays in one dimension. So arrays in one dimension, for example, suppose I want to have the marks of 5 students, then I will create an array like this, suppose this is marks. Okay, so this is containing only one square bracket subscript. So this is a one-dimensional array, but we can have arrays in multiple dimensions. For example, if I have two square bracket subscript, then it is a two-dimensional array. And if I have a three square bracket subscript, then it is a three-dimensional array. So I can have any number of dimensions, in my array, 4-dimensional array, 5-dimensional arrays. But generally, after 3 dimensions, it is very difficult to perceive and operate on on higher dimensions like 4 and 5-dimensional arrays. So generally we work till 3-dimensional arrays. So in this video I will tell you about 2-dimensional arrays. So for example, I have one array. Let me name it ARR, and let me make it a 2-dimensional array. Suppose like this, 3, 2. All right. So what does this mean? I have allocated if you can see, I have two square bracket subscripts, two pair of square bracket subscripts. So that means it is a double-dimensional arrays. Whenever you are talking about arrays in C++, you always keep in mind that arrays are always allocated contiguously. All right, arrays are always allocated contiguously. So I will first of all I'll write this point. Arrays are always allocated contiguously. Okay, that means it is not that some part of the array will be stored in some other memory location, some other part will be stored in some different memory location. It is not like that. They are always stored next to each other. For example, if you just take this, then it will be something like this, so I say that this is the space of memory where array is being allocated. So in this case, how many elements will be allocated? You have 3, so you can always visualize a 2-dimensional arrays as a matrix. See, they are not allocated as a matrix, but you can visualize them as a matrix. I'll just tell you them. So this matrix has 3 rows and 2 columns. Okay, so how many elements will be there? There will be total of 3 into 2, that is equal to 6 elements. So let me do one thing. Let me allocate 6 elements from here. 1, 2, 3, 4, 5 and 6. Okay, 6 elements have been allocated. So what does this mean? So I will I'll again write one thing, and that is 2D array is 1D array of 1D array. So when you are talking about if you see this line, when you are talking about 2-dimensional arrays, then they are also 1-dimensional arrays, but they are not ordinary 1-dimensional arrays. They are 1-dimensional arrays of 1-dimensional arrays. So what does this mean? This means that in this case, if you observe, in this case, if you go over here, in this case you will have you will have 3 1-dimensional arrays. Okay, you will have 3 1-dimensional arrays, and each 1-dimensional arrays will have 2 elements. Okay, like this. For example, if you just see, this has total of 6 elements, but I will if I want to it will be something like this, See, these are 3 1-dimensional arrays. See, these are 3 separate 1-dimensional arrays. This is the 0th. See, indexing starts from 0. This is the 0th 1-dimensional array, this is the first 1-dimensional array, and this is what? This is the second 1-dimensional array. So total there are 3 1-dimensional arrays, 1, 2 and 3, and each 1-dimensional array is containing how many elements? 2 two elements. This is the, this is the 0, this is the 1. Again, for this one dimensional array, this is the 0th element and this is the first element. Again, for this one dimensional array, this is the 0th element and this is the first element. And now you can have any values, for example 3, 5, 7, 4, 2 and 9. You can have any values within this array. So if I ask how are you going to access this element, so what is the row number of this element? It is equal to 1. And what is the, what is the column number? It is equal to 0. So this element will be accessed, through the index, through index 1 comma 0. If I ask you how will you access this element, this is at row number 2 and column number what? Column number 1. So this element will have the index, it will have index of 2 comma 1. So this is actually, if you are having a two-dimensional array, it will be allocated contiguously. Don't think that a matrix form will be allocated. It is, some students perceive it like that way because they generally perceive two-dimensional array as a matrix. Matrix is for our ease, of understanding how two-dimensional arrays work. But always remember that arrays are allocated contiguously. Now what is happening is that if you want to visualize this as an array, as a matrix, if you want to visualize all this as a matrix, then what you can do is that you can have 3 rows. So I said this number 3, it represents rows. So I will have how many rows? I will have 3 rows. And each row, how many columns will be there? And in each row, 2 columns will be there. Okay. So this row will have the index 0, this row will have the index 1, and this row will have index 2. And now what will happen? This is the 0th, for example, this one dimension in this row, this is 0th element, this is the first element. Okay. Similarly, this is the 0th, this is the first, this is the 0th, and this is the first. And now you can write values. What? 3, 5, 7, 4, and 2 and 9, like this. Now again, if I ask you what is the index of this element, then you can say it is equal to what? 1 comma 0. This is what we saw over here also. I ask you about the index of this element. It is equal to 2 comma what? 2 comma 1. Alright. And this is what we saw over here also. The index is what? It is equal to 2 comma 1. So this is generally the way we work with two-dimensional arrays. Alright. So I will just I'll just clear all this. And now let us work it out. So what I will do is that I will just I have made this declaration, and within the I will declare and I will initialize the array over here itself. So how many rows I'm gonna have? I'm gonna have 3 rows, and in each row how many elements will be there? 2 elements. Suppose 3 comma 5, and then I say 2 comma 1, and then I say 7 comma 8. Alright. So in this way, you can see that I am having 3 separate rows. Alright. And in each row how many elements are there? And in each row 2 elements are there. So now if I want to print this array, so how will I print? First of all, you need to for example, if you want to print a matrix, suppose if this is your matrix, how many rows? 3 rows, and each row 2 columns, like this: 3, 5, 2, 1, and 7 comma 8, and 0, 1, 2, and 0, 1. So I'm indexing everything. Now first of all you will traverse and each row. So you will go to this row, you will go to this row, and then you will go to this row, and then in each row you will print the individual columns. So my first loop will run for the number of rows, and the second inner loop will run for the number of columns. So again, alright. So what I will do, I need to create the outer loop. Alright. The outer loop integer I equal to 0 and I less than what? I less than 3, and then I plus plus. Alright, this is my outer loop, and now I talk about the inner loop. So suppose I have different integer j equal to 0, and how many columns are there? There are 2 columns. So I'll say j less than 2, and then what? J plus plus. And this and just inside this for loop, I am just gonna print what? I am going to print cout arr I, and then what? And then j. And then I write like this. Suppose I just open this for loop and I close it over here, and now I write cout new line. So what does this signifies? It means okay, let me add one space also over here. Sorry, what does this signifies? So this inner loop is running for each row. Now each row, it is printing the contents of each row, every column in each row. Okay, and now what is happening is that after each row is printed, I am coming to a new line. Okay, so you will be able to visualize everything, you know, output as a matrix of a two-dimensional array. So this is what is exactly happening. Let us go and actually run this application and see if it is working or not. So I will clean and build this application. And now if I go and run this application, it should work out. Oh, there are some alright, again let me go and run it. So you are getting if you see, you are getting a matrix kind of structure. Okay, I can also do, you know, I can create a 3x3 array. Suppose I say like this 3x3, and I just increase, you know, suppose 2 I write over here, and then 5 I write over here, and then for example I just write for example 4 over here. And now if I go and save it, can you visualize what kind of output will be there? If I again clean and build this whole application, and now let us go and run it. Oh, it's not, I think it's not got saved. Oh, I just need to do one thing. J less than 3. Alright. Again let us go and run it. Clean and build, and run. So you are getting a 3x3 matrix out of it. You know, if you can just observe, you are getting a 3x3 matrix, but elements will always be allocated, you know, elements in this case also will be allocated contiguously. All right, so one change that I made over here, the inner loop is not running, it is running from 0 to, you know, from 0 to 2, because I have written less than 3. So actually it is gonna run for values 0, 1 and 2. Why I have made this change? Because now in each row there are 3 columns. All right, that is why I have made this change. So this is the general way of working with two-dimensional arrays. So you can write a lot many of programs like displaying the upper triangular matrix, lower triangular matrix. All these are very common problems. You can search them out and write them. In this video series, I just need to focus on C++, so I'll not go to, you know, every nook and corner of working with arrays. So what are functions? So functions are, you know, if you have what I have written over here, functions are a block of code performing a specific task. To what does this means? This means that you want to perform some work repetitively, and if you have to perform that task repetitively in your code, then one approach of solving that problem will be that you write that specific piece of code every time whenever it is required. Or the other approach could be that you create a function, and then whenever you require that task to be performed, you call that function. Okay, so if you're not able to get it, let us try to understand this with the help of some practical example. For example, I have already told you how to find the maximum of 3 numbers using if else and, you know, nested if else. I have already told this program. So program is self obvious. I have to find the greatest of A, B and C, and if A is greater than B, then I will not take into consideration B. I will only then compare, because A is already greater than B, then I will compare A and C, and if A is greater than C, then A will be greatest, else C will be the greatest number. So this is a very simple program to find the maximum among 3 numbers. But is there any specific way by which we can reduce you know, the lines of code, how many number of lines, or the complexity of this code? Is there any way by which we can do that? Yes, there is a way. If you observe, we are finding the greatest of 2 numbers, you know, and this we are doing over here also, this we are doing over here also, and this we are doing over here also. So there is a specific block of code that is being executed, that is required in your program more than once. So why not create a function out of it? And for example, I create a function, and suppose so how do you create a function? First of all, you specify the return type of the function, then you give the name of the function. So suppose I say the name of the function in my case is max, and then you specify the argument list for the function. Suppose there are two arguments. Suppose I will say integer x comma integer y, and this function is very simple. What it does is that it finds the maximum of x and y. For example, if x is greater than y, it return x, else it it returns y. This is a very basic function. I have created this function, and it just finds a maximum of two numbers. Now I don't want to write all this piece of code, so I will remove it. Now, is there any simple and sweet way to perform the same task that we were executing before? Is there any way? Yeah, there is a way. Turns out there is a way. What way is there? I can write what? I can write like this: max a comma max b comma c. If I just write it, for example, if I just write it, see in one line what task I was executing, with writing multiple lines of code. I have just written this one line of code, and it is performing the same task. If you try to run it, you will get the maximum number. For example, if I just go and clean and build this application, and then when I go and run this application, see, you're getting the maximum of all the three numbers. See here, a is equal to 10, b is equal to 5, and c is equal to 8, and the maximum value is what? Maximum value is 10. So it is getting me what? It is getting me 10. And if you are not able to understand how this is functioning, then you can just see, for example, I'll just take the pencil, and so max is a function. So all right, so here I have a function. What is the name of the function? The name of the function is max, and it is taking two arguments, suppose x and y, and it is returning. So the return type is what? Return type is int, and it is returning the greater of what? X and y. So I have called what? I have called max. See, I have called max, and then again I have given what? Max of what? B comma c. So what is gonna happen is that first of all, this inner max will be resolved, and it will give a call to which function? It will give a call to this max function, and it will fetch me the greater of what? Greater of b and c. So in this case, which is greater? C is greater. So it will return me what? It will return me c. So it will eventually resolve to what? Max of a comma c. And now it will compare a and c. So a is equal to what? A is equal to 10, and c is equal to what? C is equal to 8. So it will find the maximum of 10 and 8, and then it will return me what? It will return me 10. So you can see this program, if you just observe this piece of code is very simple to understand, and it's very sweet and simple. You don't have to write you don't have to write code like duplicate code in your program. So it is very simple to understand and debug. And now if you want to find it, for example, if you want to find the minimum, then you can declare, you can create another function. So let us take a look at another very sweet example in which functions use will become very clear. So let me just go to. I have already created this program. This program is basically this. What this program does, I'll just tell you. I'll copy all this, and I'll go to Notepad. Okay, here I go, and I'll remove all this. All this is not required, and I just paste it. So what this program is doing is it is finding the the number of prime. It is finding all prime numbers between 3 and 100. So what? See, between 3 and then between 100. It is finding all prime numbers. So what it is doing exactly is like that. First of all, I need to run a loop from 3 to what? I need to run a loop from 3 to 100. And then I get every number, and then individually I check whether that number is prime or not. So I have already explained this program of finding whether a number is prime or not. See, the num is the number in which I need to find whether it is prime or not, and then this this inner for inside this for loop body, it is just finding whether num is prime or not. Okay, so I've already explained this program, I'll not explain it again, but you can see that this program tends to be little complex, and on first go it is very difficult to see, observe and understand what this program is doing, but you can just observe, like num is taking values from 3 to 100, and in each and every case it is finding whether num is a prime number or whether num is not a prime number. Let us try to run this program. Suppose if I go and clean and build this application, and now if I go and run this application, okay, I think alright, here I just need to add some space. Let us again clean and build this application. Suppose I clean and build it, and now if I go and run this application, it will work fine. Yeah, so it is getting me all the prime numbers between 3 to 100. Okay, there is one is flaw. I think it should be less than or equal to. Okay, here also I need to mention what less than or equal to, because I want to find inclusive all the ranges, 3 and 100 included. I want to find all the prime numbers. Okay, so this is self-explanatory. I'll again try to run it so that output comes out to be verified, and then if I run this program, see, you're getting all the prime numbers between 1 to 100. All right, but now I want to make this program more readable and more understandable. So let us do one thing. Let us create a function, and suppose the name of the function. What the function essentially does is it takes a number as an argument and find whether the number is prime or not. So let me create a function is prime, and this function takes a number as an argument that is of type what? That is of type int, and it returns a char. For example, I say it returns a char as a return type. So what does char means? If it returns a y, then it means yes, that means the number is prime, and if it returns n, that means the number is not prime. Okay, so this is how the program exactly runs. And now what I will do is that I'll just copy all this piece of code. I do not need I'll just tell you, I'll just copy all this piece of code, and what I'm going to do is I'm just pasting it over here, and I check return y, else return, and then I say what? Then I say n. Okay, so let us try to understand this, how this is prime function is working. It is taking a number as an argument. And it is running a loop from which position? From 2 to the number divided by 2. And I have already explained this program. If I completely divides a number, and that means the number is not prime, and for that case we increment the value of count. So if the value of count remains to be 0, then the number is prime, else the number is not prime. See, I'll just quickly demonstrate this. For example, suppose the number is what? Suppose the number is 7, and then the loop will run from what? 2 to what? 2 to 7 divided by 2. That will be equal to what? That will be equal to 3. Okay, so it will run for 2 and it will run for 3, and 7 divided by 2. 7 divided by 2, is this equal to 0? No, it is not equal to 0. It is not equal to 0. Again, 7 modulus 3, is it equal to 0? No, it is also not equal to 0. So the value of count in this case will remain to be what? Count was initialized to be 0, and it will remain to be what? Count was initially initialized to 0. So count in the case of 7 will remain to what? It will remain to be 0. So once it gets out of the body of the for loop, it is checking whether count is equal to 0. Yes, it is equal to 0. That means the number is what? That means the number is prime, and that is why I am returning what? I am returning yes. See, this is the name of the function, is prime, and it is just checking whether the number is prime or not. Else it is returning what? Else it is returning what? N. Let us take another example. For example, I take 8, then the loop will run from what? 2 to 4, and 8 modulus 2 will become what? 8 modulus 2 will become equal to 0. In this case, the value of count will become what? Count will become 1. Then it will run for 3. Okay, 2, 3 and 4. Then it will run for 3. 8 modulus 3 will not be equal to 0. 8 modulus 3 will not be equal to 0. But once it runs for 4, 8 modulus 4 will again be equal to what? It will be equal to 0. So the count value of count will become what? It will become 2 in this case. So again, you know, once it gets out the body of the for loop, it will check count is not equal to 0. So it will return n in the case of what? In the case of 8. So it is going to check whether a number is prime or not. Okay. So I'll just clear all this. And now my task is very simple. What is that simple task? I just need to check this. What do I need to check? I just need to call this function what if what is prime, and is prime what? Num. Is equal to what? If it is equal to yes, then I say cout num, and then I give a space. Okay. See, now which program is more readable to understand? See, now you are able to get it. The loop is running from 3 to 100, and for each number it is finding whether the number is prime or not. And if it is prime, then I am printing the number. So now the program becomes much more readable to understand and debug. See, clean and build. And now when I go and run this application, see, again it is printing the numbers from from 3 to 100 that are prime, but now the program logic is much more simple and it is much more easier to understand this. So the program has become much more modularized, you know, so it has become more modularized and more understandable. So this is what is the advantages of using functions. Okay, so in the next video we will continue our discussion of functions, and we will see what is function prototype, what are formal and actual arguments of a function, and then we will study about the default argument of function. Now in this video we will try to understand what is function declaration or function prototype, and how do we make call to functions. Okay, let us move on to let us first of all see what I have written over here. For example, if I just go over here, so if you just see the third point, function prototype. A function prototype in C++ is a declaration that omits a function body but does specify the name, return type and argument list. So let us try to do one thing. Suppose I want to create a function that will find the sum of two integers. So if it finds the sum of two integers, then it will have the return type as what? It will have the return type of int. Suppose the name of the function is sum, and it will take two arguments. Suppose integer a and suppose what? Integer b. And it finds the sum of a and b. So I will say return what? Return a plus b. So I think this much is very clear. This is just a function, and what is the return type of the function? Integer. What is the name of the function? Sum. And what is the arguments? There are two arguments. One is a and the other argument is what? B. And what are the data types of the argument? Both are of type int. Okay, this much is understandable. Now let me call this function. So I will say sum, suppose 2, 3, and I'll just print out what is the sum of these two numbers. So I will say okay. So I'll just put a semicolon over here and just save the changes. And now if I go and run this application, clean and build, and now if you go and actually run this application, so it is printing when it is getting the sum of a and b. See, it is printing 5. Alright, so this is good, but now what? Let me do one thing. I'll just remove it from here, and I just put it over here. Okay, so now let us try to run this application. See, previously I was putting this sum method, this function, at the top of the program, but now I have inserted it below the main method. Will it give any changes? Will it result in some kind of changes? Let us try to run this application. Clean and build. Yeah, it is giving a compile time error, and sum was not declared in the scope. Why this error is coming? Can you tell me why this error is coming? See, when the compiler is coming to this line of code, it does not find any kind of declaration that is associated with the sum function. Why? Because sum function is declared and defined below from the point where it is called. See over here. So now there is something called as function prototype. So you have to tell, for example, if you have a variable and before giving the variable some value, you declare that variable. Similarly, there is a function, and before you call that function, you can also provide a prototype of that function. So prototype will not contain function body. It is just a kind of declaration that just tells the compiler that such and such type of function exists. So here I can have the function prototype. So I can write sum, and then there is a function sum, and it is taking it is taking just 2 integer arguments, and now I just put a semicolon. So I have not mentioned the body, I have just given the return type, the name of the function, and then I have given just the argument list. Alright, so this is what is called as a function prototype or declaration. See, I have not associated any body with the function prototype. So now if I actually go and run this application, okay, and run. See, now it is going to run fine, and it is giving me, it is giving me the sum of 2 and 3 that is equal to 5. Alright, so this is clear. And now, so this is what you call as function prototype. Okay, so you can verify this third point. Function prototype in C++ is a declaration that omits a function body but does specify the name, return type, and argument list. So this is what we have seen over here. And now let us try to understand about formal and actual arguments. So here if you see, I am passing 2 and 3, and this function is getting called. Which function is getting called? The sum function is getting called. So A is taking the value 2 and B is taking which value? B is taking the value 3, and eventually it is returning what? A plus B, that is equal to 2 plus 3, or it is returning 5. So in this case, these two numbers 2 and 3, they are the actual arguments. Okay, they are the actual arguments, and these numbers which I have declared inside the function body, they are what? They are formal arguments. So I'll just take the pen and I'll just specify them here. If you go, these two. So for example, I can do one thing more. Let us try to suppose integer a equal to 2 and integer b equal to 3, and let us write let us write a and b over here. All right, so now if you just observe, this a and this b, these are what? These are the actual arguments. These are actual arguments, and this a and this b, these are what? These are formal arguments. Okay, all right. And so over here, when you are giving the actual arguments, you do not need to write what? Integer a or integer b. Why? Because you have already told that these a is an integer and b is also what? B is also an integer. And not to get confused, it is not like that. Suppose this variable is having the name a and this variable is also having the name a. So it does not mean that they are the same variable. It does not mean like that. It means that this main function has a different scope. This main function has a different scope, and this sum function also has a different scope. For example, this is the scope of the main function, and this is the scope of the sum function. So what is happening is that there is one variable, that is a variable, and it is equal to 2, and there is one more variable, that is b, and that is equal to 3. And what is happening when you are passing these arguments? When you're passing these arguments to some function, then what is happening? A copy of these functions is being made. So here also a new variable a is being created, that is having the value 3, and here also a local variable b is created, so this is having the value 2, and this is having value what? This is having value 3. So these this a and this a are not the same. They are having different scopes and they are different variables. So this a exists in the scope of the sum function, and this is what you typically call as call by value. Okay, so we will in since in some of our videos also I'll just explain you what is called by reference. Okay, so before starting default arguments, let us try to create one function, and this function is very simple. It takes a character and an integer as an argument and prints that character that integer number of times. For example, suppose the return type of the function is void, and print suppose print s is the name of the suppose I say print sir is the name of the function that prints a series that takes a character c and the number of times this character has to be printed. So I can just what do I write is that for integer I equal to 1, I less than or equal to n, and then I say I plus plus, and then I say cout what cout c. So this function is very simple. It is just printing c. See, it is just printing c n number of times, and then over here I just make a call to the function. What is the name of the function? The name of the function is print sir, and print sir I just want to print, for example, say suppose x, and suppose 5 number of times. All right. Then what? Let us try to run this program and see if it is running or not. Clean and build. And then if I go and run this application, see, it is printing x how many number of times? It is printing it 5 number of times. This is good. All right. So I'll just remove it. But can I write print sir, and I just give this? Suppose I just give a star. I just give one argument. Will it work out? Will it work out? If I try to clean and build this application, will it compile? See, it will not compile. Why it will not compile? Because this function, that is a print ser function, it is taking 2 arguments. One is a character and the other is an integer. But this call to this print ser function, it is just giving one argument, that is just one character. So it will not it will result in an argument mismatch, and it will not find an exact declaration. So what I mean over here is that suppose I mean to say that if I do not supply the second argument, then you just print the character, suppose 5 number of times. So I just need to give a default value to n. Over here I just need to give a default value to n. Suppose I say 5. So now what does this mean? This means then when the value of n is not given, see, in this case when the value is fn is not given, then the default value of n will become what? It will become 5. So that is gonna happen in this case. If I just clean and build and run this application, see, this time it should run. I clean and build this application. And now if I go and run this, see, it is printing star 5 number of times. So over here you see it is printing it 5 number of times. So that means the default, so you can always give some value. For example, I just give the value over here, suppose 20. So then in that case the value of n will stand to be what? It will stand out to be 20. If I clean and build it, that means star will be printed how many number of times? 20 number of times. See, it is getting printed 20 number of times. But if you don't supply the second argument, then the default value of second argument is what? Then the default value of second argument is 5. I can also make a default value of this character. If you don't supply any character, then the default character is star. Okay. So now let us try to run it. For example, I say print sir, suppose I say hash, and then I say print, I just say print sir, and I do not give any argument. Will this program run fine? Let us try to see it. What will be the output? And just I for cout, let us add a new line after every output so that it is more clear to visualize. All right. Okay, let us try to run it. And once when I run this application, See, it is getting it is getting me this output. Why it is getting me this output? If I just okay, if I just take it, then you see this first line, it is giving the first argument is star and the second argument is what, 20. Okay, the second call to print, sir, is just giving the first argument, and then the second argument is defaulting to what? Defaulting to 5. So hash is getting printed 5 times, and then the third call to print, sir, is not giving any of the arguments. So for the character, the default is what, star, and for n the default is what, 5. So this is what is default argument in C++. Okay, so I hope I've made it clear. So today we will try to understand the concept of a classes and an object. So we will try to understand both of these entities, which are the basic framework of any object oriented programming language. Take for example C++ or Java or C# or any other object oriented programming language. Classes and objects are the very basics. So what is exactly a class and what is exactly an object? So whenever you are asked about a class, so you can say that a class is actually used to represent a real world entity. See, in my next slide, I say that a class is a representation or a blueprint of a real world entity. It is just a representation and has no physical existence. So what does this exactly means? It means that you first of all identify your problem statement. Your problem statement is that you want to represent some real world entity. So what can be some kind of real world entity? For example, I just open a notepad and I just ask you, what can be a real world entity? So a real world entity can be anything. You can think about many real world entities. For example, I can say that a student is a real world entity. I can say that an employee is a real world entity. I can say that a fan, my home fan, is also a real world entity. I can say the mobile is also a real world entity, and there can be many number of things. I will just take a few more things, like for example a book. This can also be a real world entity. So my problem statement is that I want to represent these real world entity into my programming language, into my object oriented programming language, and I want to perform some operations on these entities. So I want to represent a student on a computer or through a programming language. So this is my problem statement. So how will I go for it? I will go for it with the help of classes. So what I will do, for example, from the many of these entities, from many of these real world entity, I select one. I suppose I select a student. Then in order to represent a student, I need to design a class. So I need to design a class. And what will be the name of the class? The name of the class will be student. The name of the class will be always student. Over here. So whenever you are asked about real world entities, you just remember two things. Okay. You remember the state of the real world entity and you remember the behavior of the real world entity. What did I say? State and behavior. So over here also, the real world entity is student. So I represented it through a class named student, and now I want to think in terms of the state of student, and then I need to think in terms of behavior of the student. I need to think in these two terms. So whenever you think about state, first of all, let us think about state. Whenever you think about state, you think of some definite kind of variables that can represent student. If it is not clear, then let me say like this. Suppose I say that the student ID is one of the states of student. I say that the name is one of the states of student. I say the email of student is one of its states. I say that his percentage marks is one of his states. So these are there can be many states of student, but these are 4 states of the student. For example, if I take the student ID, the name, the email, and the percentage. So these are all specific states of the student. Now when I talk about the behavior of the student, so there can be many behavior. For example, a student eats in a specific way. A student, for example, I say walks in a specific way. I say the student dances in a specific way. So these are all the behavior of the student. So remember this very basic important fact of designing object oriented classes. Whenever you design classes, remember this very basic important thing, that you represent the state of a class or of a real world entity through member variables, and you represent the behavior through member functions. Like if you see this slide, I have written that in order to represent the state, you need member variables, and in order to represent the behavior, you need member functions. If still it is not clear, then we will look on to it through a very basic practical example. So let me go to my IDE, and I have my main method over here. But now what I will do is that I will design a class. And what is the name of the class? The name of the class is student. Okay, before that, I have taken student, but I can, for the given case, I can take any real world entity. For example, I can take a fan. A fan is also a real world entity. Then I need to identify the state of the fan. There can be many states of the fan. I need to, suppose I say that the color of the fan, the RPM, that is the rotation per minute of the fan. I can say the motor power. Okay, I can say the cost. These are all the states of not a student. These are the states of fan. And then I need to identify the behavior of fan. Suppose I'm talking about a ceiling fan. Then a fan rotates in a specific way. So I can say rotates, and if you are not clear this rotates, I can write something like, something like this. I can write a fan rotates. I can write like this. So in my this entity, when I want to map a fan, the behavior is rotates, and the state is like cost, motor power, color, rotation per minute. All these can be states of the fan. So this is just a kind of very abstract example. It's not a very concrete example. So let us go to the concrete implementation of a class, of how can we represent a class like this. So over here I have taken a class, and what is the name of the class? The name of the class is student. So what I want to do, what is my problem statement? My problem statement is that I want to represent student into my programming language, that is any programming language. For the given example, we are studying C++, so we are representing student in C++ programming language. So first of all, what I need to do is I need to identify the states of students. So what are the state of a student? I say that student ID is one of the state of the student. The student name is one of the state of the student. And for example, I say that that suppose his subject, a student can have subject also. Suppose these are all the three states of the students. These are all the three states of a student. So I'm just taking three states, for example. You can take any number of states. So the student class has three states. And now I need to think in terms of behavior of the student. So what can be a specific behavior of the student? I can write, for example, I can write eat, and I can write like this: see out, a student is eating. Or a student can dance also, so I can write something like this also. Suppose a student is dancing. So these are some of the behavior of the student, specific behavior of the student. A student eats in a specific way, a student dances in a specific way. So these are all the specific behavior of the student. So in this way I've represented the student class. So in C++, you remember this very important thing, that whenever your class ends, you terminate a class by a semicolon. Okay, this is something that is specific to C++. So over here I have written this semicolon when my class terminated. Which class? The student class. The student class. This class terminated. Okay, so this is basic of a class. So just repeating on the fact, these are my two instance functions, member functions, and these three are my member variables. Okay, so now what I'm going to do is that I'm going to design an object of the class. So you must have heard about objects also. So what is an object? So before trying to understand object, one more thing I would like to state. And what is that one thing? If you go to this slide, you will see a class is just a representation and has no actual physical existence. You see, class has no actual physical existence. So what does this exactly means? This means that when I am designing my class, say suppose I am designing my student class, then this class itself, you know, it is not occupying any memory. It is not occupying any memory, and it does not have any actual physical representation. Okay, but it is just, you know, it is not occupying any memory, but it is just a kind of representation, and it is just trying to represent the student. It is just trying to model the student, but actually it has no existence. It has no physical existence. It is just a representation. But when we talk about objects, then objects have actual physical existence. Okay, so if you go to this slide and you just see object, an object is an instance of a class, and objects actual have physical existence. So what does this mean? So we will try to understand this thing little graphically. So tell me, what is the name of the class? The name of the class is student, and I create an object of the class. Suppose the object of the class is S1. So this is very basics of C++. Whenever you want to design an object of the class, you write the name of the class followed by the name of the object itself. Okay, like this. And to make things little simple, I'm going to write the public accessibility modifier over here. Public accessibility, I will explain this in more detail in my coming lectures, but let us be very clear that public accessibility modifier means that all these member variables, these three member variables, and these three member functions, or all the member functions and variables of the class, are even accessible outside the class. So here I will write s1.id is equal to, say suppose 1, s1.name is equal to s1.sid. It's not id, it is sid. Suppose s1.name is equal to Nikhil, and s1.subject is equal to, say suppose, theory of computation. Yeah, it is like little big name, so I will just write it small. Suppose Java. Alright, let us be little small about it. So so these three are the student S1. So S1 is an object of class student. It is an instance of student. It has its SID 1. It has the name Nikhil, and it is as a subject Java. So what does this mean? So in order to understand this, I will go to the paint, and we'll just try to understand it with this very basic thing through some graphic representation. Suppose it is like this. So over here, so this one see, this object is allocated somewhere in the memory. The name of this object is S1, and this represent the student ID. This represent the student name, and this is gonna represent the subject. Okay, so this object has been allocated somewhere inside your memory. Suppose this is the boundary which you are seeing is like suppose a memory, your RAM, and inside this RAM somewhere this object has been allocated. This object, what is the name of this object? The name of this object is S1. The SID is 1, the name is Nikhil, and the subject is Java. Alright, so this way somewhere in memory this object has been allocated. So one more important thing, let us return to my NetBeans ID. Whenever you access a member variable or member function through an object, you always use the dot operator. For example, here I'm accessing SID, the student ID, through the object S1. So I will use the dot operator. If I want to access the name, then I will use the dot operator. If I want to use the subject, I will use the dot operator. If I want to use even the member functions also, like this, for example, I say S1 dot eat, then also this is a member function, then also I need to use the dot operator. So this is very clear. I'm not going to run this program right now. This is just making you try to understand what is exactly a class and an object, and a relationship between a class and an object. But what I'm going to do over here, I'm going to create another object. Suppose this class has another object S2. How can this class has another object? Yeah, this class can have many objects. But what does this in real term means? This in real terms means that suppose you have a class, and in that class you have 30 students. That means you will create 30 student objects. Is it clear? You will make 30 student objects. But does that mean you will make 30 student classes? No, you will not make 30 student classes. You will only make one class, and of that one class there will be 30 objects. For example, in this example, we have one student class. See, we have not made 2 or 3 student class. We have just one student class, and in this one student class I have created 2 objects. This is the S1 object and this is the S2 object. And now I can say something like this also. For example, suppose I just copy this and I write it over here, and I say to, suppose the name of this student is Nitin and his subject is suppose Android. So what will this mean? This will mean exactly in the same lines. This will mean, for example, this will mean something like this. Yeah. So it will mean that another object, this object name is S2, and this object also has a ID, it has a name, and it has a subject. For example, this has an ID of 2, it has name Nitin, and it has subject. What is the subject? It has subject Android. Okay, so if you take this example, this is the student ID, this is the name, and this is the subject. Alright, so we can also, so this student S2 object is also allocated in the memory, S1 is also allocated in the memory, but they have different copies of ID, name, and subject. You can see S1 has the ID of 1, whereas S2 has the ID of 2. S1 has name Nikhil, whereas S2 has name Nitin. So that means every object will have its own copy of member variables. Okay, this is very important concept. You need to, because these are the very basics of object-oriented programming. I will just write this very important concept. What is this concept? Every object has its own copy of instance variables. When I say instance variables, that means member variables. So in this case, this means that SID, name, and subject, these are all my instance variable or member variables. S1 will have a different copy of SID name and subject, and S2 will have a different copy of SID name and subject. See, I am trying to explain these things in little details. Some people who are very conversant with object-oriented programming, they will find these things redundant. But if you are a starter, then I'm trying to explain in the perspective of a starter who is like just starting, trying to understand C++ programming language. So S1 has a different ID name and subject, S2 has a different ID name and subject, and I'm also repeating things so that it fixes on your memory. You are clear through it. So I think this statement must be very clear in your mind that every object has its own copy of instance variables. Okay. So like this. So we have understood the very basics of classes and objects. In my next video, we will try to actually implement a class, and we will try to actually call some instance methods of the class. Okay. So in the last video lecture, we saw what were classes and what were objects. How do we represent a class? How do we create an object? All these concepts we saw. We also saw how objects are allocated in the memory, and how we access the member variables and member functions through a object. These all concepts we saw in the previous video lecture. But now let us go to actually implement a class. Okay, so here you see I have one class. I have already one class which we saw in the previous lecture. Suppose this is a student class. We are going to create some more classes so that the concept of classes becomes clear. But we'll just start with student class. So here, this is the student class, and I will make this. I will not use this. I will write the public accessibility modifier over here. So when I write the public accessibility modifier over here, it means that subject name and student ID, they no longer are public. Whatever I write after this public accessibility modifier, that members will be public. So for example, if I say eat and I say cout the student eats, if I write like this, then, and over in this main method I create an object of the class, suppose S1, student class S1. Then I cannot access student name. I cannot access the name of the student. Why I cannot access the name of the student? Because name is private. But I can always access the method eat. I can access this method because eat is a public method. So if you are not clear to understanding this, if you are not getting this, just you can just wait for some time. Once you go on to design one or few or more classes, then these concepts will become more clear. But here let us design few instance methods. For example, I say that set data. This is one method, and void show data. This is one more instance method, and all these methods are these are all public methods. So I want to set the data of students. So setting the data of students, I mean that I want to set the student ID, I want to set the name of the student, I want to set the subject of the student. So how will I do it? I will say it's something like this. I will say cout please enter the ID of student. Okay, I will say like this, and then I will say cin, and I will say SID. Then I will just copy it, and I will write like this. Please enter the name of the student. Please enter the subject of the student. Here I will write the name, and here I will write the subject. This way I am going to write, and the output becomes more clear. I am just going to write the new line markers after all this. So this saying like this, and I am just going to copy it and inside this show data method, the show data method is used to show the data of the student. So here we can write something like this: the ID of the student is cout SID, and then we can write something like this: the name of the student is suppose cout name, and cout subject of the student is like this. So we have created two methods, set data method and the show data method. This is my set data method and this is my show data method. So what is this set data method doing? The set data method is doing is what it is creating. It is setting the data for the object. So over here I have the object, and what is the name of the object? The name of the object is S1. So let us first of all try to do one thing: s1.show data, like this. Just I have not done anything. What two lines of statement I have written inside this main method? I created an object and I have just called the show data method. Just try to see what will be the output of this. If I run just this very basic application, what will be the output? I'll just clean and build it. And oh, there are some errors. Okay, I got it. Yeah. Alright. Okay, I'll just save them, and I will clean and build it once again. And then let us see what will be the output of this program. Build successful. And if I just go to run this, what will be the output? You see the ID of the student, it is not giving any ID. The name of the student is blank. The subject of the student is also blank. So what does this mean? This means that if you go to the actual representation, I will open a new, I will not save all these changes. I will open a new paint. And inside this paint, first of all, let me create an object. So whenever you say student S1, so the first line is going to allocate an object. And what is the name of this object? The name of this object is S1. Okay. So here, if you go over here, what is the name of this object? The name of this object is S1, and S1 has ID, it has a name, and it has a subject. So here, if you go, so right now what thing is that you have not given any specific ID, name, and subject to S1. So this this ID is having some default, some garbage value. For example, 2, 0, 1, 2, 5, 6, 7, whatever be the default value. This is null. This is also null. You say this is null, means this field is empty. It doesn't contain any value. So right now we have just allocated S1, but the ID, name, and subject, the ID, name, and subject, they have not been given any specific values. So now what I do is that, so if you just show data, if you use this method show data, then show data will give the ID, name, and subject of S1. But the SID of S1 is, you know, a kind of garbage value, and name and subject are null. So before moving forward and before trying to explain things, again, I would like to give a very important concept. You must remember this concept, and I write one line and you make this line very clear. Inside a member function, the member variables always belong to the current object. So this is, you know, this is one very important statement. I am not taking this statement from a book. This is all what I've learned actually working on object oriented programming language. So this is may not be very syntactically or grammatically correct, or it is not taking from a very standard book, but you just try to understand it. What I mean if I say like this, I mean, suppose I say that this is my member function. Set data is a member function. Similarly, show data is also a member function. And inside this member function, set data, I am accessing member variables. I am accessing student ID. I am accessing name. I am accessing subject. Then to which object this SID will belong? To which object this name will belong? To which object this subject will belong? The answer is that inside a member functions, the member variables always belong to the current object. So over here, if you see, I called the show data method through the S1 object. So when the show data method gets called, the current object is the S1 object. The current object is the S1 object. So when I write SID over here, that means the SID of the current object. And what is the current object? It is S1. In the previous lecture, we also saw that the member variables, every object has its own copy of member variables. Okay, that means if there are three objects, S1, S2, S3, then S1 will have different SID name in an object, S2 will have different SID name in an object, and S3 will have different SID name in an object. But over here, I have called the show data method through S1. That means the current object is S1. That means when I refer SID inside show data method, that means the SID of S1 object. When I refer the name inside this show data method, which has been called through S1, that means the name of S1 object. So over here in this paint, if you see, when I initially allocated the object, the SID has some garbage value and name and subject are null. That is why you are getting this output. The ID of the student is this, the name of the student is null, the subject of the student is also null. But now what I do now is that S1 dot set data. I call this method S1 dot set data, and then I call the S1 dot show data. So when I call the set data method also, this is also instance method. That means whenever I am accessing SID, whenever I am inputting SID in this method using the extraction operator, the scene through the scene or the extraction operator, that means the SID of S1 is being set. Or over here I am using in name, that means the name of S1 is being set, or for in this example the subject of S1 is being set. So over here, if I just go and run this application, clean and build successful. Okay, yeah, now if I go to run this application, I just go and now I run this application. Please enter the ID of the student. I say set the ID is 1. Please enter the name. Suppose I say the name. Please enter the subject. I say the subject is Java. The ID of the student is 1. The name of the student is Nikhil and the subject is Java. Just this is this. I will just make some formatting changes. I will remove this. I will write like this, so it becomes more readable. This output is not readable. I will remove this also, and I will write subject, and then I will write like this. Now if I go to clean and build, and now when I run this application, let us try to understand what will be the output. Run. So I run this application and now it is asking me for the SID. I say the SID is 1, the name is Nikhil and the subject is Java. You see the ID of the student is 1, the name of the student is Nikhil and the subject of the student is Java. Alright, so what does this mean over here? This means that this S1 object is allocated, and once you call the set data method, inside this set data method, when I am calling the in SID, that means the SID of S1 is being set, and to what value this is being set? This is being set to 1. So I will just erase this. Okay, and inside this what I am going to write? I am going to write over here I am going to write 1, the name is Nikhil, and the subject is Java. This is the subject. So this object has been allocated. So please ignore my handwriting. I am using paint, so handwriting is not very good, but I think it is clear. So this S1 object has SID1, it has name Nikhil, and it has subject Java. Alright. Now if I say I create one more object, and suppose another object, I'll just copy this code and I will write this like this over here. This is for S2 object. Alright. So inside this object, inside this code, I allocate another object. I use the s2.setData, and then I use s2.showData. So here I can write like this, showing s2 data, and here I can write cout showing S1 data, like this. Yeah, okay, good, like this. If I write like this, then what is going to happen? What is going to happen now if I run this application, if I clean and build this application, like this, and then I go to run this application. Please enter the ID of the student. So we are entering the ID of S1. I say 1. Please enter the name. Suppose I say Nikhil. Please enter the subject. Say suppose Java. The showing S1 data. The ID of the student is 1. The name of student is Nikhil, and the subject of student is Java. Again, now it is asking for S2. Please enter the ID. Suppose the ID is 2. Please enter the name. Suppose the name is Nitin, and suppose the subject is Android. Showing S2 data, the ID of student is 2, the name of the student is Nitin, and the subject of student is Android. So what does this mean? This means that you have allocated another object, which we saw in the previous example. Now this object remains to be S2 object. This is the S2 object, and over here if I go, so this means that this is your S2 object. Inside this object you have the ID, you have the name, and you have the subject. The ID is 2. This is Nitin, and the subject is Android. This is the subject. So this means you can see now you can also have got the actually the proof that these two objects you saw by this example. When you actually run that, S2 has a different ID, it has a different name, and it has a different subject, and S1 has a different ID, it has a different name, and it is a different subject. That means every object will have a different copy of member variables. Is it clear? This thing must be very clear. And when whenever inside a member function I access that member variables, they always belong to the current object, what I wrote over here. I think this should be very clear. Now so here so in this class, if you see, there are 3 member variables and there are 2 member functions, the set data and the show data member functions. Suppose I create one more member function. Okay, I will not create another member function now. In my next video or in the same video also, I can continue with designing some other class. So this class is clear. Now suppose what I do is that I just remove it. I remove this code. I remove this class. Okay. Let us go on to design some other class so that the concept of classes become clear. I design a class and the name of the class is, say, suppose the complex class. So when I say the complex class, I want to represent the complex number through that. So when I say a complex number, so you have to first of all think in terms of the state of the complex number. For example, the state of the student were its ID, name, subject. But when we talk about complex number, then the state is every complex number has a real part and every complex number has an imaginary part. So these are all the states of the complex number. Then I will go to the public that means that every member function I want to make them public. First method that I am going to create is set complex. Set complex integer I comma integer r, and I say like this: real equal to, this is the r, and this is I. Real equal to r, img equal to I. This is the set complex method. And then I design one more method, show complex, and the show complex method, suppose it says something like this: cout real, and then show complex method. So here I have created a complex class. So let us go to create an object of the complex class. Suppose I say that the complex class C1. So the object of the complex, I created one object of the complex class, that is C1, and that means C1 will have a different copy of real and imaginary part. Then I say C1 dot set complex. Suppose I set the complex real part to be 3 and the imaginary part to be 4, and then I say C1 dot show complex. I call this method also. So over here, if I go to clean and build this application, what will be the output? Let us see the output. I'm just going to run it. See, the output is 3 plus 4i. So I have displayed the complex number. So this is, I think this is also very clear. If it is not clear, then I will just open a new. I will not save these changes. I'll be a little fast this time because I have already explained these concepts. Over here, if you say something like this, this is the real part and this is the imaginary part. The real part is 3 and the imaginary part is 4, like this. Okay, so this is the real part and this is the imaginary part. This is the object, the complex object. The name of this object is C1. These are all the member variables of this complex object. And over here, if you go here, this is the real part and this is the imaginary part of the complex object. So this is how we actually represent a complex object. And what I can do is that like the previous example also, I can create many objects of the complex class. So for example, I have created one object. I can create another object. Suppose the name of this object is C2, and I say the C2 dot show complex, C2 dot set complex, C2 dot show complex. I say that for C2 the real part is 5 and the imaginary part is 7. Then when I call the C2 dot show complex, what will be the output? Just see. I am just going to clean and build this application, and I'm going to run this application. So once when I run this application, you see the output is 3 plus 4i. This is the C1 object output, and this 5 plus 7i, this is the C2 object output. In this video lecture, we will try to understand the concept of encapsulation. So what is encapsulation? So before trying to understand encapsulation, let us try to understand this concept with the word itself, what the word suggests. So if you think of encapsulation, then you can think in terms of a capsule. So let me do one thing. I will not save this. I will draw, can you guess what I will draw? I will draw a capsule. So what does a capsule looks like? A capsule looks like this. You know, I'm talking about those capsules that doctors give you generally. So inside a capsule, you have some
you have some, you know, some medicine inside the capsule. This is, suppose this is a medicine that is inside the capsule. So this is a capsule. So what is important? This is the medicine that is inside the capsule. This is the medicine, and this is the outer cover. This is the outer cover of the capsule. So what is important? Of course, the medicine is very important, and that has to be protected, and the outer cover is just there to protect the medicine, you know, to protect the medicine so that it does not get spoiled, it does not becomes harmful for the patient who takes it. So from this example we can understand the concept of encapsulation. In encapsulation also, when we talk about the concept of encapsulation in OOPS word, then in OOPS word we have to protect, like in this example we are protecting the medicine that is inside the capsule through the cover of the capsule. In encapsulation also we do the same thing. We try to protect our data members and data variables of the class. How we try to protect the instance members and instance functions of the class? Let us look with the help of this example. So I will do one thing. So before trying to, let us try to understand the literal definition of encapsulation. The literal definition of encapsulation says that encapsulation is an object-oriented programming concept that binds together data and functions, that manipulates the data and keeps both safe from outside interference and misuse. So what is exactly this outside interference and misuse? Let us try to understand this concept. So over here, I have a class, and what is the name of the class? The name of the class is student. So in C++, there is, so you must be knowing, so encapsulation is implemented, encapsulation over here, it is implemented through the use of accessibility modifiers. So what are accessibility modifiers? Accessibility modifiers like the private accessibility modifier, the public, and the protected accessibility modifiers. So we will try to see and understand the accessibility modifiers in great details when we go to inheritance. But over here, just let me state that private accessibility modifier states that all those member functions and member variables, those are private, can only be accessed within the class, and public means that they can be accessed from even outside the class. And there is one more important thing that is very specific to C++. I will write it down on a notepad. The default accessibility modifier in C++ is private. Okay, so what does this mean? The default accessibility modifier in C++ is private. So over here, if you go, I have declared 3 member variables in the student class, but I have not declared any accessibility modifier. That means the default accessibility modifier is private, which means that student ID, student name, and subject are all private. And I will show you. For example, if I construct an object of the student class, I have constructed an object of the student class, but now suppose if I try to access the name of student, suppose if I try to access the name of student, and I write something like this, cout s1.name, cout s1.name. If I try to, you know, this is showing a compile time error. If I try to clean and build this application, what will be the output? You see, it is not building. You see, and there is also the student name is private. This is private, and this is what I told you exactly. If the default accessibility modifier is private, so if we have not given any accessibility modifier, explicitly stated any accessibility modifier in this class, that means student ID, name, subject are all private. But now let me do one thing. Let me make all of them public. And how will I make them public? I will write something like this, public. Now the student ID, name, subject are all public. And now suppose again I run this application, clean and build. You see the errors have gone, and now you can see build successful. That means it is compiling without any errors, without any compile time errors. That means when the name is public, it can be accessed even outside the class. See, this is my class boundary. This is my class boundary, and I can access the name even outside this class boundary in the main method. Now, I can do something like this. What can I do? S1.name equal to say S1.name equal to say, suppose a very famous actor in Bollywood film industry, say suppose Amitabh. Okay, and then I say cout S1.name. Then what will be the output? Clean and build. I think this is very clear. This is very simple. It will just give the output as Amitabh. If I run this application, Amitabh. Okay, you will see Amitabh over here. So this is no issues right now. There are no problems with this particular piece of code, but there can be some specific problems with this if I write my class like this. What can be the problem? There can be some specific problems. For example, I make one more change. I declare the age of the student also. Okay. Now what I do, I say that the name is, say suppose la 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 la. Okay, this is the name, and I say s1.age equal to, say suppose -21. I say like this. Okay, suppose I don't say I say, so I will just use a very slang language. Suppose if a person is not very intelligent, you say them he is a fool, but there is no person whose name is fool. But I say that the name of this object, that the name of this person who is represented by the object S1, his name is fool, and his age is -21. Age is always positive, it can never be negative, but I have given the age to be -21. Now what I will write is, I will say the name of the person is like this, a new line marker, and then I'll copy this code and I'll write something like this, age, and the age of the person. Will this particular piece of code compile? Yes, it will compile, it will run, but just see what will be the output. I will just clean and build this particular piece of code, and then I will run this application. It is working, but over here you see the name of the person is fool, the age of person is -21. But how come this is syntactically correct, but it is absurd in real world? There is no person whose name is fool, and there is no person whose age is negative. So you see over here that my ID, name, subject, which are the members of class student, are not secure, and that is what is the principle of encapsulation stating us. It is stating that you make all these member functions and variables which are present inside your class, you make them secure from outside use, and from outside the class I am setting some values of name and age which are not at all viable. So I need to protect my class member variables and functions. I need to protect them. So how can I protect them? One way, of course, to protect them is that you make them all private. I make them private. But if I make them private over here, then again there is one problem. What is the problem? Because I make them private, I cannot access them from outside the class. So if I cannot access them from outside the class, no one from outside can set some absurd values to these member variables. So but how then can we set these member variables and functions? We can do it through the use of public setters and getters. Always remember what I have written in this site. I have written in this slide is that encapsulation is implemented through the use of accessibility modifier. Principle of encapsulation suggests to keep member variables of a class private and member functions that manipulate them public. So what does this exactly means? These are my member variables: age, subject name, student ID. These are my member variables. These all have to be declared private, which I have written over here. If you go to the third point, principle of encapsulation suggests to keep member variables of a class private. And then what should be kept public? What should be kept public? So all the member functions that manipulate these member variables, they have to be declared as public. So over here I say void set name. There is one suppose I say like this, and name equal to n. Okay. Suppose first of all, let me do one thing. Let me design one method, void show student. This is one method, and inside this method I am going to display the whole data of student. How will I display the data of student? I will write something like this: cout the SID of student is SID, and then new line marker. I'll copy this code and then I'll paste it 4 times. Okay. The name of student, the subject of student, and then the age of student. Over here also I will write the name of student, the subject of student, and then the age of student. So I have designed the show data method. This method is used to display the details of every student, show student method. Okay. Now in this I'm using the principle of encapsulation. So the principle of encapsulation states that I don't make these member variables public, I make them private, and the functions that manipulate these member variables, I make them public. So here what I do something like this: string get name. So generally it is done through the use of getters and setters. Return name like this. I'll just copy this, and these subject s, subject equal to s, first of all, just let us stop at this at just over here. Now just observe this code. Just observe this code. Now I have made the name private. So I cannot access the name from outside the class. If I write something like this, s1.name, which I have already shown you, if I write something like this, then this will give a compile time error. It will not work out. So if I have to if I have to access a name, then I will use this get name function. This is the getter function for name. If I have to access a name, and if I have to set the name, then I will use this setter function. How will I go for it? Like for example, suppose I say that s1.set name. Suppose I set the name to be Amitabh. And then I say cout s1.get name. I say something like this. Okay, over here. Now what will be the output? I think the output will be very clear. How the output will be there? I just clean and build this application, and I run this application. Just see the output. Output is of course very obvious. It is Amitabh. If you are not able to understand this, then I'll just explain this. s1.set name. I have passed the parameter as Amitabh. This parameter is collected in this variable n. This is an instance function, and inside this instance function, name is set to the value of n. N is Amitabh, and a name, this name belongs to the current object. What is the current object? The current object is S1. That means the current object's name, that means S1 name is set to Amitabh. And then once I say get name, the get name is returning the names. Whose name? S1's name. And what is S1 name? It has already been set to Amitabh. So this returns Amitabh, and this is I am printing on my console. The console outputs as Amitabh. Okay, so this is what has been done till now. But over here, so here also you can see I can do something like this. I can do something like this. What I have done before, I can say s1 dot set name full, s1 dot get name, and then will this application run? Of course it will run. Clean and build, and then I run this application. You see the name has been declared again as full. This is what we were trying to prevent. Previously we were setting the member variables private so that no one from outside the class can set some absurd values to these variables. But again we have seen that inside these setter inside these method I can again set some absurd value. So how can we protect the class? This is a very important question. Still we can protect the class with the help of these member functions. How can we go for it? Just see with the help of this example. Here I have said that the name is so what you can do inside these member functions, you can write some application logic. Suppose if I say like this, if n is equal to, suppose I say full, if n is equal to full, then I can say cout not a proper name, else I can say name is equal to n. So this is the advantage of using member functions. You can write some application logic that can protect your member variables. Inside member functions you can write some application logic to protect your member variables. That is why you generally make your member functions as public. So here you see, now again I run this particular piece of code. So here I clean and build this application. Build successful, and I run this application. What is name? Okay, so it is just outputting not a proper name. When I'm setting the value of name to be full, it is saying not a proper name. But if I set some proper value, say I say suppose Neha, this is a proper name. I set, so Neha is a proper name, so I am not doing any kind of check against Neha in my setter function. So over here, if I go and build this application and I run this application, so it is displaying Neha. But again, if I have some absurd values, then you cannot do it. Then similarly it is the case with it's a case with age. Age can never be negative. Suppose my school policy, suppose all these students belong to a school, and the school policy states that the school never takes any student who is below 3 years of age. So I can do something like this. What I can do, I can create a setter function for age, set age, and suppose the age is passed in a parameter a. Now I can check it. How I can check it? I can say if a is less than or equal to 3, if a is less than or equal to 3, cout not a proper age. Okay, else I can write age equal to a. Okay, this is my setter function for age. I just here you go. Okay, just making this code more readable. Alright. So you are checking, whenever you are setting the age inside this member function, you are checking if age is less than 3. If age is less than 3, you are not setting the age. If when age is only greater than 3, then only you are setting this age variable over here. Similarly, I can also design a getter for the age. How? So age is of type integer, that is why the return type of this method will be int, and then I will say get age, and inside this get age function I will say return age, and then I will design the setter and getter for my SID also. So how will I design the setter and getter for SID? I will just copy this. SID is of type int. So when you will design the setter, you will say void set SID, and SID of type int, that is why it will take a parameter of type int s. And how will I set SID equal to, say suppose s, and integer get SID. Inside this method I will just write return SID, okay, like this. So here you can see this is a this is proper. So the basic advantage of using member functions is that you can write some application logic inside that can be checks, so that your member variables are protected. So they are the, I will just write comments, setters and getters for subject, for name, sorry, these are the setters and getters for name. Just copy it. These are the setters and getters for subject. These are the setters and getters for age, and these are the setters and getters for SID. Okay. So what I have done over here, if you look at this class as a whole, what I have done, all these member variables I have declared them as private, and suppose name is over here, name is private, but if I want to access name from outside the class, then I will use the setters and getters of name. If I want to set the value of name, then I will use the set name function. Suppose s1.setName Amit, Vishal, Neha, whatever name you want to set. And if you want to get the name of what is the name of the current object, then you will use the getName function, s1.getName. So this is the concept of encapsulation. Okay. So over here I have stated also the principle of encapsulation suggests to keep the member variables of a class private, and the member functions, just see the third point, and the member functions that manipulate them public. Okay. So over here you can see these set name, get name functions are manipulating name, so I have made them public. Similarly it is the case with age, subject, name, age and SID. So you can write some application logic inside your member functions to protect the member variables. Okay. So this is the concept of encapsulation, and encapsulation is implemented by the use of accessibility modifiers, the private and the public accessibility modifier. So in this video lecture, we will see the concept of how can we, how can we pass objects to a member function, and how can we return objects from a member function. Of course, we will study this concept in greater details when we study copy constructors, when we study assignment operators, and we will see them in more details. But here I'm just trying to explain you this so that it becomes clear and we can proceed on to you get an understanding so that you can move forward, because there will be of course some classes in which I will be using this concept. So in my previous lectures I have designed the complex class, and inside this complex class I have already shown that there are two member variables. These are the real and the imaginary part, because any complex number is composed of real and the imaginary part. And see over here also I have declared real and imaginary, what the concept of encapsulation states, what we have seen in a previous video lecture, real and imaginary. So real and imaginary are declared to be private, and the member functions set complex and show complex, which manipulate them, which operate upon real and imaginary parts of the complex number, are declared to be public. Okay, so this way I have designed this class. And now suppose I say I declare an object of the class. What is the name of the class? The name of the class is complex. I declare an object to be C1, and then I say C1 dot set complex. I declare the real part to be 1, the imaginary part to be 2, and then I say C1 dot show complex. So what will be the output of this program? 1 plus 2i. If I go clean and build, and then I run this application, see the output is 1 plus 2i. Real part is 1, the imaginary part is 2. But now let me design one function. Suppose I want to add two complex numbers. So here I declare another complex number. Suppose this complex number is C2. Okay. and this complex number I initially set the value, suppose yeah, okay, over here I say suppose C2 is something like this, C2 dot set complex. Suppose the real part is 3 and the imaginary part is 4. Okay, so like this. So over here when I say I write comments like this: cout showing C1 data and new line marker and Control Z, copy this piece of code, and again showing C2 dot, okay, C2 dot show complex. So if you just clean and build this application and you run this application, the output is very simple. You can almost guess it. Showing C1 data, it is 1 plus 2y. Showing C2 data is 1. Showing C2 data is again 1 plus 2y. Why? Because I have written C1 dot show complex. I should write over here C2 dot show complex. Okay, like this. So this is very clear. But now what I want to do, I want to add these two complex numbers. So you must be aware of some basics. You must have studied it in your class 12. I have studied. So if you want to add two complex number, then their real part and imaginary part are added individually. So if you add these two complex number, then the new complex number will be 4 plus 6i. The sum of the real part is 4 and the sum of the imaginary part is 6. So this way I want to add these two complex numbers. So I will design one method, add complex. This is my method. What will be the return type of this method? Because I am adding two complex numbers, and the addition of two complex number will also result in a complex number. That is why this add complex method will return a complex number, or an object of class complex. And I take an argument inside this, suppose I say complex C, and I write something like this. So what does this piece of code means? How can I call this method? This method has a return type of complex, and it is taking an argument of type complex. So how can I call this method? I can call this method by doing something like this: C1 dot add complex, and inside the argument I will pass C2. So what will this particular piece of code means? If you just see this line if you see, which I am highlighting, C1 dot add complex C2. So over here, if you call this method through C1, which method will be called? The add complex method will be called. And what is the current object? The current object is C1. The current object is C1, and we can test it out also. You see, if I write cout, suppose I say real, and I give a space, and then I say imaginary. If I do something like this, then what will be the output? Clean and build. Okay, it is taking some time to build, but you can guess the output. The current object is C1. So when you write cout real, the real part, whose real part? C1 real part or C2 real part? The current object is C1. That means it will display the real imaginary part of C1. If I run this application, then it will display what? It will display 1 space 2. So 1 space 2 is belonging to C1. And if I write something like this, C dot real and C dot imaginary, if I write something like this, then what will be the output? I am not, over here I'm going to comment this code so that the output is more, you get more proper output, properly formatted output. I just clean and build this code and I run this application. Okay. So now it will display what? It will display 3 plus 4. 3 and 4 belong to which object? It belongs to C2. Now I have passed this object C2 as an argument in this add complex method, and this is collected in another complex object C, and again the real part of C becomes 3 and the imaginary part becomes 4. Here a very important concept that has to be kept in mind, that this passing of object is a kind of pass by value. It is not pass by reference. What does this mean? Let us try to understand this. So I will just draw two boundaries. This is my first boundary, and this is my second boundary. Okay, these are two boundaries. These are two boundaries, and inside this boundary there are okay, like this. Okay, so this is the scope of main method. This boundary represents the scope of your main method. All right, and this is the scope of your add complex method. This is the scope of your add complex method. So inside the main method you have declared two objects, C1 and C2. These are the two objects that you have declared in your main method. And now in the add complex method, when you are passing this C2 object, then this C2 object is not passed as a whole. A copy of this object is created. And this is called as C. Suppose over here you see, if the C2, if you take C2, then the real and imaginary part of C2 are 3 and 4. So that means over here, if you go over here, this C2, if you just go over here and you see the real and imaginary part, the real part is 3 and the imaginary part is 4. So this object is copied into the scope of add complex, and a new object is created and its real part is 3 and the imaginary part is 4. Okay, so it is like this. Of course over here C1 real part is 1 and the imaginary part is 2. Alright, so I just want to highlight this, that this is actually called by value. It is not called by reference, and we can test it out also. How we can test it out? Suppose okay, so I will not test it out right now. To make things simple, I will not test it out right now. I will just first of all try to show you how can we add these two complex numbers. So inside this inside the scope of this add complex method, I will declare a complex object temp. Okay, and then I will say temp dot real equal to real plus c dot real, and temp dot img equal to img plus c dot img, and then I will return which object? I will return the temp object. Okay, and then I will declare another complex variable. Suppose the complex variable is C3, and then I will go on to write something like this: C3 equal to C1 dot add complex C2, and then okay, like this. I will just copy this piece of code, I will paste it over here, and I will just remove the comments. And I want to display the data of not C1, I will not display the data of C2, in turn I will display the data of C3, the third complex object which stores the sum of C1 and C2. First of all, just run this application, then we will try to understand what is exactly going on behind the scenes. I clean and build this, and then I run this application. Okay, so the output is 4 plus 6i, and that is what we saw. If I add C1 and C2, the output complex number will be 4 plus 6i. But what is exactly going behind the scene? When you are using C1 dot add complex C2, that means you are going inside this method. The current object is C1. That is why we saw that we can access the real part of the current object by using just real. And if you want to access the real part of the object that is passed as an argument, which argument? The C argument. Then we will use the C dot real. So I have created a temporary object over here, and temporary object real part is set to real plus C dot real, and imaginary part is equal to the imaginary part of the current object plus the object that has been passed as an argument. And then in turn I return this temporary object. So what is going on behind the scene? This is what is going behind the scenes. when you go to the add complex method, inside this add complex, another object temp is created. This is the temp object that has been created, and this is the sum of C and the current object. So C, it will result in 4. The real part will be 4 and the imaginary part will be 6. And then what is the last line? The last line of this add complex method is return temp. So you are returning this object. Which object? This temp object you are returning. And when you are returning this, you are collecting it in the scope of your main method. And in which object you are collecting it? You are collecting it in C3 object. That means the contents of this temp object will be copied into which object? The C3 object. The contents of temp object will be copied into the C3 object. Like when we call C1.add complex C2, then the contents of C2 were copied into this C object. Similarly, when we return this temp object, the contents of the temp objects will be copied into this C3 object. So the C3 object real part will become 4 and the imaginary part will become 6. So once when I display C3, the output will be very clear. It will be 4 plus 6i. So in this way, we saw that this method has a return type of which returns an object, and it takes an argument which is also an object. So when we will see the concept of the assignment operator and the copy constructor, then we will try to then we will explore this example in greater details. What is exactly happening? There are some more intricacies that is involved with it, so we will see that also. But for right now, for your understanding, this much part is clear. So I'll just end this lecture. So what are constructors, and how are constructors are called? Why do we create constructors? What are the intricacies of a constructor? All these concepts we will cover in the upcoming video lectures on constructors. So before trying to understand constructors, let us try to understand the need behind constructor. So what I have done, I have designed a class. This class we have already seen, the student class. I have designed the student class, and let us make one change. Let us make the student ID and name private, and then there is one method. What is the name of that method? That instance method is the show student method, that is just displaying the details of the student. Okay, so this much class I have designed, and now if I run this application, I will go clean and build, and then I will run this application. Just see what is output. The student SID is -13120, and the student I'll just make change. There's a syntactical change. Student name, the student name, the student SID is the student name is okay. All right, so it's a typo error, so please forgive me for that. I'll just go and run this application. Now output will be clear. Okay, so let us see what is the output. The student SID is -13120, and the student name is, it is not displaying anything. That means the student name is null. So if you see, we created this object. Which object? The object of the class student, the S1 object. But we have not initialized the object to proper values. Initializing the object to proper value means that you initialize the object. What is initialization to the object? So what is initialization to object? Just try to understand this with the help of this example. Suppose I open new, I'll just open a new window, and I'll just try to show you with the help of this example. Suppose this is brush. So this is my memory, and now one object has been, when you write student S1, one object has been created, and this is the S1 object, and the S1 object has the ID value as 13120, and this value is null. It does not contain anything. So we need some mechanism by which we can properly initialize the object at the time of creation. And what does initialization means? Initialization means that we will have proper name and proper ID for the student object in this specific case, or given the case for any object. You design any class and you create an object of the class, you want to properly initialize the object. So for doing that purpose, to properly initialize the object, you will use the concept of constructors. Okay, so over here, if I go and I'll go to my PowerPoint presentation and just try to understand what are constructors. So we will go through this slide point by point. So constructors have the same name as the name of the class, and constructors have no return type, and constructors are used to initialize an object. What do all these things mean? Let us take first 2 points. Constructors have the same name as the class, and constructors have no return type. So there is my class. My class name is student. So here I design a method, and the name of the method is, say, suppose student. So this is not an ordinary method, my dear friends. Now it is a constructor. Why it is a constructor? Because it has the same name as the name of the class. What is the name of the class? The name of the class is student. And what is the name of this method? This method name is also student. Sorry. That is why now it is a constructor. So I write in something like this: the student, the student constructor has been called. I write something like this. Then what will be the output of this program? I will just comment out this piece of code. Okay, now you go to the presentation. Constructors have the same name of the class, and constructors have no return type. So here also you see, like this method, the show student method, this has a return type of void. But am I associating any return type with this? No, I am not associating any return type with student this. So this is a constructor. It has no return type and it has the same name as the name of the class. That is why it is not an ordinary member function. It is a constructor of the class. And if you see the fourth point, this point, which point? This point. Constructors are called implicitly. Sorry, constructors are called implicitly when the object of the class is created. That means you do not have to give a call to a constructor. Constructors will be called automatically whenever you create an object of the class. For example, over here, if you see, there was one method. Which method? The show student method. You had to make an implicit call to this method. How did you make? By the use of dot operator. You wrote the code s1.showStudent. You made an implicit call to show student. But this constructor, you don't have to make like in the show student method, you have to make an explicit call, not an implicit call. I'm sorry. You may have to make an explicit call to call the show student method. But for the student, this constructor, you don't have to make an explicit call. It is called implicitly. And when it is called, whenever the object of the class is created. Okay. If you are not clear, then let us see what is the output of this program, and things will become more clear. I will just clean and build this application. It is taking some time. So all these concepts will help you in your placements, in getting a solid understanding of object-oriented programming. I'm making these concepts. Just let me explain. So what my purpose in making these videos is that to make things simple, I take a lot of time. I go very slowly so that concepts become very clear to students, so that I am basically targeting beginners who want to learn things. Okay, so just let us go to the output. This was on a side note. I'll just run this application. The student constructor has been called. Why the student constructor was called? Because we were creating an object of the class, and once we created an object of the class, an implicit call to the constructor was made, and the output, and what we wrote inside the constructor, the student constructor has been called and that was displayed as an output. Okay, this is our program. Now suppose I do one more thing. I copy this particular piece of code, I copy it, I paste it, again I paste it. Now what I am doing, trying to do over here, so student is a class and class can have many objects. So I create 3 objects of the student class. So can you guess what will be the output of this program? I think you can guess it. I will clean and build this application and then I will run this application. Okay. The student constructor has been called how many times? It has been called 3 times. Why it has been called 3 times? It has been called 3 times because we have created 3 constructors of the class. And we saw in our PowerPoint presentation that whenever we create an object of the class, the constructor of the class is implicitly called. That is why when we create 3 objects of the student class, the constructor call to the constructor was made 3 times and the student constructor has been called was displayed 3 times on the screen. So this is the so I think now this point is clear. Constructors are implicitly called when an object of this object of the class is created. But now there is one more important thing. Constructors are used to initialize an object. How constructors can be used to initialize an object? So for example, I want the student has a SID and the student has a name. Previously we saw over here that the ID and the name were getting garbage values. So we don't want this. We want to properly initialize the object at the time of its creation, and for that purpose I will use a constructor. So how I will do it inside the body of a constructor, I will just write the code for it. Okay, so for the time being I'm just going to remove these 3 objects. Yeah, and then inside the student constructor I am going to write something like this: integer s and string n. And what should I write over here? I will say SID equal to s, and name equal to n. I'm going to write something like this. Okay, like this. Yeah, clear. So now I create another object of the class, suppose student class s1, and inside this student class I pass suppose 21 comma webhub. Okay, so I will not pass webhub, I will pass Krishna. Okay, let us take some names of God to in our programs. Let us try to run this. Clean and build and run. The student constructor has been called, but now I will write one more piece of code and I will say s1 dot show student semicolon. Now what will be the output? Clean and build. And now I run this application. You see, the student constructor has been called, and then once I call the show student method, the student SID is 21, the student name is Krishna. How come this is possible? This is possible because you called the constructor was called when you created the object, and you passed 2 arguments to the constructors. One argument was the name and the other argument was the SID. And inside this constructor also you initialize SID to S and you initialize the name to N, and S and N were containing the values 21 and Krishna. So on a side note, I would just like to make things clear, I would again like to say that this SID and name belong to the current object. And what is the current object? The current object over here is S1. That is why when we say SID and name, whose SID and whose name? SID and name of S1 object that has been set to 21 and Krishna inside the body of the constructor. That is why we are getting this output. The student ID is 21 and the student name is Krishna. Okay, so this is the output. So we covered 4 points. What 4 points have we covered? Constructors have the same name as the name of the class. We saw over here also that we created one constructor and the name of the constructor was student and the name of the class was also student. Constructors have no return type. I have not associated any return type over here. Constructors are used to initialize an object. Yes, constructors has been used to initialize this object S1. Then SID has been set to initialized to 21 as the name has been initialized to Krishna. Okay, and constructors are implicitly called when the object of the class is created. So what was my class? The name of my class was student and I created an object of the class. What was the name of the class? What was the name of the object? S1. Whenever I created the object, the constructor was implicitly called. I did not had to make an explicit call to constructor. It was automatically called. So this is the important concept of constructors. Okay, so yeah. So in the next video we will see how can we overload constructors, what are default arguments in a constructors, what are parameterized constructors. All these things we will see in the next video lecture. So before trying to understand static member variables, let us try to understand the very need behind creating standard static member variables. Okay, so let me go to my IDE and yeah, over here. So I have created a very basic class. This class you have already seen. I have created a student class and student has a SID, it has a name and it has marks. These are the overloaded constructors of the student class. Okay, and this is the show student details method. For example, if I create a student object of the student class, suppose I create an object S1, I give it a ID 1, I give it a name, say suppose Nikhil, and then I give it a mark, suppose 91. Okay, I say like this, and then I say s1 dot show student details. I say like this. Okay, so this is my main method, and what will be the output? It is pretty obvious. Return 0. Okay, I write like this, and then I run this application. Okay, clean and build. And now I run this application. See what is output. Yeah, just to make the output more formatted, I will just insert new line markers over here. Alright, now I go to clean and build this application, and then I run this application. Alright, let us this is very simple. I think this is all we have seen till now, so there are no issues with this program. I think I do not even need to explain what is happening over here. It is just outputting the details of the student object. Okay, so let us try, in order to be very clear about it, let us try to understand this with little graphically. We will try to understand this. Suppose this is my memory in which object are created. This is the memory, or you can say this is the RAM. Okay, this is the RAM. Okay, this is the now I have created an object, and this object is the S1 object. Okay, I have created one object. This object is the S1 object. It has the ID 1 and it has the name Nikhil, and it has marks 91. This is the S1 object. Okay, and now I will create another object, and this is, say, suppose the S2 object. So how will I create the S2 object? I will say something like this. Copy, and then suppose this is my S2 object. Suppose his name is Vaibhav, and his marks are, say, suppose 85. Okay, and then I call the s2.show details. Okay, so now what is the story till now?
the story till now that one more object has been allocated, and this is the S2 object. One more object has been allocated, and this is the S2 object. So how is the S2 object? It is something like this. This is the, you see, this is the S2 object. It has ID 2, it has name as Nitin, and it has marks as 85. This is my S2 object. Okay, so now it is clear. Till now the story is very clear. I think there are no confusions with this. Okay, S2 object. All right. Now I want to have one more information regarding all the students. I want to have information about the class teacher. Okay, so I am going to write string teacher over here, and then I will write something like this, string t, and then I will write teacher equal to t, and then I will write I will just copy it and then I will paste it. The teacher of the student is teacher. Okay, like this. Now if you observe, suppose all these students belong to the same class. Suppose all these students belong to the same class. So if they belong to the same class, they will have the same class teacher. Suppose I will say something like this. His class teacher, Nikhil's class teacher is also Anita, and Nitin's class teacher is also Anita. Okay. So what will it look like? It will look like something like this. Suppose this is my S1 object. This is my S1 object, and inside the S1 object, he is going to have the class teacher name as Anita, and similarly Nitin also will have the class teacher name as what? It is going to have the class teacher name as Anita. Okay, like this. So so now if you think that if there are 50 students in the class, if there are 50 students in the class, then also they will have the same class teacher name. What will be the name of the class teacher? Suppose it is Anita. Okay, or for example, I say suppose I want to have the principal's name, and there in a school, say there are about 3000 students. I create 3000 objects, and everyone will have the same principal name, whatever may it be. Okay, so this is not a very good or a very clever design. See, this Anita is common among all the objects of student class. So why don't I do one thing? What do? I do one thing very simple. I try to do one thing. I do not place this Anita over here. I do not place this Anita. I do not make Anita belong to every object. I do not make Anita belong to every object. Like this. I remove this, and I do something different. What different do I do? I do something like this. I do something that I make somewhere Anita somewhere outside the place where S1 and S2 are allocated. I will take the brush, and now I will allocate Anita somewhere outside S1 and S2, and suppose here it is Anita, and it is shared by S1 also, it is shared by S2 also. Similarly, if there are some other objects of the class, it will be shared by all objects of the class. So Anita is common amongst all objects. Why? Because they are all students object, and all the students have the same class teacher. Okay, so from here comes the concept of static variables. See, instance variables belong to the object. Instance variables belongs to the object. Why instance variable belongs to the object? Because every object will have a different copy of instance variable. For example, this object, S1 object, has an instance variable marks that is different for Nikhil, that is 91, and S1, the S2 object has also an instance variable 85 that is different for Nitin, and that is 85. Okay, so there are instance variable belong to the object, but static variable do not individually belong to object. They belong to the whole class. Okay, so from here comes the concept of static variables. See the first point. What does the first point says? The first point says that static member variables belong to the class, and static member variables are shared amongst all objects of the class.
Okay, so now over here in my IDE, I am not going to create this variable like ordinary variable. I am going to make it static. Okay, so once I make it static, it does not belong to any specific object. Every object will do not have the different copy of teacher. Teacher variable will be shared by all objects of the class. Okay, like this. So now this member variable teacher is now a static member variable. Okay, it is a static member variable, and it belongs to every student of the class. Now if you go to this presentation, then you go to the third point. Static member variables are declared in the class and then defined outside the class. Global scope in the format, data type, class name, and then the static variable name. What does this mean? So my dear friends, a class, I already told you, a class is just a logical representation. It does not allocate any memory. Okay, but we saw that static member variables have to be allocated somewhere have to be allocated some memory. Okay, for example, if you see over here, this Anita, this is the class teacher, the name of the class teacher over here. If you go, okay, like here this variable Anita, it has to be allocated somewhere. That means I have to declare the static variable outside the class. So over here, when I am just defining the static variable, because a class cannot allocate any memory, but I need to allocate some memory for my static variable. That means I need to define the static variable outside the class in the global scope. So how do I do it? I do it in this format. I do it in this format. I give the data type, I give the class name, and then I give the static variable name, and then I can initialize it also. How? Like this. I go over here. So over here my class is ending. You see, here my class is ending. So outside the class, I will write the data type. What is the data type? The data type is string. What is the name of the class? Student. Then I give the scope resolution operator, then the static variable name, and then I initialize it to, say, suppose Anita. So over here I have what I have done. Here I have defined the static variable. Okay, here I have defined the static variable. Now yeah, so see out the teacher name is teacher. Okay, and then give a new line marker after that. All right, now if I run this program, what will be the output? I run this program, clean and build. Oh, there are some errors in the program. Okay, yeah. These constructors are taking 3 parameters. Previously, okay, now. Alright, now I clean and build this application. Suppose I run this application. See, the student this student has a SID of 2, it has name web of, it has marks 85, but its class teacher name is Anita. Here also you see the class teacher name is Anita. That means this Anita, the class teacher, is shared among all the students of the class. So it is a static variable of the class. Now I do something very interesting. I create one method, void change teacher. Suppose I want to change the name of the teacher, suppose T, and then I say like this, teacher equal to T. I say like this. Okay, change teacher. I have created one instance method, and that is a change teacher. Now I do something like this. Since S1 change teacher is an instance method, I say S1 dot change teacher, and I change the class teacher to be, suppose, Govind. Suppose now the class teacher is Govind. Okay, what will happen? I will again write this, copy, and I will again write this. Okay. Yeah, before writing this I will write something like this: showing S1 details. Okay, and a new line marker, copy, paste, showing S2 details, and then again I will write showing S1 details, and I will paste, I will write showing S2 details. Okay, like this. Now if I run this application, what will be the output? You see, clean and build. And now I run this. Sorry. I opened the debugger, you know, just my mistake. I run this application. What will be the output? You see, initially the teacher name was Anita. Over here also the teacher name is Anita. But then I called what? I did what? I called this instance method change teacher, and what did I did? Change teacher, and I gave the value to be Govind. And then you see, for both S1 showing S1 details, the teacher name is Govind, and for S2 also the teacher name is also what? It is Govind. So now you got an idea. The idea is, over here if you go to Paint, why this is happening? Because now when you call the change teacher method, the teacher was no longer Anita, the teacher changed to be Govind. So here if I go, the teacher name has changed, and what is the name of my new teacher? It is Govind. So for both S1 and S2, the teacher name is Govind. Okay, like this. Yeah. So what we have seen about static member variables: static member variables belong to the class. We saw in the previous video in the student class that every student will have the same copy of the class teacher. So they belong to the class. Static member variables belong to the class, and they are shared amongst all objects of the class. And static member variables are, you know, they are declared in the class. That's a kind of forward declaration, and then they are defined outside the class. So now over here, I have created one class, my class, and for the sake of convenience, I have used the public accessibility modifier and have declared two variables, the A and the A and B. So A is an instance variable, and B is a static variable. A is an instance variable. So if A is an instance variable, A is a instance variable, so it will belong to object. Okay, all objects will have different copy of A. All right, and this B is a static so it will be shared amongst all objects of the class, like this. Okay, so this B is a static variable. It is just defined over here. It is just declared over here in this, so I need to define it. So how do I define it? I define it by first writing the data type, then writing the name of the class. The name of the class is my class, and then I write B, and suppose I say that B is equal to 10. All right, like this. Now if you go to this PowerPoint presentation, static member variables belong to the class, and static member variables exist when no objects of the class has been created. So now in the main method, have I created any objects of the my class? No, I have not created any object of my class.
but still the static variable is going to exist. How you can see like this. Suppose I write my class and then I write the name of the static variable. Okay, like this. Yeah, I suppose I clean and build this application, and then I run this application. See, 10, the output, it is coming out to be 10. That means I have not created any object of the class, but still the static variable is existing. Now what I do, I create objects of the class. Suppose I create one object m1 and I create another object of the class. Suppose I create the m2 object. I say m1.a equal to, say, suppose 20, and m2.20, and then I say m2.a equal to, say, suppose 30. I say like this. Okay, and then I issue some print statements. How do I do like this? Cout m1a is, I write something like this, m1.a. okay, and then I copy it, I paste it like this. m1b is m1.b, and then I copy all of this and write something like this. Okay, I write m2 over here, I write m2 over here also I go, I write m2 over here also I go, I write m2. Okay, and then to make the output more formatted, I am going to write the new line marker. Over here also I am going to write the new line marker, and over here also I am going to write the new line marker. Okay, so what will be the output of this program? If you have just observed, what will be the output of this program? Now I clean and build this application, and then I run this application. m1a is 20, m1b is 10, m2a is 30, and m2b is also what? It is m2b is also 10. That means the b object, that is the static object, is shared between m1 and m2. Now we have verified this point, that static member variables belong to the class and static variables exist even when no objects of the class has been created. See, initially I just made it clear that I created no objects of the class, but still the static variable was existing. Now and static variables can be accessed in different ways. I can access the static variable by using the name of the class like this, using the scope resolution operator, and then by writing the name of the class and then scope resolution and then the static variable. Or I can access the static variable by using the objects. Over here, if you see m1.b, and then I have accessed the static variable m2.b. Now suppose what I do, I change the static variable. Suppose I change it to 5. m1.b equal to 5. Then I go and I copy all of this and then I paste it over here. Okay, like this, I paste it over here. And then now suppose if I run this application, clean and build, then I run this application. See, m1a is 20, m1b is 10, m2a is 30, m2b is 10, and then I have changed. What I have changed? I have changed the b to be 5. That means m1b is also 5 and m2b is also 5. If you are not, I have already explained it, but still if it is not clear, then let me explain it like this. I will just open a new paint, don't save, and then if you see like this, okay, here I have one variable, that is the m1 variable. This is the m1 object, and it has a that is equal to 10, and okay, it is equal to, initially I have set it to see 20 and 30. Okay, so if I go to paint and this this a is equal to 20, and there is one object that is this is equal to 30. Okay, this is the m2 object and it's a equal to 30, but there is one shared variable, that is the b variable, that is the shared, and has a value of 10, and it is shared by m1 and m2 both. It is shared by m1 and m2 both. I can access this b variable by using the name of the class. How I can access it? What is the name of my class? My class. Then using the scope resolution operator and then writing the name of the static variable. Now what I did, I changed the value of the static variable. How I did it, I made it equal to 5. So instead of 10 b, the value of b changed to what? It changed to 5. So when it changed to 5, the value over here became what? It became 5. That means m1's b is also 5, and when I access b through m2, then also the value is 5, and so the value of b has now become 5. Because why? Because b is a static variable. Okay, so this is very clear. I think I have made it this clear just to give up just to make static variables more clear. I made a little elongated presentation, and you just make this point very clear. A is an instance variable, so it will belong to the object. All objects will have a different copy of A. And B is a static variable, so it will belong to the class. And then all objects will have the same copy of, okay, like this. Alright, so I think I have made static variables clear. I'm just going to revise these points. Static member variables belong to the class. I have already told they are shared amongst all the objects of the class, how they are declared and how they are defined, and static variables exist even when no objects of the class has been created. And static variables can also be accessed by the name of the class by using the scope resolution operator. So these are the important points regarding the static member variables. In the next video lecture, we will try to understand the static functions, how static functions work. That static member variables belong to the class, or they are shared by all the objects of the class. We also saw the example that suppose there is a student class and every student object has the same class teacher. Then the class teacher, I make the teacher as a static variable that will be shared by all the objects of the class. That we saw. But we can also have, like, there can be instance variable and instance functions. Similarly, there can be static variables and static functions also. Okay, so what I do over here is that first of all I minimize this and I just go to my IDE, and inside this IDE you can see I have a class. What is the name of the class? The name of the class is my class. Okay, I have created this class, and this class has a member variable, that is A, and it has a static variable. And what is the name of the static variable? The name of the static variable is B. Okay, so you are able to get it. Now what I do, first of all, I create two functions inside this class. Suppose function 1, and I write something like this inside: cout inside function 1. Okay, and then I write a new line marker and I just end it. Okay, and then I copy it and I just create another function, and this is the function 2. But this function 2 is a special type of function because it is a static function. It is a static function. So what I will write over here, I will write something like this: in static function 2. Okay, like this. So whenever function 1 will be called, inside function 1 will be printed to the console, and when function 2 will be called, inside static function 2 will be printed on the console. Now what I do, so first of all, let me go to my PowerPoint presentation. What is the first point? The first point states that static member variables belong to the class. The second point says that the static member functions can be accessed from the name of the class using the scope resolution operator. Okay, so if I go to my IDE, and inside this IDE, if you observe, function 2 is a static function. That means it can be accessed from the name of the class. How? You see, function 2. I can access function 2 like this. And if I go and run this program, what will be the output? Clean and build. And then I go and run this application. Suppose if I run this application, what will be the output? You see, inside static function 2. But can I, so that means now what I do is that I don't access function 1. I don't access function 2. I access function 1. What will be the output of this program? Suppose I go and clean and build this application, and then I run this application. You see there, the run it is failing, because so what is it is writing over here, cannot call member function without object. Why? Because function1 is a member function, it belongs to a object. So whenever you need to call function1, you need to create an object of my class. For example, suppose I say that I create an object of my class. Suppose what is the name of the class? M1, my class, and then I create an object of my class M1, and then I can call which function? I can call function1. But I cannot call function1 like this, because function then because function1 belongs to the object, but function2 is a static function. That means it belongs to the class. If it belongs to the class, then it can be called by the name of the class, by the help of the name of the class itself, by using the scope resolution operator, what we have done over here. And we can also call function2 from M1 like this. You see, I can do something like this also. Suppose I write like this, then what will be the output of this program? If I go just and yeah, so I will create M1 with an argument. Suppose you say I pass argument 10, because you see in this my class there is only one constructor, and that is taking one argument. So whenever I need to create an object of the class, I need to create an object by passing one argument. Because I have inserted a constructor in this class, we saw in the previous tutorials for constructor, we saw that if we create a constructor in the class, then it is not the responsibility of the compiler to insert a default no argument constructor. Okay, like this. So so you see, I called the function2, which was a static function, in two different ways. One was by using the name of the class, what I have written over here, and one by the name through the help of the object of the class. So if I just go and run this application, you see what will be the output. Clean and build, and then suppose I go and run this application. Okay, like this. You see inside function1. Why inside function1? Because over here I am calling m1 dot function1. So when I call function1, inside function1 is called, and when I call function2, inside static function2 is printed, and then when I call m1 dot function2, inside static function2 is printed on the screen. Now what I will do? I will do something very special. Say suppose I create another object of the class, and this is the m2 object, and I pass the value of 20 inside this while creating this m2 object. That means for m2 object, this constructor will be called, and what will be the a of m2? It will become 20. So if I go to some pictorial representation, so I will just open a new paint window. I don't want to save these changes. So so what will happen? Let us try to understand this pictorially, and then you will understand about static function. Suppose I say that this is my memory boundary. This is my RAM inside all objects, inside which all objects are allocated, and there is one object. There is one object, that is the m1 object, and there is another object, that is the m2 object. Which object? The m2 object. Okay, m1 object is having the value of a as 10, and then m2 object is having the value of a as 20. Okay, now I just forgot to do one thing. Because b is a static variable and it is just declared over here, what we saw in the previous video, I need to even define the value of b. So how will I go for it? What is the data type of b? It is int. Then what is the name of the class? It is my class. Then I will write the scope resolution operator b, and suppose I say that b is equal to 5. Okay, I write something like this. Now what is the picture over here? The picture over here is something like this. B is a static variable of the class. That means b is shared by both the objects of the class. Okay, so b is shared by both the objects of the class. This is what we have seen. Okay, the value of b is 5 and it is shared by both the objects of the class. Okay, now my dear friends, I am going to write something like this inside my function 2. Suppose I write this something like this: see out the value of a is Okay, I write something like this and I just print a, and then I give a new line marker. I write something like this, okay, inside function 1. And just make a note that function 1 is not a static function, it is a member function. So I will just go and comment out this code. Alright, when I call m1.function1, when I call m1.function1, then I clean and build this application, and then I run this application. Okay, so what is the output? Inside function 1, the value of a is 10. The value of a is 10. See, the value of a is coming out to be 10. Now I call this function 1 with m2 object. So this function 1 is a member function, it belongs to the object, so it can be called by either m1 or it can be called by either m2. Okay, so I run this application, and what will be the output? The value of a is 20. Why the value of a is 20? Because this is a member function, and inside the value, if it inside this function 1, if I print a, then this a will belong to the current object. Over here the current object is m2, and for m2 the value of a is 20. That is why it is giving the output something like this. The value of a is 20. But now, my dear friends, what do I do? I copy this piece of code and I just paste it over here. Okay, now it is already giving a compile time error. This will not work. But can you tell me the reason why this will not work? I will just give you the problem statement. What is happening over here? I am trying to access an instance variable, a member variable inside a static function. Okay, what I am trying to do, see, a is a member variable, it is an instance variable, it belongs to the object, and I am going to access that instance variable inside a static function. So it is giving a error. Already you can see it is marked red. So I will just go to the PowerPoint presentation, and you make a note of this very important point. It is commonly asked in interviews that static member functions cannot access instance members of a class. Why is this happening? Why is this true? This is true because, my dear friends, this is true because, you know, this function, suppose this is the static, which function? Static function 2. This is a static function 2. Now I am accessing a inside this static function. What I am accessing? I am accessing a inside this static function. Now this, so now if you are accessing a inside a non-static function, then it refers to the current object. But here you have created two objects of my class. So this a can belong to this object also, m1 object also. This a can belong to m1 and m2. So compiler is not able to decide which version of a it needs to call. So just keep this thing in mind, that you can never access an instance variable in a static function, because instance variables belong to the object and there can be many objects of the class. So static function, because static function belong to the class, they cannot decide that which version of the member variable it needs to call. Like in this case, m1 and m2 both have a. m1's a is 10 and m2's a is 20. So inside static function, if I write print a or cout a, then which a? It can belong to m1, it can belong to m2 also. So my dear friends, this is very important. Just keep this thing in mind. This particular piece of code will not work. What particular piece of code? This particular piece of code will not work. You can never access a instance variable inside a static function like this. Alright, but one thing can be done. See, cout the value of b is, suppose I write something like this, and then I write b, and then I write a new line and marker. You can always access a static variable inside a static function. Okay, static variables can be accessed in a static function. Why they can be accessed? Because, you know, when I say, suppose this is my static function over here, if I go and now this is my static function, and now I want to access the value of b. So b is shared by all the objects of the class, so it is definite that it is referring to this b, because there is only one copy of b, so it is referring to the one b that has the value 5. Okay, so keep this thing in mind that static functions can only access static variables of the class. Alright, like this. So over here, if I go and suppose I comment out this particular piece of code, I comment out this code also, and now suppose I write my class, then the scope resolution operator, and then I access, say, suppose function 2. Okay, and then suppose I am calling function 2. So inside function 2, what will be the output? First, the first output will print inside static function, and the second output will print the value of b is, and I have initialized the b to be 5. So over here, if I go and clean and build this application, and now suppose I go and run this application, the value of b is 5. So inside a static function, you can only access static member variables. You can never access instance variables inside a static function. Why? Because there can be many objects of the class, and every object will have a different instance variable. Okay, but there is only one static variable that is shared by all the objects of the class. Okay, and static functions also belong to the class. All right, so over here there is one particular very important, very common use of static variables and static functions. Suppose I want to keep a track of how many objects of the class have been created. So how will I go for it? So I will create a static variable, and that is the count variable. Okay, and then this is just the declaration of the count variable. We saw inside the class static variables are only declared, but they are defined outside the class. How they are defined? What is the name of the class? It is my class. Then I will use the scope resolution operator, and the value of, and then suppose the variable is count, the name of the variable is count, and I will initialize it to 0. I will initialize this variable to 0. Now whenever an object of a class is created, the constructor is called. Okay, whenever you create an object of the class, you call the constructor. So I want to keep a track of how many objects of the class have been constructed. So I can write this very simple basic code. Suppose I write something like this, count plus plus. So what does this mean? This means that whenever you call the constructor, the value of count will be incremented by 1. So by this you can keep a track of how many objects have been created up till now. Okay, so I create a static, suppose I create a function, static function. Suppose the name of the function is obj count. Okay, and inside this I write something like this, till now count objects of my class have been created. Okay, I write something like this. Now I save this. Now you see I have created two objects of the class. Okay, and then I call suppose m1 dot obj count, and then I create another object of the class, suppose the m3 object, and suppose I initialize its a to 30, and then I call the m1 dot obj count, object count, like this. So what will be the output of this program, my dear friends? What will be the output? Can you guess the output? Yeah. So you just go. Initially the static variables will be initialized, the value of count will be 0. So if I go to this paint over here, I'll just clean this. I'll take a new, I will not save all these changes. So what is happening over here? Something like this is happening over here. Suppose this is my memory. Okay, yeah, over here if I go, and suppose I say that this is the memory, this is the memory in which your objects are allocated, and inside this memory there is one object. What is the name of this object? This is the M1 object, and it has value of a as 10. There is a M2 object, and it has a value of a as 20. And then you have initialized one variable b, that b is having the value of 5, and then you have initialized, there is one static variable count that is having initial value as 0. Initially, I'm sorry, initially I will just go line by line, so I will not create these objects. We will go line by line, and then we will create these objects, and then we will see what is going to happen. Okay, so I also erase this. Alright, no, I erase this also. Sorry, I just created them. Okay, now, so let us process what has been written in the main method line by line. I'll just go to the NetBeans IDE, and inside this you first see this line, my class M110. So that means their object, that an object is created. What is the name of the object? M1 object. Okay, so if it is something like this, an object has been created, and what is the name of the object? It is the M1 object, and M1 object, and it has the value of a as 10. Now my dear friends, whenever an object is created, the constructor of the class is called. So a matching parameterized constructor is called. So over here I have declared this constructor, and inside this constructor the value of a will become 10, and the count will be incremented by 1. Since count is a static variable, that means now the value of count will become what? It will become, initially it was 0, but now it will not be 0, it will now become 1. Okay, then I create another object. What is the object? It is the M2 object, and the M2 object is having a as 20. But now again, when M2 will also be created, the constructor will be called. Once the constructor will be called, the count will be also incremented by 1. So till now we have created two objects, the M1 and M2 object, and the value of count is 2. So this count is keeping a track of how many objects have of class my class have we created till now. So suppose I go and then I clean and build this application. Yeah, build successful, and then I go and run this application. Okay, so you see, okay, there is some yeah, so over here, suppose I just, for to make the output more clear, I will write something like this. Okay, now clean and build, and then I go and run this application. So it is, till now 2 objects of my class have been created, and then till now 3 objects of my class have been created. So first, when you call the obj count object count method using M1 object, so till that point 2 objects were created, the M1 object and the M2 object. So that is giving the object count to be 2. Then you create another object, the which object? The M3 object. So once when you create the M3 object, situation will become like this. One more object will be allocated, and it's, what is the name of this object? M3 object. Its a is 30, and now again the constructor will run, and inside the constructor I am increasing the value of static variable count. Okay, so something like this. So then it is giving the output as, till now how many objects have been created? 3 objects have been created. Okay, so something like this. So yeah, so I think I'm done with this video lecture. Just one more important change. I have already told this, but I am calling is through M1. I can also call it through the name of the class. Why? Because obj count, if you observe, obj count is a static function, so it can be accessed, it belongs to the class, and it can be accessed by the name of the class itself. So I can write this code like this also. Okay, scope resolution operator, and then if I save this and then run and clean and build and run this application, the output will remain to be the same. Okay, So I run this application. Alright, till now 2 objects of my class have been created, till now 3 objects of my class have been created. So output is something like this. Okay, so you can just have a look at the program. I'll just revise it quickly. So I created one member variable, 2 static variables, and this was a constructor, and then this was a member function, but these 2 were static member functions. So static member functions, because they belong to the whole class, they can only access static member variables. Static member functions can never access instance variables of the class, and static member functions can be called by the name of the class, like what we have done over here, or we can also call static member functions through objects of the class. So before studying this pointer, let us try to understand what are pointers and what is an object pointer. Okay, like this. Suppose I go to my IDE. Where is it? It is over here. Okay, so I have a class. What is the name of the class? The name of the class is box class, and in this box class I have 3 instance variable: the length, breadth, and the height. These are the 3 instance variable, and then there is one constructor which is used to initialize the object of the class. So this is a very simple class. Okay, the box class, and we have already discussed this class. So inside this box class, let me do one thing. Let me create an object of the box class. Suppose I create an object of the box class 2, 4, 5. Suppose I say like this. This is an object of the box class. Now I create a pointer to the box class. Suppose I say like this, box pointer p, and I say like this, p is equal to address of b1. P is equal to address of b1. So what will this mean? What will this particular piece of code mean? Let us try to understand this graphically. So I will go to paint, and inside the paint the current situation is something like this. Suppose suppose I say that this is your memory, and inside the memory somewhere the box object has been allocated, and what is the name of the object? b1, and it has 3 variables: the length, breadth, and height. And what the values? The values are 2, 4, and 5. So I can write 2 over here, 4 over here, and 5 over here. Suppose this box object is allocated at the memory location 2025. Then p is having the value, p is a pointer, and it will contain the address of b1. So what is the address of b1? 2025. So p is a pointer to the object. P is a pointer to the object. So whenever you have a pointer to an object, you access the instance variable and instance functions of that object through the object pointer by using the arrow operator. So use the arrow operator. So over here, suppose I do something like this. I design a method void calc volume to calculate the volume of the box. And what is the volume of the box? Cout length into breadth into what? Length into breadth into height. Okay, so this is the volume of the box. I can write something like this also. The volume of the box is length into breadth into height. So this is the volume of the box. Now over here, suppose I want to access the volume of the, so this volume, this method, the calc volume method, this is a instance method. So that means it belongs to the object. So whenever I want to access instance variable or instance functions through object pointer, I do it with the help of a arrow operator. So here, if I write something like this, suppose I write that p arrow calc volume. So what will it mean? So over here, p is a pointer to the object and calc volume is an instance function. So I use the arrow operator. Which operator? Arrow operator, to access the calc volume method. See, if you are just accessing the calc volume method through the object, then you will use the dot operator, calc volume. But if you are accessing it through an object pointer, then you will use the arrow operator. See over here, p is a object pointer. It is a kind of object pointer. That is why we are using the arrow operator. So I just go and comment this piece of code because we have already seen this. I am just going to clean and build this application. being successful. And then just let me go and run this application. It's taking some time. Yeah. So okay, I generally do this mistake again and again, but it's a kind of I just format the output properly so that the output program is running, but output is not very clear and very obvious, clean and build. And okay, and then I run this program. What will be the output? You see, 3 arguments constructor for the box class has been called. Why this was printed on the console? This was printed because we created an object of the box class, and whenever you create an object of the box class, the constructor was called, and inside the constructor we printed this 3 argument constructor for the box class has been called. And then we created an object pointer p to the box class. Let's see, p is containing the address of b1, which is the object of the box class, and then we can access the calc volume method of the box class by using the what operator, by using the arrow operator. Okay, so I can write something like this. Notepad. We use the arrow operator to access the instance variables and functions of a class. We use arrow operator to access the instance variables and functions of a class through object pointers. Okay, so when we have object pointers, then through object pointers, if we want to access the instance variable and instance functions, then we use the arrow operator. So here we have used the arrow operator. How we have used the arrow operator? P arrow calc volume. Okay, so this is clear. So I have just briefly explained what are object pointers and how can you access the instance. See over here, if I write this length, breadth and height to be public, suppose I write them to be public, so they are now public. So if they are public, then they can be accessed from outside the class. So I can write something like this also. Suppose I write p arrow length. I can do something like this also. Okay, because length is an instance member of the class, and to access the instance member of a class through an object pointer, I will use the arrow operator. So this is clear. Now we can turn on to the discussion of what is a this pointer. So you can just go to this presentation and you can look at the, this is a keyword in C++, and every instance variable and constructor is implicitly passed a pointer to the current object known as the this pointer. So what will this mean? Let us go to this class, my box class, and inside this box class I have a method. This is the instance method. Okay, so I have written every instance. Okay, so there is one every instance, not variable, every instance method and constructor is implicitly passed a pointer to the current object known as the this pointer. Okay, so over here, if you see this calc volume method, this is the instance method. Calc volume method is an instance method, and I have written that every instance method is implicitly passed a pointer to the current object known as the this pointer. So that means that this calc volume is implicitly passed one pointer. And what is the name of this pointer? The name of this pointer is this. Okay, so name of this pointer is this, and it points to the current object. Now suppose I do something like this. I don't do something like this, and I comment out this code. I can comment out this code. So what is the story till now? The story till now is that we have just created an object of the box class. So over here there is no pointer over here. I just go and remove it. Okay, so I remove it. There is one pointer to the class known as the b1. There is one object of box class, the b1 object. Okay, there is only one object. Now I am going to call the calc volume instance method. So how will I call it? I will call it by use of b1 dot calc volume. Okay, like this. So I have called the calc volume. So when I call the calculate volume method of the box class, what is the current object? The current object is b1, and inside this calc volume, if you go, this is the instance method, and inside this calc volume method there is one implicit pointer known as the this pointer, which points to the current object. So that means only inside, suppose I will take suppose this is the scope of my calc volume function. This is the scope of calc volume function, calculate volume. So suppose if this is calculate volume, then this contains one pointer. What is the name of this pointer? This, and it contains the value 2025. That means 2025 was the address of b1 object, so it contains 2025. So it is a pointer to which object? This object. Now this was the length of what? This was the length of b1, this was the breadth, and this was the height. So we already saw that through object pointer, if we want to access the instance variables or instance functions, we use the arrow operator. So if I say that this arrow length, it will be equal to 2. Similarly, if I say this arrow breadth, it will be equal to 4, and if I say this arrow height, then it will be equal to 5. So my dear friends, just keep this thing in mind, that you don't have to pass this pointer to an instance variable or to a constructor. It is implicitly passed. You don't have to take the responsibility of passing them individually to every function. So over here I can write something like this, because this is a pointer to the current object. So this arrow length will represent the length of the current object. This arrow breadth will represent the breadth of the current object. This arrow height will represent the height of the current object. So you can write this thing in this also. Suppose what I do, I create another method, and suppose it is something like this: void display box. So I'm just displaying what the box looks like. So over here I can write the length of the box is something like this arrow length. Okay, and then a new line marker. So over here something like this. I'll just copy it and I paste it over here, and I will paste it over here. The breadth of the box is okay, breadth, and then the height of the box is the breadth, and then the height of the box. So here also you can observe this, very important, because display box, it is a kind of instance method. So this instance method will be implicitly pass a pointer to the current object. And what is, so here if I call b1 dot display box. So b1 dot display box. So what is the current object? b1. So when I write this arrow length, so whose length? It will mean the length of the b1 object, that is equal to 2. Okay. So suppose now what I do, I create another object of box class, suppose b2, and then b2 suppose length 4, 5, 6. I say something like this. All right. Removing the spaces. All right. Now 4, 5, 6. There is another object of the box class, a b2 object. Now I just remove this, and b1 dot display box, and then I call the b2 dot what display box. Suppose I say like this. Then what will happen? I just go, if I just go and clean and build this, and then I'm going to run this application. So how I am going to run this, like this. Okay. So when I run this application, just see the output. The 3 argument constructor, because we created 2 objects, that is why the constructor body got executed 2 times over here. Then the length of the box is 2, the breadth of the box is 4, and the height of the box is 5. Again, this is of box B1, and then it is displaying the box, the details of the box B2. The length of the box is 4, the breadth is 5, and the height of the box is 6. But over here, if you just observe this code carefully, when I call the b1.displayBox, then the current object is b1. So when I write in this method this arrow length, that means whose length? The length of b1. Over here, then when I call b2.displayBox, then the current object is the b2 object. So when I say this arrow length or this arrow breadth or this arrow height, then whose length, breadth and height? The length, breadth and height of the current object, that is the b2 object. Okay, so it is something like this. So we got an idea, we got an understanding of this pointer. So over here I have written every instance method and constructor is implicitly passed a pointer to the current object known as this pointer. So this pointer not only exists in instance method. See, I have created 2 instance method, the display box and the calc volume. But this pointer also does exist in the constructor of the class. So here also I can write this arrow length, I can write this arrow breadth, and then I can write this arrow height. I can write this also. Alright, like this. So this code will also compile. Now there is one more point, and this pointer is often used to remove the ambiguity between local and instance variables. So if you just go to this point, what does this point means? So if you observe this constructor, inside this constructor, there are 3 local variables, the length and the breadth and the height. See, when I create the box object, I pass 2, 4 and 5, and they get collected in length, breadth and height. So that means length, breadth and height are local to this constructor. But what will happen if I don't write like this? Suppose I remove this construct from here, and also it from here, and also from here. This was what we did previously. The length of the current box, the current object was set to L, the breadth was set to B, and the height was set to B. But now I don't say it L, I say this is length, it is breadth, and then it is, say, suppose height. So this length, this breadth and this height are the local variables, and these local variables are having the same name as the instance variable. So I can say that length equal to length, breadth equal to breadth, and height equal to height. What do I mean over here? When I say length on this side, it means the length of the current object, and then when I say length on this side, it means that the length, what local variable, the local variable length. Okay, then also over here the RHS is the breadth of the local variable breadth, and this breadth is the breadth of the current object. Is this true? No, my dear friends, this is not true. If I just run this application, if this I was doing previously, see, when I said this was not length, I said it to be L, then I wrote it over something like this. I said length is equal to L, that means the length of the current object is equal to L. But now the local variable is also having the name as length, so I will say length equal to what? Length equal to length. Okay, but now if I run this application, clean and build, okay, And then when I run this application, just let us see the output. See, the length of the box is 0, the breadth is 0, the height is 0. Length is the box is some arbitrary value 13120, breadth is 0, and the height of the box is 0. Why? We have passed the length, breadth and height of both the boxes, but we can see that length, breadth and height is setting to 0 or either to some garbage value. Why this is happening? This is happening because of this. First of all, I will write it in a notepad. You just make a note of it. I am going to write inside a constructor local variables take preference over instance variables. Instance variable if they have the same name. So if local variables and instance variable have the same name, then the local variables will take preference over instance variable. So here in my constructor, you have this box class constructor, and the names of the local variable and the instance variable are the same. See, over here I have 3 local variables, the length, breadth and height, and here I have 3 instance variables, the length, breadth and height. So here the local variables will take preference over the instance variable. So when I write length, I wanted to say, this is what I wanted. I wanted that the length of the current object should be set to this local variable length. But this is not happening. Why this is not happening? Because local variable take preference over instance variable. So here this length is also referring to the local variable. See, here also this breadth is also referring to the local variable. That means that these instance variable, the length, breadth and height, they are not getting set. They are not getting set. So that is why they remain either to be 0 or either to be some garbage value. So how do we remove this problem? We remove this problem with the help of this pointer. How will we remove? See, I have written over here in this PowerPoint presentation what I have written, that instance method are also implicitly pass a pointer to the current object known as the this pointer. So when I write something like this, I write this arrow length equal to length, then I say this arrow breadth is equal to breadth, and then I say this arrow height is equal to what? Height. Now this program is correct. Okay, now this program is correct. So when I say this arrow length, that means the length of the current object, the length of the current object, and it is getting set to the local variable length. Then when I say this arrow breadth, that means the breadth of the current object, and that is getting set to the local variable breadth. That has been, suppose I create the B1 object, then breadth is equal to 5, breadth is equal to 4. So that means over here that the breadth of the B1 object is being set to 4, and similarly the height is being set to whatever, 5. Okay, so something like this. So now this program is correct. So now if I go and run this application, clean and build, and then run. Yeah, see, the length of the box is 2, 4, 5 and 4, 5 and 6. So now we are getting proper output because of the use of this pointer. Okay, so something like this. So again I'll just go to the presentation and see every point is covered. This is a keyword. Every instance method and constructor is implicitly pass a pointer to the current object known as this pointer. This pointer is often used to remove the ambiguity between local and instance variable. We saw over here that the local and the instance variable had the same name. So local variables were taking preference. So in order to specifically demarcate the instance variable, we use this pointer. Okay, and then we use the arrow operator to access the instance members of a class using this pointer. We also saw this over here also. If you see, suppose I want to access the length of the current object, then I will use the arrow operator, because length is, it is a member variable. So to access a member variable or function through this pointer, we use the arrow operator. So this point is also clear. And then this pointer is a local object pointer. This pointer is a local object pointer. So what does this mean? This means that this pointer only exists inside the scope of this constructor, or if I'm using this pointer inside this calc volume method or display volume method, its scope is limited to only these methods or constructors. Suppose I write suppose like this arrow, this arrow, yeah, okay. It means that these only is this pointer, or the scope of this pointer exists within these methods or constructors. Okay, like this. It is, the scope is local to these constructors or instance methods. All right. So static functions do not have this pointer. Okay, static functions do not have this pointer. So we have seen that this display box method, it's an instance function. So this has this pointer which points to the current object. This calc volume method is an instance method, so it has this pointer which points to the current object. So if I say this arrow length, that means the length of the current object. But now what I do, I create a static function in the class. Suppose static function 1, and suppose the return type of the function is void, and here suppose I write cout the static function 1 has been called. Okay, I write something like this, and then I print the new line. Now if I write like this, I write cout this arrow length. If I write something like this, then will this particular piece of code compile? Just let us see this. So what is the name of the static function? So I'll just comment out this code. What is the name of the class? The box class. Then I will write the scope resolution operator, and now if I want to call function 1, so function 1, it's a static function. So to call a static function, I can call it through the name of the class itself. Just let us go and run this program, and let us see what is the output. See, this particular piece of code is not compiling. You see, this is unavailable for a static member functions. This is unavailable for static member functions. And my dear friend, this is what I write over here. Static functions do not have this pointer. Why do static member functions do not have this pointer? See, if there are if the function is an instance function, then this pointer refers to the current object. Why? Because instance functions belong to an object. But we saw that static functions do not belong to an object. In turn, they belong to the whole class. Okay. So when inside a static function, when I write this arrow length, so this static function is not associated with any object. This arrow length initially inside instance method, it means the length of the current object, but this function belongs to the class. It is not associated with any specific objects. That is why when I write this arrow length over here, it has no significance in this function also. And we also saw in the previous video of static functions that inside static functions we can never access instance members. Similarly, inside static functions, we can never have this pointer, because this is a pointer to the current object, and static functions belong to the class. Okay, they don't have any linking to the object. Instance functions belong to the object. That is why we can have this pointer inside them. Okay, so always keep this point in mind, that static functions can never have this pointer. Okay, like this. Okay, thank you. Before even trying to understand what these operators are, let us first of all try to understand the need behind creating these new and delete operator, and why do we use it in our programs. Let us try to understand the need. So basic purpose of new and delete operator is to dynamically allocate memory. But why do new and delete operators dynamically allocate memory? Let us try to understand this. I'm just gonna remove it. I'll need this in my program. I have just copied it. I'll just copy it, and I'll move it to a notepad, so that this class doesn't unnecessarily creates any type of confusion. I'll just copy it, and I'll just paste it over here. I'll need it later. Okay, so for example, when I say integer I, okay, So what is happening? I say suppose I equal to 10, and then I say C out, for example, I. This is a very simple program, and so what is happening in this program, if you just observe what is happening, uh, you know, this I, for example, this I, when the program runs and memory is allocated for it. Okay, so I'm just suppose I take this pen tool, and let me draw. Okay, so what is happening is that this, suppose this is your this is your RAM, suppose. So inside RAM somewhere memory for this variable, which variable, the I variable, has been allocated. And suppose an integer take for example, an integer is taking 4 bytes of space. Okay, integer takes 4 bytes of space. It may depend from different version of compiler to compiler, it may differ, but let us consider it. So at the compile time, this is known at compile time, this is known at that, this is at compile time, all the memory is allocated at runtime. When the program actually runs, then the memory for this variable, see, this variable is allocated, but at the compile time it is actually known that this I variable is going to take how many memory? It is going to take 4 bytes of memory. Okay, so this is quite simple and very basic to understand. But now and suppose so you suppose have a program in which you have to calculate the average marks of students in a class. So you can do something like this. Suppose you want to calculate the average marks of the students of a class. I won't write the whole program, but you will have to do something like this. For example, in teacher you have to say, then you have to, suppose you have to declare array, suppose a marks array, and suppose there are 50 students in the class, and you will write something like this. Integer marks what, 50, and then you can you can access individual marks, and you can run a for loop, for I equal to 0, I less than 50, you can say like this, I equal to 0, and then I less than 50, and then I plus plus. You can write, you can give marks, marks of, suppose I equal to any marks, suppose I marks, suppose whatever, you fetch the values from the user, you can allocate student marks, and then you can calculate the average. But some problems may come. For example, it may happen that when the program actually is, when you at the compile time, when you're writing the program at the compile time, you are not sure how many students are there in the class. If you are not sure how many students they are in the class, see, here you are sure that there are 50 students in the class, but many times it may not be sure that how many students are there in the class. So for that purpose, when you are not sure, then you have to dynamically allocate memory. Okay, so at the runtime you will have to tell how much memory do you actually need. Okay, so this is what is new. New is used for, if you just if I just go to this PowerPoint presentation, see, we can allocate memory at runtime within the heap for a variable of given type using this special new operator. So here, if you are not sure that how much memory you need, then at runtime, if you are giving this value of how much memory to allocate, then you will use which operator? You will use the new operator. So I'll just tell you how can we actually use the new operator. So to use new operator, you just have to give this new, and then followed by the data type. So suppose I have to allocate memory for just an integer, sorry, new. Okay, new, and suppose I have to allocate memory for just an integer, so I will write something like this. I'll just write what, new int. Okay, and this new int returns a pointer to the allocated memory. So I can say something like this. Suppose integer pointer p equal to what? Integer pointer p is equal to new int. So if I write like this, then what does this mean? See, if I write like this, then this means that when your program actually runs, then a memory was allocated for what? The memory was allocated for an integer, and suppose this variable is stored at memory location 2000. Okay, then a variable known as a p variable. P is a pointer, so it is containing an address of this allocated memory. See, this is the allocated memory, and it is allocated at memory location 2000, and p is a pointer that is pointing to this memory location. So effectively it means this. Say, for now, suppose example I write value stored at p equal to, say, suppose 20, and then I write C out the value stored at p is, okay, and then I can write something like this, start p, and then a new line marker. So if you write like this, then let us see what will be the output of this program. Just try to run it. Suppose I clean and build this application, and now if I go and run this application, see, suppose I just go and run this application. See, the value stored at p is what? The value stored at p is 20. Okay, so this much is clear. Now, if you have allocated some memory dynamically and you want to delete that memory, see, like before, what was happening is that I'll just write it. Suppose you write this variable. Suppose you create a variable j. Okay. So when your program goes out of scope, that means when your program finishes its execution. So when your program starts, for example, if I just take the pen tool, when your program, for this variable, suppose this variable, suppose the variable j, when your program starts, this variable j is allocated, and when the program terminates, this variable j is what? This variable j is deallocated. Okay, but with memory that is dynamically allocated, you need to delete the memory by actually writing something. So you delete a memory that is dynamically allocated by using which operator? By using the delete operator, and then you give the name of the pointer. Okay, so for example, I will over here say delete p. So what will that mean if I write something like this? Suppose I write delete what? Delete p. Then it will free the memory that is being pointed by which? Then that is being pointed by p. And now suppose again if I write, suppose I again copy it and I paste it over here. So if you just clean and build this application, and now if you go and run this application, see, the value stored by p is what? The value stored at p is 20, and then values stored at p it is coming out to be some garbage value. Why? Because we have freed up this memory location. So before actually the program terminated, we actually freed up some memory that we have allocated in the program. So that is also an advantage. You can both allocate memory and you can both do what? You can deallocate memory also. So let us try to see a practical use case. For example, I say that suppose I want to calculate the average of students, average of all students in the class, marks of all students in the class. So I will just quickly write a program for it so that it becomes clear. Suppose I want to calculate the average of marks in a student. Suppose I say integer pointed p is equal to what? I allocate now an array. Okay, okay. And how do I allocate in memory? So I do not know how many students are there in the class. That when my program will actually run, then I will come to know how many students are there in the class. So first of all, suppose I declare a variable n students, that is the number of students in the class. So I will say cout enter the number of students in the class. Alright, and then suppose I give a new line marker, and then I write suppose c in what? C in n students. Okay, then I input the value. Then I am going to allocate memory for how many variable? Sorry, I am not going to say something like this. I am going to say something like this. Okay, n students. Okay, n students. Okay, so here what is happening is that I am allocated. Suppose here I am asking what? Here I am asking how many students are there in the class, and then I am allocated memory. I am allocating memory for those students. Okay, so it is like this. Now I can write. Suppose how many students are there in the class? N students. So I can run a loop from I equal to what, 0, I less than what, n students, and I plus plus. So here I can just run a for loop, and inside the for loop I can write what, suppose I write cout, enter the marks for the, suppose I plus 1 student. Okay, I'll just add like this. Okay, alright, and then I will give a new line marker, and I need to declare this variable I also. So here I will write like this, integer I. Alright, now I have I have entered the student marks, and now I can write what, I can write like this, what, that p plus I, the, I can write c in what, value stored at p plus I. Okay, and sorry, c in, and then I just need to copy this. Suppose I need to calculate the average, so I will declare one variable also. Suppose integer avg marks. Okay, suppose I declare a variable average marks, then I can calculate the average also. How will I calculate the average? I will say, suppose first of all I need to calculate the sum of the sum of all marks, and then I need to calculate the average. So how will I calculate the sum? Suppose I declare a variable called sum marks. Okay, so I initialize this variable to 0. I initialize, suppose, average marks also equal to 0, and now I say, suppose sum marks equal to sum marks plus what, plus value stored at what, p plus I. If I write like this, and then in order to calculate the average, I can write something like this. So first of all, let me calculate the average. So average, average marks equal to what, sum marks divided by kya, divided by the number of students in the class, and then I can write the average marks are, and now I can write one avg and then average marks. So here I have I have calculated the average marks. But the interesting point of this whole program is that I am not sure how many students are there in the class. It may be anything. So if I go and run this program, for example, if I just go and run this program, clean and build. So first of all, it will ask how many students are there in the class. So if I just run this application, suppose if I go and run this application, enter the number of students in the class. So I say, suppose there are two students in the class. Enter the marks for the first student. Suppose first student is getting 90 marks. Enter the marks for the second student. Suppose the second student is getting 80 marks. The average marks is what? The average marks is 85. So you are actually, when the program is running, then you are telling how many students are there in the class. For example, I again run the program. I run this program, and now again enter the number of students in the class. Suppose there are 3 students in the class. Enter the marks for the first student. Suppose the first student getting 50 marks. Enter the suppose second student is getting 60 marks, and the third student is getting 70 marks. The average is what? The average for the whole class is what? The average for the whole class is 60. So what is actually happening over here is that if I so what is actually happening is that you are telling you are inputting this variable. Which variable? N students, the number of students in your class. When the program is running, you are inputting this variable from the user, and then you are allocating this much amount of memory. Okay, so when you say integer, when you are saying like this, integer point, integer n students, so it is allocating, suppose n students is equal to 4, then it is allocating a memory of an array of how many integers. It is allocating an array of 4 integers, and suppose this array is starting at memory location 2015, then there is a pointer, which pointer? P, and it is containing which value? It is containing the address of the array, that is 2050. So this array is containing how many elements? 4 elements. Why? Because 4 is the, this is the number of students that you have given in the class. So if you want to access this element, for example, if you want to access the value of this element, then it will be equal to what? It will be equal to P plus 1. The address will be equal to P plus 1, and the value will be equal to what? Star at P plus 1. So this is what I've done. You are inputting this value every time. So when you write, when I is equal to 0, then this is the value of this memory location. When I equal to 1, this is the memory of the second the second element in the array, and when I equal to 2, it is equal to the value of the third element in the array. And then you are summing all these values, and then you are calculating what? Then you are calculating the average. In this way you are doing it. And now a very interesting thing. So you have allocated this array. Now if you want to deallocate the array, see, if you want to deallocate, suppose if you did like this, you allocated an integer, suppose in new int, and now if you want to delete, suppose you were saying like this, integer pointer r equal to what? New int, and now if you want to delete this memory location, then you are saying what? Delete r. But if you want to delete an array, then you have to do something like this. You have to write delete followed by the array subscript, and then the name of the memory location. So here I can, or the pointer. So I will write something like this. Okay. So for this is for the array subscript I used to if I were to deallocate the arrays that have been dynamically allocated, then I use this. Okay. So if I actually if I go and run this program, let us see what is the output. Clean and build. And now if you go and run this application, see. Okay, so like this memory has been deallocated. So I have already shown that you can deallocate this memory using this. Okay. In this video we will try to understand how can we dynamically allocate objects or an array of objects using the new and delete new operator, and then further delete it using the delete operator. So let us try to understand it. So I'll just go on to my without wasting any time, I'll just go to my C++ application, and I have created a class. I've already created a class to save some time. Suppose the name of the class is a rectangle class, and there are two member variables in this class, the width and the height. Since this is the the default constructor for the class, this is the parameterized constructor for the class, and then this is the destructor for the class. Okay, so I have one instance method that is setting the value of width and height for the class, and then there is one instance method that is calculating the area for the class. Okay, so just observe this class. You can also pause this video and have a look at the rectangle class. Okay, see, this is my rectangle class. Okay, so you can have a look at this class. And now let me do something like this. I need to dynamically allocate an object. So what will I write? What is the name of the class? The name of the class is rectangle. Suppose I declare a pointer to this class, suppose rectangle pointer r, and then I can write what? R equal to what? R equal to new rectangle. So I have allocated see, new operator, and then you can also see here I've you just go to this presentation, what I've written, the second point, we allocate memory using what? New and data type, and where the data type can be any built-in data type, or what? It can be a class also. So the amount of space that will be required for the object of the class, that much space will be allocated, and the address will be stored in what? The address will be stored in R. So this it will be something like this. For example, if I take so what is exactly happening is that if this is your suppose your RAM, this is the area of your RAM, then an object has been allocated, and an object has been allocated. We do not know what is the name of this object, but suppose the address is 2080. Okay, and this is an object for the rectangle class, so it is having the width and height. Suppose the width of the rectangle is 10 and the height is, say, suppose 20, and then there is a variable, the R variable, and that is containing the address of this object. So what is the address of this object? It is 2080. Okay, so it can be address can be anything, but this R is pointing to this object. R is pointing to this object. Okay, so what we can write, suppose I want to suppose I escape it, and R is a pointer to this object. So now if I want to, so if you want to access a member variables using pointers, you use which operator? You use the arrow operator. So if you want to calculate the suppose you want to set the width and height. Suppose I set the width to 10 and height to what? Height equal to 20. And then now if I want to suppose calculate the area, then what will I do? R arrow what? Area. Okay. And now once you have performed all the operation, you can delete this memory. And how you will delete it? You will delete it using which operator? You will delete it using the delete operator. So here I have done this. Okay. So let us try to see what is exactly happening in this scenario one by one. Suppose I clean and build this application. And now if you go and actually run this application, let us see what is the output. See, run. So constructing 0 by 0 rectangle. See, so there is one important thing for the new operator. When you allocate objects using the new operator, see, here I am allocating one object. Here I am allocating one object using which operator? I am allocating an object by using the new operator. So what is happening over here is that if you observe, see this line, constructing see this line, constructing 0 by 0 rectangle. Okay, so where this is called when the default constructor for the class is called. See, suppose I write to make things more clear, I write like this, default constructor. Okay, and then I give a new line, and then I just copy it, and if I paste it over here, and then I can write what? I can write parameterized constructor called. So let us see what is output. If I actually go and clean and build this application, and then suppose if I run this application, then you will get this output. See, default constructor has been called. So whenever whenever you create an object by using the new operator, the constructor for that class is automatically called. Okay, the constructor is automatically called, and then I am calling this method. So if you are having object pointers, then if you want to access the members of that class using the object of pointers, you use the arrow operator. And finally I am deallocating the memory over here. Okay, so this is what is exactly happening. So now if I want to do something different, I want to allocate an array of objects. So what will I do? Suppose I want to allocate an array of, say, suppose I'll first of all clear all this. I'll clear all this, and now if I want to allocate an array of objects, then what will I write? Suppose I want to allocate an array of 3 objects, and so I have allocated an array of 3 objects. And now if I write if you want to delete this array, then you will what? Then you will use the array subscript, and the memory location is being pointed by r. So I will write like this. So if you actually go and clean and build, and then if you run this application, see, default constructor has been called how many times? 3 times. The default constructor has been called, and the destructor has been called how many times? The destructor has been called 3 times. Okay, so this makes output very clear. You are allocating an array of how many objects? You are allocating an array of 3 objects. See over here, you are allocating an array of 3 objects. So that is why the constructor was called 3 times. And then once you deallocate the array, the destructor will be called. And how many elements are there in the array? There are 3 elements in the array. So that is why the destructor will be called how many times? The destructor will be called 3 times. Okay, so I can write a loop something like this also. For example, I can write suppose r0 and dot, suppose I say set. Suppose for the first rectangle I set the the width and the height to 10 and 20. For then I'll just copy it and suppose I'll paste it. For okay, I need to move it over here, and then need to move it. Suppose for the first rectangle I do like this, and for the third I do like this. Suppose for it I set suppose to 24, and then for this I set it to 15, and then I set it to what? Suppose I set it to 5, and then I compute the area. So how will I compute the area? I will write something like this: for integer I equal to 0, I less than 3, and then I plus plus, and then I can write what? I can write r I dot area. All right, and then okay, I need to output this, and then I'll give a new line marker. All right, if I write like this, then it will compute the area of all the rectangles. So if you actually go and clean and build this application, then let us see what is the output. I clean and build this application, and now if I go and run this application, let us see. See, the constructor will be called first, and then all the rectangles areas have been calculated. All right, and then you're writing what? You're writing this. See, after calculating all the areas, you are writing, delete the array. So when you're deleting the array, then you're calling what? Then you're calling the destructor. So the destructor has been called, destructor has been called for all the rectangles. Okay, you have allocated the array of 3 rectangles. Okay, clear? So in this way, you can work with dynamic memory allocation. And one more thing to that is like a kind of addition. If you have studied exception handling, then many times it may happen that you want to allocate some memory, but that much memory in the heap may not be available. Although that scenario is very rare, but still it may happen that if you dynamically allocate memory, suppose you are allocating very big memory, suppose you are having suppose a table in which you are having thousands of rows, and then for that purpose you allocate an array, and that much that much memory is not available. So what will you do? You will do something like this: try, and then you will this allocation part you will put in what? You will put in a try catch block. Okay, so I'll put this in a try catch block, and then I will do what? Okay, inside I can write something like this. And then I can give a new line marker, and from here I can just end the program by returning some value. Suppose I say return 1. Okay, so this is actually standard best practice when you're doing dynamic memory allocation using new and delete. Then you should write this operation inside try and catch. Why? Because sometimes memory allocation may fail, and if memory allocation fails, then this exception will be raised, and you'll go to the catch block. So if you go and actually run the program, there will be no changes, but still you have given more robust code you have written. Okay, if you clean and build, and if you actually run this program, see there are no changes, but still the program has become more robust because you have done some custom exception handling also. Okay, so whenever you are asked about reference variable, you can just say that reference variable are an alias name for some other variable. So that means reference variable are just a kind of alternate name for some other variables. Let us see this with the help of one example. So I just go to my my NetBeans application, and let me declare one variable. Suppose this variable is I, and the value of this variable is, say, suppose 10. And now I want to declare a reference variable of, say, suppose type int. So whenever you create a reference variable, you precede the definition of the reference variable by an ampersand sign. Suppose I name the reference variable to be rvar. Okay, a reference variable. Okay. And all right, suppose just say it var. Okay, let me just name it var. Okay, and I say this equal to, suppose it is equal to I. So what does this mean? Let me write something like this: the value of I is, and then I print the value of I, and then I give a new line. And then I just copy all this line, and I paste it over here, and I say the value of var is this. Okay, so var. Okay, so if I just go and run this application, what will be the output? And to understand the output, let me try to explain it to you. For example, what is happening over here, if you observe, what is happening is that, suppose all right, suppose I say that this is the memory, your RAM, in which memory is being allocated. So inside your RAM, a variable is there. What is the variable? The name of the variable is I, and the value is what? The value is 10. Now you are creating a reference variable. What you are saying? Var equal to what? It is equal to I. See, you are saying like this, you know, integer m percentage var equal to I. So this means this variable, you know, this var. So this variable can be referenced by, you know, it can be referenced by I also, and it can be referenced by what? It can be referenced by var also. So now if you are printing the value of I, what will it print? If it will print 10. If you are printing the value of var, then also what it will print? 10. Why? Because var is just an alias name for which variable? It is an alias variable. So if you want to use I, you can also use what? Var in its place. So now if I just go and run this application, for example, suppose I clean and build this application, and now I go and run this application. So what will be the output? Run. See, value of I and var, both of these variables are having which value? Both of them are having the value of what? They are having the value of 10. And now I say suppose var plus plus. If I say var plus plus, then can you guess what will be the output? Okay, take your time to, you know, just guess the output. I'll just run this application, and if you run it, then what will you get? You'll get, you know, the value of I is what? The value of I is 11, and the value of var is also what? The value of var is also 11. Why is it coming? Why is it coming like this? It is coming like this because you are having two variables, you know. There is a memory allocation, and this memory allocation is, you know, you can I also use, and you can use what? You can use var also to refer it. So initially the value was 10, and now you said what? You said var plus plus. So that means this variable now will become what? 11. So if you print I, then also what will be printed? 11. And if you print var, then also what will be printed? What will be printed? 11 will be printed. Okay, so this way. Now let us try to do something, and before, you know, just let us try to understand reference variable in some more clarity and with some more depth. So whenever you create reference variable, you precede its declaration by which, you know, you precede its declaration by an ampersand. So this ampersand should not be confused with the address of operator that you use in pointers. So one point that you can, you know, you can differentiate is that if you use address ampersand operator on the RHS, see this equation. Yeah, this is the RHS, and this is the LHS. If you use the ampersand operator on the RHS, then it becomes the address. But when you use it in the LHS, then it becomes? Then it becomes a reference. So here var is what? Var is not, you know, it is indicating the address of variable. It is a kind of reference. Why? Because ampersand is used at the, you know, at the LHS. So this way. And now a reference variable must be initialized at the time of creation. What does this mean? See, I have declared this reference variable in this line, and in its declaration also I have defined, you know, I have given, you know, I have initialized the reference variable also. How I have initialized the reference variable? I have initialized the reference variable to I. So that means this variable var is just another name for which variable? It is just another name for the variable I. Now if I not do it, suppose I just declare the reference variable, but I do not initialize it. Then if you go and actually run this application, suppose clean and build this application, and if you actually run this application, then you will get error. Why you will get error? Why? Because once you create a reference variable, you have to also initialize it, and you cannot initialize a reference variable to a value. See, reference variable is another name for an existing variable. So you have to initialize reference variable with that existing variable. You cannot initialize a reference variable with a value. It will not make any sense. So if you again clean and build this application, you see, again, you know, you will get errors at this line. So I have to write like this. All right. And then the third point that I have written is that a reference variable or object once initialized cannot be updated or made to refer to some other variable or object. So suppose I do something like this. Integer, I declare a variable j, and suppose I remove this line, and I say var equal to j. Suppose the value of j is equal to 12. And now if I write j equal to j plus 10. All right. And now I just copy all this. copy it, and now suppose here I also print the value of j. Okay, here also I say the value of j is what? The value of j is equal to this variable. So now if I run this program, can you guess what will be the output of this program? Let us actually go and run this program. Clean and build, and if you actually run this application, then what is happening? See, the value of I is 12, the value of var is 12, and the value of j is what? The value of j is equal to what? The value of j is equal to 22. So if you just bifurcate this program, let us try to understand this program. I will take the pen tool from here, and I will suppose write like this. So now what is happening? If you observe what is happening, suppose this is, this is the memory, this is the whole memory in which all allocations are being done. So there will be a variable. What will be the name of this variable? The first line will do, it will declare a variable I, and the variable I will have the value of 10. Again, one more variable is declared, and this variable is, suppose it's having the value 12, and this is j. Then you are declaring a reference. See this line. Which line? This line. You are declaring a reference. So that means this variable can be referred by what? I and var. Now you are writing var equal to what? You are writing var equal to j. So this means now var will, var will refer to j? No, it will not mean that. It means this value will not be, will be replaced by the value of j. And what is the value of j? It is equal to 12. And now you are writing what? J is equal to j plus 10. So here, in place of 12, what will be written? 22. So if you print the value of I, what will be printed? 12. If you print the value of var, what will be printed? 12. And if you print the value of j, then what will be printed? 22 will be printed. Okay, so I think it is clear. And the point, to be noted is that, this line has to be noted. If I am saying var equal to j, so it does not mean that now this reference variable var is pointing to j, or this var has now become an alias name for j. It means, this the value over here has become what? The value over here has become the value of j, and that was equal to 12. Okay, clear? So here I am just going to minimize it. So with that, the third point, as I have also explained, the third point, that reference variable, once you have initialized the reference variable, you cannot make them to refer to some other variable or object. So this is, this is the way you work with reference variable. So now let me do one very common program, and that is the, pass by reference. So you must have done these programs by using pointers, but I will explain pass by reference using references. So let me create two variables. Suppose integer a, alright, integer a, and integer what? Integer b, and suppose I write 10 and b is equal to what? Suppose b is equal to 20, and I write cout the value of a is, and then suppose I print the value of a, and then I give a new line marker, and then suppose I copy all this code and I print it, paste it, and then I print the value of what? I print the value of b. Okay, so I now create a function. Suppose the function is a swap function, and it is taking two references. Okay, so here I say x, and here there one reference, suppose y. Okay, so I have taken two references, and I declare a variable, suppose temp, and I say temp equal to x, and x equal to y, and y equal to temp. I write like this. Okay, so I created a function that is a swap function, and here alright, I think now it should work. I'll just save it, and now I qual that's so I will write, before writing this, I will write like this. Before calling the swap function, and then I will give a new line, and then I will copy it, and then I will call the swap function and pass the argument. Suppose I pass the argument a and b, and then I paste this line, and then I write something like this: what? After calling the swap function, and here if I just copy these two lines and I paste these two lines over here, the value of a is what? So you are initializing the value of two variables, a equal to 10, b equal to 20, and now you are printing those values. Then you are calling the swap function, and then you are again printing the value of what? You are again printing the value of A, and then you are printing the value of B. Let us see what is the output, and then we will try to understand it. Okay. Okay, I think it is built successful, and I can run this application. See, value of A was, before value of A was 10 and B of value was 20, but after the calling of swap function, the value of A has become 20 and the value of B has become what? It has become 10. So why is this happening? Let us try to understand it. Suppose I take the pen tool, and here I just so what this is, this is suppose okay, I have not taken. Alright. Suppose this is the memory that is allocated for you. This is your RAM, and inside the RAM, two variables are there. What is the name of the first variable? It is A, and that is equal to 10. And what is the name of the second variable? It is equal to B, and it is equal to what? 20. Then you are calling which function? You are printing A and B, you are printing 10 and 20. Then you are calling swap A and B. You are passing these two arguments, but now you are collecting them in what? Now you are collecting them in references. So that means X is now another name for which variable? X is now another name for this variable, and Y is now another alias name for this variable that was, that belonged to B. And if you declare a temporary variable and you say temp equal to X, so temp, suppose I say this is the temp variable and temp equal to X, so temp will become what? Temp will become 10, and now you say X equal to Y. So here X equal to Y means now what the value will come? Here value 20 will come, and Y equal to temp. So here, what you will, in place of 20, value of temp will come. So here what will come? It will 10 will come. So now if you just go to the main method and you print the value of A and B, so what will be printed? For if you print the value of A, then 20 will be printed, and if you print the value of B, then what will be printed? 10 will be printed. So this is the way references are working in this swap function. And now let us try to do this without the use of references. Suppose I do not use these references. And I just save the program, and I just go and clean and build and run this application. Suppose I clean and build this application, and now I kind of run this application. See, before swapping also the value of A and B is 10, and after swapping also, and after calling the swap function, the value of A and B is equal to 10. Why? Because this is call by value. So call by value means that I have explained it, call by value, but still I would like to explain it. If I take the pen tool, so this is like a kind of call by value. So suppose this is the scope of your main method, and two variables are there. Suppose A and this variable is B, and 10 and 20 are there in these variables. And now this is the scope of what? This is the scope of your function, that is the swap function. And here you are declaring a local variable X will be created, and it will be given the value of 10, and a local variable Y will be created and will be given value of 20. So now these two variables will be swapped. Here 20 will become, and here 10 will come, but no changes will be reflected in these two variables. So this is actually what? This is actually call by value. So we are more interested in call by references. Okay. So here, in both cases you are getting the output of A as 10 and B as equal to what? 20, even after swapping these two values using the swap function. So better to use what, if you want to perform call by references, then you can use the ampersand operator also. Alright, so here also I use the ampersand operator, and here also I use what? Here also I use the ampersand operator. Alright, so this much is done, and now we are going to see reference objects. So if you want to create objects, then first of all we need to create what? First of all, for that purpose we need to create a class. Okay, suppose the name of the class is my class, and inside my class I'll just keep things very simple. I'll just terminate the class, and I'll use the public accessibility modifier, and I will declare two variables, suppose X and suppose integer Y. Okay, and then I'll create a constructor for the class, and integer X and suppose integer Y, and suppose I see out I write in my class parameterize constructor, and then I give a new line marker, and I say this arrow x is equal to x, and this arrow y is equal to y. So I have I have created this very simple class, and then I can suppose I create a method void. Suppose this is a display method, and I can write what cout the value of x is, and I can write this arrow x, and I can copy it and I can paste it. Suppose I can print the value of y also. So here also I can print the value of y, and better to always give new line markers after end. Okay. So I have created a class. What is the name of the class? The name of the class is my class. This is my class. And now let me do one thing. Let me create an object of the class. Suppose I create an object of the class, my class m1, and I pass suppose x as 10 and y as 12. Okay, if you write like this, and now you want to declare a reference of my class. So how will you declare a reference? By the use of which operator? The ampersand operator. And suppose the reference name is m2, and you have to initialize the reference during its creation. So I initialize it to what? By it m1. So now m2 is just another name for what? M2 is just another name for m1. Okay, so here it means something like this. If you actually go if I take the pen tool, and I just what has actually happened is there that one variable has been allocated, and this one object is there, and this is the m1 object, and x is 10 and y is equal to what? 12. See, if this variable is what? This is representing x and this is representing y. And now once I say what my class, and then I use ampersand, and m2 is equal to m1. If I say like this, then what means? It means an m2 is also the analyzed name for what? M2 is just an analyzed name for what? M1. And now I do like this. Suppose I escape it, and suppose I say m1 dot x equal to m1 dot m1 dot x plus 10, and I copy it and I paste. Suppose I don't write m1, I write m2 over here, and here also I write m2, and here also I write m2 and m2. So, and I say m2 dot y equal to m2 dot y plus 5. Okay, now I write like this, and now I create now I call the display method. So I call m1 dot display, and I also called what? M2 dot display. Alright, I just copy it, and first of all I'll print m1 dot display, and then I'll call m2 dot display. So here I can write suppose what I can write showing the details of m1 object, and then I will give a new line marker, and I'll just copy all this code, and here I can write this. Okay, showing the details of, say, suppose a m2 object. Now what will happen? Suppose if I go and actually run this application, see, I clean and build this application, and now if you go and run this application and see what is the output. See, the value of x is 10, showing the details of m1 object, x is 20 and y is equal to 17, and for the m2 object also an x is 20 and y is equal to 17. Why? Because m2 is also an alias name for what? M2 is also an alias name for m1. That is why it is happening like this. Okay, so I think reference variable, I just needed to only I just wanted to make this concept clear, that you can have reference reference objects also. And let us quickly try to create one method. Suppose void, suppose the name of the method is function1, and it is taking a reference, suppose it is taking a reference of my class, suppose ampersand m. It is taking a reference, and then I am saying something like this. m dot x equal to m dot x into m dot x. Okay, and then I copy it and I suppose paste like it, and I write like m dot y, and here also write m dot y, and here also I write what? Here also I write m dot y. Now inside the main method, I think this much is clear, so I can just remove it, and I kind of create an object of my class. Suppose my class, I create an object m1, and with the m1 object, and let me initialize it. Suppose 5 comma 6. Okay, and I call m1 dot function 1, controls it. I call what? Suppose I go over here and I write m1 dot function 1, and I just pass what? And I argument I also pass m1, and then I call what? m1 dot display. Then can you guess what will be the output of this program? If I just run this program, what will be the output? See, if I try to run this program, what will be the output? See, here I go and clean and build this application, and so this is also, you know, a kind of call by reference. So if I actually run this application, see, the value of x is 25 and the value of y is called 36. Why is it coming like this? Let us try to understand this. Just few more minutes, I'll try to explain this. Suppose I take the pen tool, and what is exactly happening over here? Okay, I'll just, you know, again I need to take the pen tool. So what is happening is there that you have allocated an object. What does you have allocated? Suppose this is your memory, and inside the memory you have allocated one object, that is a, you know, this object, and x, you have set the x equal to 5 and y equal to you have set y equal to 6, and this is what? This is m1 object. Now you are calling this function m1, this function 1. See, you are calling this function, but now this function is taking what? It is taking a reference. So now what it becomes, this m also become a alias name for what? This m also becomes a alias name for m1. So once when you say m dot x equal to m dot x into m dot x, so here in place of 5 what will be written? 25, and here in place of 6 what will be written? 36. So if out, when you come out of this function and you print m1 dot display, what is getting printed? 25 and 36 are getting printed. See, m1 dot display. So when you go to the display function, I'll just escape it, and if you actually go to the display function, what is the current object? The current object is the m1 object, and the value of x for m1 is what? It is equal to 25, and y is equal to what? Y is equal to 36. So this is also a kind of what? Kind of explanation for passing objects by reference. Okay, and you can, if you don't use these references, then what will be the output? Can you guess? And I'm not going to explain it, but if you try to run this application, clean and build, and now actually you go and suppose if you run this application, see, then what will be the output? You know, x is 5 and y equal to 6. Why? Because here what is happening is that you are not passing, you know, the object as reference, so another copy of the object has been created. Okay, another copy of the object has been created. All right. So before trying to understand friend function, let us try to understand the need behind friend. So in general, suppose you have a family and there are some close family members like your mothers, your father, the brothers, sisters. They all form a unit. But there are also some friends of the family which can come inside the family and they can meet the family members. So this is the case with my object-oriented programming in C++ also. Like I have a class, and inside a class, suppose I have a private variable. Suppose I have a private variable, and suppose the variable is, say, suppose x. I have one private variable. So what does private variable means? Private variable means that it is only accessible from within the class. I cannot access a private variable from outside the class. See, if I make an object of my class, say suppose m1, then I cannot write something like this, m1.x. I cannot do it. Because why? Because x is private to the class. But this private variable cannot be accessed from outside the class. But there is one provision, that is a provision of friend function. So friend function of a class have this, friend functions of a class are allowed to access the private members of a class. So how do we declare friend functions, and how do we create friend functions? All this we will see in this video lecture. So before studying friend function, I will just try to first of all present it, And let us look at some point of friend functions. So friend functions are not member functions of a class to which it is a friend. Okay. And friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Friend function can access any member of a class to which it is a friend. So let me do one thing. Suppose this is my class. What is the name of my class? My class. So over here I will create a function. Suppose the name of the function is function1. But now this function is not an ordinary function. It is a friend function. You see, if you go to this presentation over here, then what I have written, friend functions are declared inside the class using the friend keyword. So whenever you want to make a function as the friend function, you in its declaration, you write the keyword that is the friend keyword. So over here I have written the friend keyword. So over here my function, that is function1, this is the friend function. So I'm just going to remove it from here. So again, if you go over here, you can see friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Okay, so friend functions are not member functions of the class. Okay. So what does all this mean? See, inside my class I can just have a declaration of the friend function. I just declare the friend function. Then I need to define the friend function somewhere outside the class. So how am I going to define the friend function outside the class? This is what I'm going to tell you. So if you want to define the friend function outside the class, then what is the return type of this function? It is void. And what is the name of the function? It is function1. So first of all, over here, this is a friend function. Okay, function1, it is a friend function. So let us go point by point. Friend functions are not member functions of a class to which it is a friend. See, over here in this my class, the function1 is a friend function. This friend function does not belong to my class. It does not belong to my class. See, I cannot write something like this. M1 is an object of class. Which class? My class. Through M1 I cannot access function1. You see, if I write, then it results in a compile time error. Unable to resolve identifier function1. Because function1 does not belongs to the class, we cannot access function1 through the object of the class. So always remember that friend functions are a kind of very special type of functions which do not belong to the class but still have the capacity, or they are allowed to access the private members of a class. Okay, like this. Now what I do is that suppose this friend function takes an argument of my class. Suppose M, my class. This is just a declaration, and over here I write something like this, my class M, and now I write cout m.x. If I write like this, then what does this mean? Suppose in this class I also declare a constructor. So how will I declare the constructor? My class integer x. Now we have studied about this pointer, so I can use this pointer, this dot x equal to x. See, over here my instance variable name is x. What is the name of the instance variable? It is x. And what is the name of this variable? This local variable is also x. So I can write this arrow x is equal to x. Alright. So when I write this arrow x, that means the x of the current object, and this x is the local variable. Alright. So I have created a constructor of the class. So now I can do something like this, 10. Alright. Now that means for object M1, the value of x is 10. Now there is a function. What is the name of the function? Function1. This function1 is not a member function of my class. Instead, it is declared in the global scope. You see, it is defined in the global scope. So if I need to call function1, what will I do? I will just write the name of function, and then I will pass the argument. And what is that argument? It is an argument of type of object of my class. So I have an object of my class, that is M1, and this function1 is expecting an argument of what class? It is expecting an argument of my class. So over here This m1 gets passed on to m, and then I print m1 m dot x. So you can see this x is a private variable. If this x is a private variable and my class is ending over here, see, this class only is from here to here, okay, and I am accessing this x variable from outside the class. I am accessing this x variable from outside the class. If x is a private variable, then generally it is not allowed, but friend function can do this, okay. Like if there is some family friend, then he can come inside your family and he can, you know, have some personal interactions with the members of the family. Similarly, the friend function can access the private variables of a class, private members of a class. All right. So now I will clean and build this application. Build successful. And then once I go to, I will just run this application. So let us see what is output. CC 10, it is coming out. So I can write something like this. Inside the friend function, the value of x is, all right, like this. And then I will, I will give a new line marker like this. All right. And then again I will go to clean and build this application, and then I will run this application. So once when I run this application, inside the friend function, the value of x is 10. See, x is a private variable and the value that has been set for m1.x was 10. m1's x was 10, and that x I am accessing somewhere outside the class. So this is a friend function. Which function? The function 1, it is a friend function. So again, let us go to my presentation. Friend functions are not members of a class, or not member functions of a class to which it is belongs. Yeah, we saw that just because if I were to write m1 dot function 1, then it was giving an error. See, m1 dot function m1 dot function 1. If I write like this, then it will result in a compile time error. I cannot do this. That means function 1 does not belong to the class because it cannot be accessed through the object of the class. Friend functions are declared inside the class. Yes, I declared my friend functions inside the class. How I declared my friend function inside the class? I did it like this, and then I defined my friend function in the global scope outside the class. Okay, like this. Friend function can access any member of the class to which it is a friend. So over here, this function 1 is a friend to my class. So it has access to all the member variables and functions inside my class. So here, the thing is that x is a private variable, but inside the friend function, I can access the private variable. But there is a specific condition. What is the specific condition? I cannot do something like this. I cannot directly access x. See, x is a private variable. I cannot write directly accessing x. The value is, suppose I cannot directly access x. Okay, if I do like this, then it will result in an error. It is giving a compile time error, unable to resolve the identifier x. So you cannot directly refer an instance variable inside a friend function. You only do it indirectly through the object of the class to which the friend function belongs. See over here, friend functions are not associated with any objects. And then if you see the last point, friend functions access the members of a class through the object of the class. So if I want to access this private variable x, I cannot directly access. I cannot write cout as we saw. I cannot write like this. If I want to access x, then I have to write something like this. I have to access it through the object of my class. See, friend function belongs to my class. It is a friend of my class. Then if I want to access the private variables of my class, then I need to have an object of my class. And what is in this case the object of my class, my dear friends? It is m. So these are friend functions. So in the next video also, we will study about friend functions. We will create a friend functions that will belong to two classes, and that will then access the private members of both the classes. So we will see it in the next lecture. So before trying to understand friend function, let us try to understand the need behind friend. So in general, suppose you have a family and there are some close family members like your mothers, your father, the brothers, sisters. They all form a unit. But there are also some friends of the family which can come inside the family and they can meet the family members. So this is the case with my object oriented programming in C++ also. Like I have a class, and inside a class, suppose I have a private variable. And suppose the variable is, say, suppose x. I have one private variable. So what does private variable means? Private variable means that it is only accessible from within the class. I cannot access a private variable from outside the class. See, if I make an object of my class, say suppose m1, then I cannot write something like this, m1.x. I cannot do it. Because why? Because x is private to the class. But so this private variable cannot be accessed from outside the class. But there is one provision, that is a provision of friend function. So friend function of a class have this, friend functions of a class are allowed to access the private members of a class. So how do we declare friend functions, and how do we create friend functions? All this we will see in this video lecture. So before studying friend function, I will just try to first of all present it, and let us look at some point of friend functions. So friend functions are not member functions of a class to which it is a friend. Okay, and friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Friend function can access any member of a class to which it is a friend. So let me do one thing. Suppose this is my class. What is the name of my class? My class. So over here I will create a function. Suppose the name of the function is function1. But now this function is not an ordinary function. It is a friend function. You see, if you go to this presentation over here, then what I have written, friend functions are declared inside the class using the friend keyword. So whenever you want to make a function as the friend function, you in its declaration you write the keyword, that is the friend keyword. So over here I have written the friend keyword. So over here my function, that is function1, this is the friend function. So I'm just going to remove it from here. So again, if you go over here, you can see friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Okay, so friend functions are not member functions of the class. Okay, so what does all this mean? See, inside my class I can just have a declaration of the friend function. I just declare the friend function. Then I need to define the friend function somewhere outside the class. So how am I going to define the friend function outside the class? This is what I'm going to tell you. So if you want to define the friend function outside the class, then what is the return type of this function? It is void. And what is the name of the function? It is function1. So first of all, over here, this is a friend function. Okay, function1, it is a friend function. So let us go point by point. Friend functions are not member functions of a class to which it is a friend. See, over here in this my class, the function1 is a friend function. This friend function does not belong to my class. It does not belong to my class. See, I cannot write something like this. M1 is an object of class. Which class? My class. Through M1 I cannot access function1. You see, if I write, then it results in a compile time error. Unable to resolve identifier function 1. Because function 1 does not belongs to the class, we cannot access function 1 through the object of the class. So always remember that friend functions are a kind of very special type of functions which do not belong to the class but still have the capacity, or they are allowed to access the private members of a class. Okay, like this. Now what I do is that suppose this friend function takes an argument of my class, suppose m, my class. This is just a declaration, and over here I write something like this, my class m, and now I write cout m dot x. If I write like this, then what does this mean? Suppose in this class I also declare a constructor. So how will I declare the constructor? My class integer x. Now we have studied about the this pointer, so I can use the this pointer, this dot x equal to x. See over here, my instance variable name is x. What is the name of the instance variable? It is x. And what is the name of this variable? This local variable is also x. So I can write this arrow x is equal to x. Alright. So when I write this arrow x, that means the x of the current object, and this x is the local variable. Alright. So I have created a constructor of the class. So now I can do something like this, 10. Alright. Now that means for object m1 the value of x is 10. Now there is a function. What is the name of the function? Function 1. This function 1 is not a member function of my class. Instead it is declared in the global scope. You see, it is defined in the global scope. So if I need to call function 1, what will I do? I will just write the name of function and then I will pass the argument. And what is that argument? It is an argument of type of object of my class. So I have an object of my class, that is m1, and this function 1 is expecting an argument of what class? It is expecting an argument of my class. So over here this m1 gets passed on to m, and then I print m dot x. So you can see this x is a private variable. If this x is a private variable and my class is ending over here, see, this class only is from here to here. Okay, and I am accessing this x variable from outside the class. I am accessing this x variable from outside the class. If x is a private variable, then generally it is not allowed, but friend function can do this. Okay, like if there is some family friend, then he can come inside your family and he can, have some personal interactions with the members of the family. Similarly, the friend function can access the private variables of a class, private members of a class. Alright. So now I will clean and build this application. Build successful. And then once I go to, I will just run this application. So let us see what is output. CC 10, it is coming out. So I can write something like this. Inside the friend function, the value of x is, alright, like this. And then I will, I will give a new line marker like this. Alright. And then again I will go to clean and build this application, and then I will run this application. So once when I run this application, inside the friend function the value of x is 10. See, x is a private variable and the value that has been set for m1.x was 10. m1's x was 10, and that x I am accessing somewhere outside the class. So this is a friend function. Which function? The function 1, it is a friend function. So again let us go to my presentation. Friend functions are not members of a class, or not member functions of a class to which it belongs. Yeah, we saw that just because if I were to write m1 dot function 1, then it was giving an error. See, m1 dot function m1 dot function 1. If I write like this, then it will result in a compile time error. I cannot do this. That means function 1 does not belong to the class because it cannot be accessed through the object of the class. Friend functions are declared inside the class. Yes, I declared my friend functions inside the class. How I declared my friend function inside the class? I did it like this, and then I defined my friend function in the global scope outside the class. Okay, like this. Friend function can access any member of the class to which it is a friend. So over here, this function 1 is a friend to my class. So it has access to all the member variables and functions inside my class. So here the thing is that x is a private variable, but inside the friend function I can access the private variable. But there is a specific condition. What is the specific condition? I cannot do something like this. I cannot directly access x. See, x is a private variable. I cannot write directly accessing x. The value is, suppose I cannot directly access x. Okay, if I do like this, then it will result in an error. It is giving a compile time error, unable to resolve the identifier X. So you cannot directly refer a instance variable inside a friend function. You only do it indirectly through the object of the class to which the friend function belongs. See over here, friend functions are not associated with any objects. And then if you see the last point, friend functions access the members of a class to the object of the class. So if I want to access this private variable X, I cannot directly access. I cannot write cout as we saw. I cannot write like this. If I want to access X, then I have to write something like this. I have to access it through the object of my class. See, friend function belongs to my class. It is a friend of my class. Then if I want to access the private variables of my class, then I need to have an object of my class. And what is in this case the object of my class, my dear friends? It is M. So these are friend functions. So in the next video also we will study about friend functions. We will create a friend functions that will belong to two classes, and that will then access the private members of both the classes. So we will see it in the next lecture. So before trying to understand what are inline functions, let us first of all understand the need behind inline functions. So if you observe this particular piece of code, there is one function. What is the name of this function? The name of this function is the max function. Okay, this is the max function, and now this is my main function. And inside the max function, inside the main function, I am giving a call to the max function. Over here also inside the main function, I am giving a call to the max function like this. Alright, it is something like this. Now, the problem with this type of code is that inside the main function, a call is being made to the max function. So main and max function have different scopes. So it is something like this. Suppose this is your main function and this is your max function. So you know, it is main function is giving a call to this max function, and then it is passing some argument. Say suppose whatever it may be, suppose argument, it is passing two argument of which it needs to find the maximum. Say suppose the arguments are 10 and 20. Okay, so suppose in main function I have some particular pieces of code. Suppose this is the first line of code, this is the second line of code, and this is the third line of code, and then I make a call to max function over here. And then again there is a fourth line of code, fifth line of code, sixth line of code. It is going on like this. So the problem with this is that it executes these three line of code, then you know it has to make a call to this max function. So when it needs to call this max function, this main function needs to preserve its current state. This state it needs to preserve, and then this max function is executed, and once when this max function is executed, then again my main function resume its working from line number 4. So it needs to save its state in some kind of, you know, registers. It needs to save its space. So this is a very it is not a cheap operation, it is a very costly operation. So always remember that when you call functions, it is a costly operations. So by using inline functions, we basically want to minimize the cost of function calls. So I can do something like this. I can precede this function max with the keyword inline. What keyword? The inline keyword. Now when I precede this function declaration with the keyword inline, then what is gonna happen is that a call to this function will not be made. A call to this function will not be made. Instead, this function will be expanded inline. Okay, what does this mean? This means when you are calling max 10, 5, and inside this max function you're writing something like this. So call to max function will not be done. What will happen over here is that it will, in place of cout max 10, 5, it will write something like this. It will write 10 greater than 5 scope, and then a question mark, and then 10, 5. It is going to write like this. See, it is going to write like this. Similarly, in this case, when I am calling max 3, 40, then it is not going to call the max function, it is going to expand its definition inline, and here it will write 3, and here it will write 40, here it will write 3, and then 40. So that means this function is expanded, it is not called. So we saw in this, when I was telling you, we saw because calling a function in different scope is a costly operation. It involves a lot of overheads. So in order, if you want to minimize those overheads, we can make a function inline. And how do we make a function inline? By preceding the declaration, by preceding the function with the keyword inline. Okay. So when you make a function inline, it is not called. Its definition is expanded in the code itself. So because inline functions are expanded in the code, generally the practice that we follow is that inline functions should be very small, because if there are big functions, then your code will become very big. See, if this max function had suppose 200 line of codes, and I need to call this max function suppose 10 times, so my code will become 200 into 10, that means 2000 times. So generally inline functions are meant for very small functions. We make inline functions for very small functions. Let us now go to the my PowerPoint presentation, and inside this PowerPoint presentation I'm going to view it, and then let us try to understand inline functions. So inline functions causes a function to be expanded inline rather than called. Inline is just a request to the compiler and not a command, and the compiler can choose to ignore it. You know, this second point is very important. When you make a function inline, it is not a guarantee that the function will be expanded inline in your code. You are just suggesting the compiler, you are just telling the compiler, please make this function inline. For example, I give a layman example. Suppose you have a girlfriend, and you ask the girlfriend, will you marry me? Then it is the decision of the girlfriend. She may accept, she may reject also. Similarly over here also, if I want to make this function inline, then it is the decision of the compiler. It can either choose to make this function inline, and it will expand your code, expand the function definition in your code, or it can choose that this function will not be expanded inline. Generally the practice that we follow is that we never make recursive function inline. Okay, like this. And to create inline function, precede the function declaration with the keyword inline. So that we have done. And functions defined within the class automatically become inline. See this point, it is very important. So how can we understand this point? Let us try to understand with this with an example. So suppose I just remove it. This we have already seen, and I'm going to remove this also. Now what I do is that all right, okay, I have included it twice. All right, no problem. Suppose I create a class, and the name of my class is suppose I will take now the student class, and student has a serial ID and it has a name. Okay, so these two variables, these are the private member variables of the class, and then I can create a constructor of the class. How will I create the constructor of the class? Like this. What is the name of the class? It is student, and then I can write integer sid comma string name. All right, like this. And then because the names of the instance variable and the local variable are same, I will use this pointer, this arrow sid equal to sid, and this arrow name equal to, I can write like this, and I will end my class over here. Now I create a member function of the class, void display student. So I have two options. I have two options. Either I can just declare this, I can just declare this class inside, I can just declare this function display student function inside the class. Which class? Student class. And then I can define this class outside the student class. How will I do it? I will do it something like this. I have written as a, as a side note, when we define a function outside the class, we define a function outside the class using the format return type, class name, scope resolution operator, then the function name, and then followed by the argument list. So over here, if you observe the display student method, what is the return type? It is void. What is the name of the class? It is student, and then I will use the scope resolution operator, then the name of the function, and then the argument list. This function is, it is not taking any argument. So over here I am giving the definition of the display student function. So I can write something like this. What I can write, the SID of the student is, suppose SID, and then a new line marker, and then I will copy this code, I will paste this code, and then I can write the name of the student is, okay, name. I can write something like this. So over here, if you just observe, I have created the display student method, instance method of the student class. I have declared it inside the class, and then I have defined it outside the class. And how do you define it outside the class? You define it outside the class by first giving the return type. Over here the return type is void. Then you give the class name. Over here the class name is student. Then you give the scope resolution operator, and then you give the name of the function followed by the argument list itself. So here, if you just go and create an object of the student class, student, suppose S1 object, suppose it has an ID of 1 and it has the name Madhav, okay. Then I can call S1 dot display student. I can call something like this. All right. Yeah. Now if I go and run this program, clean and build, and then I run this program. Okay, this ID of the student is 1 and the name of the student is Madhav. So with this, I just wanted to bring to this point that instance method, we have two options. We can either define the function inside the class, or we can either define the function outside the class. And over here I have chosen the second approach. I have defined the instance function outside the class. And how I have defined it? By using this format. Which format? Return type, class name, scope resolution operator, function name, followed by the argument list. Okay, now this much is clear. But now you just move to this point. Now we come to this point that function defined within a class automatically become inline. Functions defined within a class automatically become inline. What does this mean? What does this particular piece of line means? See, if I comment out, if I want to make the display student inline, then I have to do something like this. Alright, I have to do something like this. I have to precede the student declaration, display student definition with the keyword. Which keyword? The inline keyword. In order to make this function inline, I can do something like this. So this display student will become inline, and once it has become inline, that means when I call the s1.displayStudent method, then the compiler can choose to expand this function inline. And if it chooses to expand the function inline, what will happen over here? It will happen something like this. Something like this is gonna happen. What? Like this. If I just I'm not going to compile it. I'll just comment it out so that you can just have a look at it. The ID of the student is 1 and the name of the student is Madhava. Okay, so this is expanded inline. So when I make when I make a call to the display student method, because display student is inline, it is expanded. Whatever is written in display student method is expanded inline over in my code. So this is just in order to make you understand inline functions. But now what I do is that, suppose I just go and I comment out this code. I do not want to I do not want to define display student method outside the class. Instead, I will define this method just inside my class. So how will I do it? This is what I've been normally doing it, you know. I've been doing it till now. So I can write something like this, and then like this. All right. This is it. So over here, this display student, I have declared and defined it within the class itself. Which class? The student class. The display student is now defined within the student class. So if you go to this presentation, functions defined within the class automatically become inline. So that means this display student method, I do not have to precede its declaration with inline keyword. It is automatically inline. It is automatically inline. When I define the function outside the class, then I need, in order to make the function inline, I need to precede its definition with the inline keyword. But that I do not have to do with the function when the function is, you know, it is defined within the class. So this display student is automatically inline. And you just keep this thing in your mind that inline keyword is just a suggestion to the compiler, that you just please make this function inline and expand its code whenever a call to this function is made. It is just a suggestion. The compiler may choose to accept it, or the compiler may choose to reject it. Okay. In this video, we will study about operator overloading. So it is a very powerful feature that has been provided specifically in C++ programming, and that is the operator overloading. So what is operator overloading? Operator overloading is I will try to explain it. What do I mean when I say I want to overload an operator? What do I mean by it? Overloaded operators. Okay, this is what we want to study. Suppose what are our operators? The plus operator. I'm talking about the minus operator. The suppose I say greater than operator, less than operator, greater than or equal to operator, less than or equal to operator. Or there can be many operators, you know. So there are many operators in C++, and they have their usual meanings. For example, I say that there is one integer a, and then there is integer, suppose there is another integer, suppose integer b, and when I write a and when I write b, so a plus b, suppose a is equal to, if a is equal to 1 and b is equal to 2, then this operator, I apply this operator plus operator to a plus b, and a and b are of type int, then a plus b is equal to 3. This is very simple. But now suppose I have suppose something like this. I have a provision like this. Suppose I have a class A. In this in it there is a variable, private variable that is declared num1, and I have a class suppose B, and suppose in it okay, so there is class A, suppose only there is one class A, and there is a variable that is declared, member variable, that is num1, and I create an object of class suppose a1, and and then I create another object of a class a2. Then the way I write a plus b over here, I add two integers. Can I add these two complex numbers? It is not possible, my dear friends. It is not possible. This will result in a compile time error. I can never like this. Basically what I mean over here is that if I say a1 plus a2, I mean that the num1 value of a1 and the num1 value of a2 gets added. Okay, see, a1 is having, because num1 is an instance member of the class A1 is having its own copy of num1 and A2 is having its own copy of num1. So what I want to happen is that the num1 values of A1 and A2 should get added. So I cannot do something like this. This is not possible for me. But yes, there is one provision in C++ in which you can actually do this. This is by operator overloading. For example, in this case, if you overload this plus operator, then you can do it. If you are still not clear, then let us jump on to the IDE, and I think that you will become quite familiar with operator overloading once you watch this introductory video on operator overloading. Say suppose I have a class and the name of the class is, say suppose, counter. This is the name of my class. Okay, the name of the class is counter, and in it I declare a variable, the count variable. Okay, there is only one variable, the count variable, and then inside the public I declare a constructor for the class. And how do I declare a constructor? I write something like this. I have taken this arrow count is equal to count. In this way I have declared a constructor in this class, and yeah, so here I am just going to end the class. Okay, so suppose if I want to add two complex numbers, then yeah, or suppose yeah, okay, I display one method, I create one method, display count, and display count inside I write the value of count is, and inside this I write this arrow count. Okay, I write something like this. Then just suppose I create an object of the counter class, counter c1, and inside this counter class suppose I say the value of count is 10 and then I call this method c1.displayCount. Suppose I call this, then what will be the output of this program? If I just go and run this program, clean and build, okay, build successful. And now if I go and run this program, what will be the output? See, the value of count is 10. Okay, the value of count is 10. It is very simple. Now suppose you just comment these two lines of code. Suppose I take an integer, and integer I, suppose I is equal to 10, and I say I plus plus. Okay, I increment the value of I, and then I say cout the new value of I is, and then I write I. So what will be the output of this program? It is very simple. It is very simple. I have taken one variable I have initialized it to 10, and then I have incremented the value, and then just let's see what is the output. Run. The new value of I is 11 because I use the plus plus operator, and plus plus operator over here in this case simply means that the value of I will be incremented by 1. Okay, the plus plus operator in this context means that the value of I will be incremented by 1. So this is happening for normal integers. But for example, I will switch on to my previous example in which I created an object of the counter class, and now I want to increment the value of count for this counter object by 1. Okay, if you are not able to understand that, I want something like this. Suppose this is the memory, and this is the c1 object, and it is having value 10. And now when I say plus plus c1, what I want to happen is that I want the value of count to be incremented by 1. So when I say over here that when I say, for example, when I say plus plus c1, I want the value of count here to be incremented by 1. But will this happen actually? Let us go and test it out. c1 dot display count. Let us go and test it out. Okay, so I will clean and build this application. Let us see what happens. My dear friends, it is not working out. See, there is an error. There is a compile time error over here, and if you actually go to the console, then see what is the error. If I just go clean and build, and if you actually go to the console, just see what is the error. See, no match for operator plus plus. Operand type is a counter. Yeah, very important over here. If you see, if it was an integer which we saw in the previous case, it was simply incremented. But over here there is no, there is no such kind of operator that is existing for the counter class that will increment it count by 1. See, I can do something like this. If I want it, then I can do something like this, void inc count and inc count, and then in this I can write, what I can write, I can write something like this arrow count is equal to this arrow count plus 1. I can do something like this, and in place of plus c1 I can write c1 dot what, inc count. I can do like this, c1 dot inc count, and then I go clean and build. It is taking some time. Okay. Yeah, build successful. And now if I go and run this application, see, the value of count is 10, and then the value of count is what? It is 11. So this is simple, but I don't want this in this way. See, so I have two options. Either I can use the c1.inc count or any other method like this that will increment the count by 1, or either I can do something like this, plus c1. So over here, if you observe, this plus c1 is a much more readable code. It makes my code much more elegant and much more self-describing, So I want somehow, if I write plus c1, that it should increment the value of the counters class count member variable by 1. This is what I want. So in this class, what I need to do, I need to overload the plus operator. This is what I need to do. I need to overload the plus operator. So how will I overload the plus operator? So over here, I will say operator plus, and this is the method in which I will so if you observe, it is the return type of this function is void, and then I am overloading the plus operator. So what I'm doing is that I'm just defining this function, declaring this function inside the class. I will define this function outside the class. So even you can, if you can define the function inside the class, but I'm in this case I'm taking a different approach. I'm just defining the function, outside the class. So what is the return type of the function? It is void. What is the name of the class? It is counter. Then the scope resolution operator, and then operator, and then plus, and then I write something like this. So this operator plus is also like any other member function of the class, and in this I just write this particular piece of code, copy, and then I paste it over here. Okay, like this. Now I can comment this code, and I can uncomment this plus c1. And now let us test, is this particular piece of code working? Is this particular piece of code working or not? So what I will do is that I will just go and clean and build this application, and I will run this application. See, now it is working fine, and it is also incrementing the value of count by 1. Why now it is working fine? Now it is working fine because, my dear friends, we have overloaded the plus operator. Okay, we have overloaded the plus operator. So overloading means that we have a given different meaning to the plus operator in the context of the counter class. So over here, if I write plus c1, then this will mean that increment the value of count of the c1 object by 1. Okay, now for example, suppose I can do something like this also, plus c1, and then I can write something plus c1. If I do something like this, then what will be the output? clean and build. And then I go and run this application. See, the output, the value of count was initially 10, and then I wrote plus C1 3 times. I incremented the count, value of count by 3 times by 1, and then the new value of count was 13. Okay, so one very important thing to notice over here is that when I write plus C1, then this function is getting called. My dear friends, which function is getting called? This function, void counter operator plus plus, is getting called. And in this function here we see, suppose I write on a side note, suppose I write plus I, and I is an integer, then this plus plus is an operator and I is an operand. Okay, so over here also, when I write plus C1, then plus plus is the operator and C1 is the operand. Okay, and this operand is making a call to the function. Which function? It is calling this function. So very important thing to keep in mind over here is that when we are inside the body of this function, the current object is C1. Okay, when we are inside the body of this function, what is the current object? The current object is the C1 or the operand. Okay, so I will explain it graphically also. See, this is your C1 object, and this is the the scope of, this is the scope of the operator plus plus method. So inside this, when I use this, then this is pointing to the current object. And then what is the current object? The current object is C1. So always remember that C1 is making a call to this operator plus plus function. Okay, C1 is making a call. That is why the current object is C1. That is when I write this arrow count equal to this arrow count plus 1. That means increment the count of the current object by 1. That means the count of C1 has been incremented by 1. If you are not able to fully justify it, then you can create another object of the counter class. Suppose I create another object of the counter class. Suppose I say the value of count is, suppose 24, and then I increment the value. I use something like this, and then I say C2 dot display count. Okay, C2 dot display count. So just so that C2's count, and then a new line, and then I will copy it, and over here I will paste it, and then I will write what? I will write C1's count. Oh, sorry, C1's count. Okay, so when I am writing C2 dot display count, then I'm okay, something like this. All right, now when I run this program, clean and build, and then I run this application. See, C2's count, it is equal to 25, and C1's count, it is equal to 13. So over here, when the call was made plus plus C2, then that means the current object was C2. That means that the count value of C2 was incremented. And when I said plus plus C1, for example, in this case I said plus plus C1, that means in this case the current object was C1. The function that was called was this function, and inside this function the value of the count of C1 was incremented by 1. So this is operator overloading. This video is just a continuation of the previous video, in which we overloaded the unary operator, the plus plus operator. And what do we mean by unary operator? It means it just takes one operand. And so I was writing, basically I was creating an object of the counter class. Suppose an object was suppose C1 object, and then I was writing plus plus C1, something like this. Okay, I was doing like something like this. So over here, this plus plus, this is a plus plus is a unary operator. That means it just acts on one operand, and this operand in this case is a C1, and this is the current object that is giving a call to this function. That is the operator plus plus, overloaded version of the plus plus operator function. It is giving a call to this function. Now, my dear friends, what I want to do is that I want to collect this value in a counter in another counter object. So if you're not clear, then I want to do something like this. Suppose let me create another object of the counter class, counter C2. Suppose I say like this: will this particular piece of code work? Let us go and test it out. It will revise our concepts of constructors. Is it going to work? No, it is not working out. Why it is not working out? Just see, it is not working. Candidate expects one argument, 0 provided. Why? Over here you saw when I create this object, C2 object, then there is no matching constructor for the C2 object. Why? Because we have created a constructor in the class, so the compiler is not creating a default constructor for this class. So that is why I can write something like this: count equal to 0. So now this piece of code will work. Okay, so I have created an overloaded constructor for the creation of this object also. That is a 0 argument constructor. See this constructor. Okay, so now what I want to do is that I want something like this: C2 equal to plus plus C1. C2 equal to plus plus C1. First of all, just let us see this now. Is this working? Is this error going away? Clean and build. Yeah. Okay. Clean and build. Yeah, build successful. It is working fine. I'll not run the application because it's pretty obvious. And now what I want is that I want something like this: C2 equal to plus plus C1. That means you increment the value of count of C1 by 1, and then you return this to the C2 object. You return it to the C2 object. So how will I go on to do this function? So I cannot, for example, if I run this application, clean and build. If I clean and build this application, see, it is giving compile time errors. Why it is giving compile time errors? No conversion, no known conversion from void to counter, something like this. Why it is giving this type of error? Because when I say plus plus C1, it is calling this overloaded operator function, and the return type over here is void. But now if I write something like this, that C2 is equal to plus plus C1, that means this operator, overloaded version of the operator plus plus function, is going to return a object of type counter. Okay, when it returns an object of type counter, then it is going to be copied into, then it is going to be copied into C2. How this is going to happen? Just see. Suppose now what I do is that I create I do something like this. Over here also in the declaration, I say that the return type is of type counter. Okay, and then I create object of the counter class, that is of, suppose the object name is temp, and then I can write something like this. What I can write: temp arrow count is equal to this arrow count, and then I can return temp. Okay, I can do something like this, and then now I write cout the value of C2's count is then a new line marker I will just end, and then I can write C2 dot what? C2 dot display count. Suppose I write like this. Okay, now if I go and run this program, then what will be the output? Clean and build. Oh, build failed. There are some compile time errors. Let us see what are those. Okay, I got it. All right. See, this is not an this is just an object of the counter class, so I cannot use the arrow operator. I will use the dot operator. Temp dot count equal to this arrow count. Okay, this is a pointer. Okay, this is a pointer to the current object. So I will just explain it also. I will just clean and build and explain this also. Okay, build successful. And then when I go and run this application, oh, it is not giving any output. Why? Okay. Copy. I have in the main method I have first given the return statement, so it is not executing anything, so I need to give the return statement in the end. Sorry for this mistake, this is a silly mistake. I'll just clean and build this application again, and then I will run this application. See, the value of C2's count is, the value of count is 11, so over here it is equal to 11. So how it is 11? Because C1's count was initially 10, and then I incremented the count of C1 by 1, and then that was collected in C2. The C1's count now became 11, and that was stored in C2. So now when I say C2.display count, its count is also coming out to be 11. If you are not able to get it, then let us try to visually understand it. Okay, so I will just open a new paint file. I don't want to save these changes. Suppose over here this is your main method, and in this main method you have created an object of this is the scope of the main method, and you have created an object C1, and then initially the value of count is 10, and suppose this is the scope of your the member function. Suppose this is the operator plus member function. So if you go line by line, then I have created another object C2. So once another object T2 is created, so C2 created, and initially the value of count for C2 will be 0. Then now the magic will start. So now when I call C2 equal to plus C1, the current, in this case the operand is C1, and the object that is giving a call to this overloaded operator plus function is the C1 objects. That is why when I say this arrow count, it means whose count? It means the count of C1, and then the count of C1 has been incremented by 1. So previously the count was 10, and now it has been incremented to 11. Now I declare inside another temporary counter variable, that is the temp. So in this scope, in the operator plus scope, you have created another object of the counter class, that is the temp object, and now you are saying that you are saying that temp.count. So temp.count equal to this arrow count. So this arrow count is what? This arrow count is equal to, see, I have done initially the count of C1 object was 10, and once I write that C1.count equal this arrow count equal to this arrow count plus 1, so now the count has become 11. So temp.count equal to this arrow count means temp arrow count is 11, and now once I return temp, then it is going to be copied into C1. So C1's count is also going to become 11. Okay, and now suppose over here I have returned this temp. Now this return temp is going to be collected in this which object? In the object C2. Okay, and then when I say C2.display count, then the count value of C2 will become 11. Okay. In this video, we will study about how can we overload binary operator. So in the previous video, we have seen how can we overload unary operators. We saw that we overloaded the prefix increment operator, the plus operator. We overloaded that operator. Now we will try to overload a binary operator. So binary operator, what is a binary operator? An operator that has two operands is a binary operator. Okay. Like for example, I open the notepad. Operator that has two operands is a binary operator. For example, I say that plus is a binary operator because it has two operands. Suppose there are two integers a and b, then I will write a plus b. Okay, so plus is a binary operator, and then minus is a binary operator, and then greater than equal to, it's a binary operator. See, these are all binary operators which take 2 operands. So now our task is to overload binary operator. So let us do that. So what I've done, I have taken one class, and which class? Suppose I have taken the distance class, and distance, suppose I am maintaining distance like this. I am maintaining the distance in feet and inches. So generally we like if someone is how much tall, then we say that he's like 5 foot 8 inches tall or 6 foot 2 inches tall. For example, a very popular Bollywood actor Amitabh Bachchan is 6 foot 2 inches tall. Okay, so we say that he is quite tall. Or someone can be very short, for example 4 foot 10 inches. So we want so now I've created a distance class, and I have not created a default constructor. So let me do that also. How will I do it? I will just I will write over here inches, and then I will copy it. I'll paste it over here, and in this default constructor I will set both of these values to 0. Okay, like this. I will set both the values to 0 because this is a default constructor. I can also say that the default constructor has been called. Okay, and I can say something like this also, so that you know, whenever these constructors are called, we can get an idea. The parameterized constructor has been called. Okay, so there are 2 constructors in my class, and then there is a show distance method. So let us create an object of the distance class. Suppose I create an object, and suppose a person is 5 foot 10 inches tall. Okay, like this. So the person is 5 foot 10 inches tall, so the distance is 5 foot and 10 inches. That is why I'm giving 2 arguments. So for this distance object, feet is setting to 5 and the inches is setting to 10. Okay, so now over here, suppose I say d1 dot show distance. This is very simple, d1 dot show distance. Okay, what I will do is that I will add new line markers over here. Alright, yeah. So let us go and clean and build this application, and then I'll run this application. We'll just see what is the output. Oh, build is failing. Okay, what is the problem? Okay, alright, it's a kind of typo error. Again, I'll clean and build this application, and then I'll run it. So this is very simple to understand. It has no issues, you know. So again, it is failing. I don't know. Oh, okay, alright. Clean and build, clean successful, and then I run this application. So you can see the parameterized constructor is called, the distance is 5 feet and 10. Okay, alright. Okay. Clean and build this application. Then again I am going to run this application. So the distance is 5 feet and 10 inches. Okay, so here if I create another objects of the distance class, suppose distance d2, and suppose d2 is 6 foot, and suppose he is a WWF fighter, you know, so his height is 6 foot 9 inches. This can be possible. Some persons have this amount of height, you know, 6 foot 9 inches. Some basketball players, they have this height. NBA players. Okay, so now what I want to do, I want to do something like this: d1 plus d2, d1 plus d2. So if I add d1 plus d2, so naturally over here I cannot do this because these are not, you know, these are not ordinary primitive variables like, you know, integers or floats. I cannot add them like this. So in the distance class, if I am adding the objects of the distance class, and in the distance class I need to overload the plus operator. So I need to overload the plus operator, and before overloading plus operator, let us try to understand mathematically. It's a kind of, it's a more of a like kind of mathematical discussion. So if I need to add these two distances, what two distances I need to add? 5 foot and 10 inches and 6 foot 9 inches I want to add. You see over here, 5 foot 10 inches and 6 foot 9 inches. So first of all, here you see this is the fit. So if I add all these 5 and 6, the result will be 11, and if I add both of them, then the result will be 19. Okay, so 11 feet and 19 inches, 11 feet and 19 inches, and we know that 12 inches is equal to 1 feet. Okay, it is like this. 12 inches is equal to 1 feet. So effectively the height will not be 11 foot 19 inches. It will be 11 plus 1 foot and 19 minus 12 inches. Why? So 13 foot and 7 inches. The height, 12 foot and 7 inches. Why this is the output? Because 12 inches is equal to 1 feet. So I subtracted 12 from 19, and then I was remained 7 inches were remaining, and because 12 feet is equal to 12 inches is equal to 1 feet, so 1 inch was added in the total of the feet. That was 11, so the feet became 12 and the inches became 12 comma 7. So 12 inches and 12 foot and 7 inches. Okay, like this. So if I want to add naturally I will do something like this. I want to do something like this. Suppose I create another distance d3, and suppose I want to say something like this: d3 equal to d1 plus d2. So what will be the return type? The return type will be distance. And what is the operator? The operator is the plus operator, and it is taking an argument of type distance. So why it is taking argument of type distance, I will try to explain this. See, I'll just remove d3 over here. First of all, let us try to understand d1 plus d2. What does this mean? So when I say d1 plus d2, always remember, my dear friends, that it is the operand on the left hand side that is making a call to the overloaded operator function. Okay, and the operand on the right hand side is getting passed as an argument. Okay, it is something like this. If you are not clear, then if you just observe, suppose so this is this is the overloaded operator function, and this is just the declaration inside the class. I am going to define this function outside the class. So what is the return type? It is distance. What is the name of the class? It is distance. Then scope resolution operator plus and dista, distance, suppose d. Okay, then I am going to define this function over here. I'm just going to define this function over here. There is some, okay, all right. So if you are not able to understand this, suppose I write C out this arrow feet. If I write C out this arrow feet, then what will be the output? You see, I will just write the new line marker after this also, new line marker. And then if I write something like this, clean and build, and then if I go and run this application, what is this arrow feet? You see, this arrow feet is 5. Okay, this arrow feet is 5, and for the d1 object, the height in feet was 5 foot. Okay, so for so the current object is the D1 object. So always what I told you, the operand on the LHS is the current object, or this is the operand that is making a call to the overloaded operator function. And if I do something like this, and this RHS operand is getting passed as an argument. So D2 is getting passed as an argument. So if I say D dot fit, so D2 dot fit, the RHS is getting collected in the variable D in the operator function. So if I, again clean and build this application, and then suppose, okay, it is taking some time. Yeah. Then I clean and build this. And then I run this application. Okay. Now the output, you see over here, it is coming out to be 6. So for the D2 object, the height in feet is 6 feet. Okay. So it is something like this. All right. So always this has to be kept in mind, that the current object is the operand on the RHS when loading binary operator, and the RHS operator, LHS, is the current object, and the RHS operator is getting passed as an argument. So what I will write, I will create an object of distance class, and temp dot feet equal to, I can write this arrow feet, that is a height in inches of height in feet of the current object, and then D dot what feet. Okay. Now I can write something like this: temp arrow inches equal to temp dot inches, this arrow inches, that means the inches in length of the current object, and then D dot, okay, inches, something like this. But now what we saw over here, it was like something like this. Suppose 11, it is coming out 11 feet 19 inches. So I have to do something like this. While temp dot inches is greater than or equal to 12, temp dot inches minus equal to 12, and temp dot feet plus. Okay, I have to do something like this, and then what I have to do, return temp. If I do something like this, then over here I'm just closing the function. So this is the overloaded operator function for if you want, if you want to add two distances, then I have overloaded over here the plus operator. Okay, so you can observe something like this. I think it is correct. And now let us go and run this application. So if I go to, suppose I say that distance D3 object we have created, and D3 is equal to D1 plus D2. Suppose I say like this, then what will be the output? I will not say D1 dot show distance. Then I will say D3 dot show distance. Okay, I will say something like this. Now all right, I will go to clean and build this application, and then I will run this application. Okay, yeah. Okay, the distance is 12 feet and 7 inches. So this was our expected output. See, I was like little faulty. 12 foot and 7 inches, and that is what is coming out in the output. The distance is 12 feet and 7 inches. Okay, all right. So this way we have overloaded the the plus operator in this example. So we have overloaded binary operator in this case, because binary operator, it is taking two operands. One operand is the D1 and the other operator is the D2. And always remember that the operand on the LHS will make a call to the overloaded operator function. In this case, D1 will be the current object. So when I say this arrow feet, it means the height in feet of the D1 object, and the second operand, that is on the RHS, will be passed down as an argument. Okay, so always remember this. And in this video we will just continue from the point from where we left off in the previous video. So in the previous video we saw how can we operate overload the plus operator. It is a binary operator. So now let us try to overload some more operators. Suppose there is one more binary operator and I would try to overload it. Suppose there is one operator, the greater than operator. Suppose A is greater than B. If A is greater than B, then I can say it is something like this. Okay, so you always do something like this. If A is greater than B, then you say, you know, something like C out A is greater. You write something like this. This is what we effectively want to perform over here. I want to write something like this, like if D1 is greater than D2, then I should be able to print that D1 is greater, or if then else, then D2 is greater. So in this way I want to do this. So always remember, suppose when I say A is greater than B, so inside this A is greater than B, the result is always Boolean. Okay, so in this case the return type will be what? It will be of type Boolean. Okay, so here the return type will be of type bool. And what is the operator? The operator is the greater than operator. And then inside this I am going to write distance D. Alright, so this is, my dear friend, this is just the declaration for the overloaded operator function, and then I am going to define it outside the class. So what is the return type? Bool. What is the name of the class? Distance. Then the scope resolution operator. Which operator we want to overload? We want to overload the greater than operator, and then distance D. Alright, so this is the overloaded definition. I have to write the overloaded definition for it, but before writing, let us try to understand this. Suppose I say D1 greater than D2. If I say like this, then over here again you observe that this is a binary operator, this greater than is a binary operator, this is the LHS operand, and then this is the RHS operand. So what we talked in the previous video, we always remember that the LHS operand is making a call to the overloaded operator function, and then the RHS operand is is being passed as an argument. So over here D2 is being passed in the argument D. Alright, it is something like this. And what is the current object? The current object is D1. So I will do something like this. I will go to so in order to compare these two heights, suppose one height is 5 foot 6 inches and the other height is, say, suppose 6 foot 9 inches. So I will do something like this. I will convert both of these height to inches. So suppose if the height is 5 foot 6 inches, then the total amount of inches will be 5 into 12 plus 6, and if the height is okay, if the height is 5 foot 10 inches, if the height is 5 foot 10 inches, then I will write 5 into 12 plus 10, convert it solely into inches, and then if the height is 6 foot 9 inches, then the total height in inches will be 6 into 12 plus 9. Okay, it will be something like this. So what is 5 into 12? 12 5s are 60, and then it will be over here the output will be 70. And what is 6 into 12? 72. 72 plus 9 is equal to 81. Alright, 72 plus 9 is equal to it is equal to 81. Okay, it is something like this. So now in this case 81 is definitely greater. So here I have two heights, and then what I will do over here is that first of all I will convert both of them into suppose I will say feet 1, and feet 1 will be equal to this sorry, this one that okay, yeah, integer feet 1, and this will be equal to this arrow feet into 12 plus this arrow inches, and integer feet2 I can write is equal to d dot feet into 12 plus d dot inches. So I converted both of them into, you know, I converted both of them into I will write inches 1 and inches 2 because I am converting both of them into inches. Okay, so I've done this, and then I will write return inches 1 greater than inches 2. If this is true, then return true, else you return false. Okay, so in this way I have overloaded the greater than operator. So over here I have overloaded the greater than operator. So suppose now I can write something like this: if d1 greater than d2, then I can write cout d1 object is greater, else I can write something like this: d2 object is greater. Okay, yeah, and then a new line marker. Okay, and here also a new line marker. Okay, yeah, let us see if it is working or not. Okay, let us see if this is working or not. All right, yeah, over here suppose I go and clean and build this application, and now if I run this application, what will be the output? Run. Yeah, d2 object is greater. Yeah, okay, you see d2 object is greater. Suppose I do one thing, I purposefully I make d2 to be 5 foot, suppose 3 inches, then naturally you know, d1 will be greater than d2. So in this case d1 object is greater, it should be printed. So let us see what is the output. I will clean and build this application, and then I will run this application. So now you see d1 object is greater. Okay, so we have overloaded the greater than operator. So now there is one more operator, there is one more binary operator, and that is plus equal to operator. What does plus equal to operator means? Suppose A is having the value 10 and B is having the value 20. If I write A plus equal to B, then what does this mean? This effectively means that A is equal to A plus B. Alright, it is something like this. So effectively the result is getting stored in A. You know, the result of performing the addition of A and B is getting stored in A itself. Alright, so now we want to do something like this. What we want to do, suppose if I write something like this, I want to write something like this. So I will comment this particular code. I will not I'm not going to use it right now. Let us try to understand this. So what I want to do, I want to do something like this: d1 plus equal to d2. So what will it mean? It will mean that d1 equal to d1 plus d2. What will it will mean? d1 equal to d1 plus d2. This will mean something effectively like this. Alright, so over here also, if you observe, the operand on the LHS is d1 and the operand on the RHS is d2. So always what we saw in the previous case, that when we overload the binary operator, then the operand on the LHS is going to make a call to the overloaded version of the function. So here also I will write it something like this: operator plus equal to and distance, suppose d. So why the output in this case is void? Why the output in this case is void, and why the output in this case is distance? The output in this case, if you are overloading the plus operator, is distance, because you know, when you are performing the addition of d1 and d2 and you were putting it into d3, you just observe this highlighted code, you were putting into d3, you know. So the result of addition on d1 and d2 was being passed to d3. So you needed to create a temporary object of type distance, and then you needed to, you know, you needed to return that distance. So that is why the return type of this is distance. This, when you overload the plus operator, the return type is distance. But when you are performing an operation like this, d1 plus equal to d2, the result is getting effectively stored in d1, that is the current object. So in this case you do not need to return anything, so that is why I have kept the return type to be void. So that is why the return type has been set to be void. So over here I will just go, I have just declared it, now I will define it. So what is the return type? Void. What is the name of the class? Distance. Scope resolution operator. What is the operator? The operator is the plus equal to operator, and here distance, suppose d. All right, okay, something like this. All right, so what will I write? I can write something like this. This arrow feet equal to this arrow feet plus d dot feet, and this arrow inches equal to this arrow inches plus d dot inches. And then, you know, because inches can be greater than 12, so as many times they are greater than 12, I have to keep on subtracting 12 from the from inches, and then I have to keep on incrementing the feet by 1. So it is the same as what we are doing over here. So while like this arrow in inches is greater than or equal to 12, this arrow inches equal to this arrow inches minus 12, and this arrow this arrow feet plus, and I do not need to return anything because this is getting set in the current object itself. So we will graphically see it also. To make it more clear, we will just see this. We will graphically see it also. Okay, so let us just go and try to understand this. So I have written d1 plus equal to d2. Now I will write d1 dot show distance. If I write d1 dot show distance, that means d1 will store the sum of d1 plus d2. So over here, what should be the effective output? Let us just go and clean and build this application, and then I am going to run this application. Let us see what is the output. Okay, the distance is 11 feet and 1 inches. Yeah, the distances will be 11 feet and 1 inches. Why? Because 5 foot 10 inches and then and 5 foot 3 inches. So if you have 5 foot 10 inches and 5 foot 3 inches, then what will be the sum? New. Don't save. You have the distance as 5 foot 10 inches and 5 foot 1 inches. So 5 foot and 5 foot will make then 10 foot, and then 10 plus 11 equal to 10 plus 1 equal to 11. So 10 foot and 11 inches. So over here you are getting the same output, you know. Sorry, it is 3, all right. Okay. So this is just mathematics. I think you can adjust to it. I have mistakenly, I have not, it is not 1. It is 3, you know, it is 3. So it is not 1, it is 3. So effectively it is 13, and then once you subtract 12 from 13, then you will increment the number of feet by 1, then it will become 11 foot and 1 inches. Okay, so this is the output that we are getting. So output is also justified. Okay, it's a like small amount of mathematics that is involved with it. So let us try to understand this. So over here I will just try to explain it in just a minute so that things are clear. Okay, so here you are writing this arrow feet. So this arrow feet means the current object's feet is equal to 5 plus d dot feet. So d dot feet was also 5. So I think this is self-explanatory. I don't think I need to explain it. But still, if you want, I can do it. I have no issues doing it. I will open a new don't save, so that you can, I don't want to, I am making these videos for just, persons who want to learn from very basics. So I will take them. Suppose the first is 5 foot and 10 inches, and this is the, and then second height is, this is 5 foot and 3 inches. 5 foot and 3 inches, and then you are writing something like this. So this is the current object which is being pointed by this pointer, and this is the D object. Okay, so what I'm writing, this arrow feet equal to this arrow feet, so this arrow feet is 5, and then D dot feet is also 5. So over here the value that is being written is 5 plus 5 equal to 5 plus 5 equal to 10. And then I am writing this arrow inches equal to this arrow inches plus D dot inches. So this dot inches is 10, this arrow inches is 10, and then D dot inches is 3. So over here what is being written is now 13 is written. So now while this dot inches is greater than or equal to 12, yes, it is greater than or equal to 12, then you are subtracting 12 from the amount of inches. So it is becoming 1, and you are adding 1 to the number of feet. So it is becoming 11. So then you exit the while loop, and then this is now my current object state. The current object state, that is the D1 object state, is something like this. So the D1 object now effectively looks something like this. It is 11 foot and 1 inches. So effectively you are making modification in the D1 object itself. That is why you do not need to return anything. That is why the return type of this function is set to void. Okay, and that is what we are getting in the output. All right. So what all operators we have overloaded over here? We have overloaded the plus equal to a binary operator, then we have overloaded the greater than binary operator, in which case the return type was of type Boolean, and then I have overloaded the plus operator. So so this will end our discussion of overloading binary operator. Now we will try and continue with overloading some special kind of operators, and then also operator overloading through the use of friend function. This also we will discuss this in the upcoming videos. In this video we will study about operator overloading. So we have already studied about operator overloading, and we saw how can we overload unary operators and binary operators. All that we saw, this is what we saw. For example, we took the class distance and we overloaded some binary operator. For example, this plus was one binary operators. We saw how we can be overloaded, then greater than and plus equal to. All these binary operator I overloaded. Now today we will try to understand how can we overload operators with the help of friend functions. So if you are aware of what are friend functions, then I will just going to revise that friend functions are not member functions of the class, but they are allowed to access the private members of the class, and they do not directly access the private members of a class. They access the private members of a class through the object of the class. So these are friend functions. So if you want to create a friend function, then how do you create a friend function? You create a friend function by writing the keyword friend. Okay. So now what I want to do, I have for example, I'll just remove this code. It's not relevant. I'll just remove this code, and I create an object of the distance class, suppose d1, and d1, suppose I say the length is 5 foot 6 inches, and then I create another object of the distance class, suppose d2, and say suppose it is 5 foot 3 inches. This is the way it is, and then I want to add d1 plus d2. Okay, I want to add d1 plus d2, and suppose I say that distance d3 equal to d1 plus d2. So over here I want to overload this plus operator. So what we have seen till now, is that if we overload the plus operator, then the operand on the LHS makes a call to the overloaded operator function, the overloaded operator function, and the second argument is passed as an argument. But my dear friends, when we are overloading through the friend function, then keep this thing in mind that both the LHS, the sorry, the LHS on the operand on the LHS and the operand on the RHS are passed as as an argument to the friend function. For example, in this case, D1 is the operand on the LHS and D2 is the operand on the RHS. So both of them will be passed as an argument to the friend function. So how it will be done? So one thing more you can observe is that the sum of D1 and D2 is being passed to D3. That means the return type of this friend function itself will be of type distance. So return type is of distance operator, and which operator I want to overload? The distance, the plus operator I want to overload. And in this I will take one object of type distance and the other object also of type distance. So in this way I created the friend function. So now I will go on to this is just the declaration of the friend function. So outside the class I am just going to define the friend function. So how I will define the friend function. So what is the, so once you make the declaration, then you write friend. So this function means it is a friend of the distance class. This function is a friend of the distance class. So once you define the friend function, you need not write the keyword friend. You just go on to write the return type. So return type is of distance, and what is the name of the function? It is operator, and then two arguments, distance D1 and distance D2. Okay, these two arguments are being passed as arguments. Okay, these two are being passed as arguments. So the code over here is very much similar to what I have written over here. If I just copy it, if I just copy this code and then I'll just paste it over here and then perform some modifications. So how will I perform the modifications? So the temporary distance object that has to be written will always be created. This will always be done. And here I'm writing this arrow feed. So this arrow feed, in the previous example it meant the current object feed, but over here it will means D1 dot feed, and here it will mean D2 dot feed. Okay, and then also similarly in this case I will write D2 dot inches and plus D1 dot inches. I'm going to write like this. Alright, I'm just going to remove this arrow. Alright, yeah, D1 dot inches plus D2 dot inches, and then I have written, so now I perform the usual calculations, you know, till the inches, total inches is greater than 12, I keep on subtracting 12 from the total sum of inches, and then I keep on incrementing the feet by 1. Okay, why? Because 12 inches is equal to 1 foot. Okay, alright, so now I have written this temp. So temp is holding the sum of D1 and D2. Alright, it is something like this. So let me do one thing over here. When I have let me comment this piece of code, because you know this is calling the overloaded operator function. This is the member function of the distance class, and I want to overload the plus operator through the friend function. This is what we have seen. This is overloading the plus operator through our usual way, in which it is an instance member, and you know the operand on the LHS was a current object, and on the RHS was being passed as an argument. So let me comment out this piece of code, and let me comment out the declaration for this piece of code also. Alright, like this. And then what I will do, I will so D3 is having the sum of D1 and D2. I will say D3 dot show distance. Okay, I will say something like this, and then I will go to clean and build and run this application. Let us go and see what is the output. The output. Okay, all right. Yeah, build successful. And now when I go and run this application, run, just see what is the output. The distance is 10 feet and 9 inches. Yeah, and it is justified. Why it is justified? Because you see over here D3 dot show distance. So D1 is 5 foot 6 inches and D2 is 5 foot 3 inches. That the sum will be 10 foot and 9 inches. So this is justified. We can justify the whole output also. Suppose what is the whole output? I'll just minimize this. What is the whole output? If you oh sorry, I'll just run this application again and just see, you know, just verify the output. Yeah, just minimize it and then I'll open it. Okay, like this. Oh, like this. So inside the main function, suppose when you are creating distance d1, then the constructor is parameterized constructor is called. Then you create d2, then again the parameterized constructor is called. And then once inside this inside the class, when you are creating object of say suppose distance temp, when you're creating inside a temporary object inside the overloaded operator function, then again the default constructor is being called, and then the output is being displayed as what? The output is being displayed as a it is being displayed as d3 is equal to d1 plus d2. All right, like this. So I'll just close it and I'll maximize it. Okay, so this is what we have seen till now. And there is one thing that you can do on your own. You can add a overloaded copy constructor in this in the distance class, and then you can see what will be the output in that case also. Okay, just try to do it on your own. If you have any confusion, then you can watch my videos of copy constructors. All right, so friend functions can also add some flexibility to operator overloading in some cases. Let us see what are those cases. But now what I want to do, in order to study those cases, let us do one thing. I want to do something like this. I want to say d1 plus say suppose 40. I want to say d1 plus 40. So what I will mean if I say d1 plus 40, I will mean that add 40 inches to the distance d1. Okay, if I say d1 plus 40, then I mean that you add 40 inches to d1. So this is my overloaded constructor. When I say something like this, then I mean that you add 40 inches to d1. So I will do it with the help of friend function. So I can even do it with the help of instance function, and I can also do it with the help of friend function. So if I do it with the help of instance function, then in that case this object will be the current object, and this object, the 40 which is on the RHS, will be passed as an argument. And if I do it through a friend function, then both of them has to be passed as an argument. So what I will do, for the sake of clarity, I will cover both of the cases. So first of all, let us try to do overload this this thing with the help of the instance function, creating an overloaded instance function for doing this thing. What do I mean when I say that I am creating an overloaded instance function for adding 40 inches to the distance? So I mean something like this. So here when I say so this is your declarations. Inside the declaration I will say something like this: distance operator plus and integer inc. Suppose I say inch. So what does this mean? This means that the return type is distance. Then the operator that has to be overloaded is the plus operator, and the argument that is being passed is the amount of inches that has to be added to the total distance. Okay, it is something like this. So over here I am going to, so this was just the declaration, then I am going to define. So how I am going to define? I am going to define what is the return type. It is of type distance. What is the class name? It is distance. And then the scope resolution operator, and in operator, which operator? The plus operator, and then it is taking an integer argument, that is the total amount of inches that has to be added to it. Okay, so what I will do, suppose I will go to this paint, and suppose you have a distance, say suppose so this is just pure mathematical type of thing. Suppose you have 5 over here, suppose yeah, okay, 1 minute. Suppose it is something like this, that you have 5 foot and 3 inches, and then you want to add 20 inches to it. So I am going to approach it. You can have different approach. I am going to first of all convert it to total amount of inches. So for what will be the total amount of inches? It will be 5 into 12 plus 3. Then that will be equal to 12 5 is 60, 63, and then plus 20 it will be equal to then 83. and this is the total amount of inches, and then again I will convert into, you know, feet and inches. So like this way I will keep on, I will do it. So let us try to do it. So over here, first of all, so it is, you know, I think it can be a little boring for you because it is pure mathematical stuff. So suppose I say total inches equal to what? It will be equal to the current object feet into 12 plus the current object inches plus the amount of inch that we want to add. So this will be the total amount of inches. Okay, this and here I can say something like this, distance temp, a temporary variable of type distance. Okay, and then I can do something like this. Yeah, I will say, I will not say total inches, I can say temp dot inches is equal to this, and then I will write this for loop. Okay, I can write this for loop, and inside this I'll just paste it, and then I will return temp. Okay, alright. So my dear friends, just remember that I am overloading this plus operator not with the help of friend function. This is this is just the normal instance function, and I will you know, after this I will just overload it with the help of a friend function to make things clear. So here, if you go and suppose you comment out this code, and then you write distance d3 equal to d1 plus 40, and then you say d3 dot show distance. So what will be the output if I just go and I will write C out over here, the function for adding inches to distance has been called. Okay, and then I will add a new line. Alright, now I will just go. So this is just, you know, as a proof, so that we can say that this this overloaded operator function has been called. Oh, there is some error. Okay, what is the error? Okay, I think if I just add this, I think then the error will go away. Let us go again and clean and build this application. Again it is giving some error. Okay, temp dot inches equal to this arrow feet. So this is the distance in feet into 12. That means the feet of the current object into 12 plus this arrow inches plus inch. So I don't know what is the kind of error that. Okay, alright, yeah, I got it. I had added integer before it, so this was not the case. Again, I'll just go and clean and build this. I think now it will run fine. Yeah, it is running successfully, and then I will go and run this application. Okay, see, the distance is 8 feet and 10 inches. Is this output justified? Just go. Suppose the distance is 5 foot and 6 inches, and then you add 40 inches to it. So you can, I mean, we can perform this mathematical calculation if you want. Suppose what is the distance? It is 5 foot and 6 inches. So if I just go over here, it is 5 foot and 6 inches. Then this will be equal to 12 into 5 plus 6 plus 40, the new amount of new inches that we want to add. See over here. Okay, so what it will be, 12 feet, 12 5 is 60, then 66 plus 40, so it will be equal to 106. 106. And what the output we are getting? The output that we are getting is, if I just clean and build this, and then if I run it, then what is the output we are getting? 8 feet and 10 inches. So what is 8 feet and 10 inches? 8 feet and 10 inches. So over here, if you go 8 feet and 10 inches. So that is equal to 12 into 8 plus 10. That is equal to 96 plus 10, and that is equal to 106. So this is the output is justified. So this is, I just did it so that you can justify the output, that it is coming out to be correct. I'll just minimize it. And now, my dear friends, without taking much of your time, I will try to perform the same operation with the friend function. So always remember that when you were not doing it with the help of friend function, then the operand on the LHS was making a call to the overloaded operator function. But now when you do it with the help of friend function, then both of them will be passed as an argument. So how will I do it? I will first of all, I will make the declaration for this. How will I make the declaration? I will make the declaration something like this. So in order to declare a friend function, you use the keyword friend. Then what is the return type? It is of type distance. And then what is the operator? The operator is a plus operator. And then you have two arguments. The first is the distance, and the second argument is of type int. Okay. And I will, again, to not have clashes, I will comment out this piece of code. And over here, from here also, I will just comment out this piece of code. And now I will write to I have declared the function. Now I will define it. So what is the return type? Distance. What is the name of the function? Operator plus, and it is taking two arguments. One is of type distance d, and other is of type the amount of inches that has to be added. And we can see that the code in this case also will be almost similar to what we have done over what we have done over here. If I just go copy this code and uncomment it, and we can write, instead of writing this dot feet, I will write d dot feet. Okay. And instead of writing this arrow inches, I will write d dot inches plus inch. Okay. So if you do this also, then also the output will be, it will be justified. So here I will write the friend function for adding inches to distance has been called. Okay. So when I go clean and build, and now I run this application. See, the friend function for adding inches to distance has been called, and then again you are getting the same output. The distance is 8 feet and 10 inches. So this kind of overloading friend function can add some kind of flexibility in your code. What kind of flexibility it can offer? Suppose you say, I say that you don't add, suppose over here I have set d1 plus 40. Then I don't want to say d1 plus 40. I want to say 40 plus d1. I want to say something like this. So if it was d1 plus 40, then if you are overloading this plus operator through normal instance functions, then d1 will be the current object which will make a call. The operand of the LHS will make a call to the overloaded operator function. But if I say 40 plus d1, then on the LHS you have an integer, and integer it is not a kind of object of the distance class, so it cannot make a call to the overloaded operator function. So in this case, what I need, I need to overload the plus operator with the help of friend function. So this is what I want to do. So in this case, what I will do something like this. Again, I will create a friend function. Return type will be of distance. the operator will remain to be the same, that is the plus operator, but in this case the first argument will be of type int and the second argument will be of type distance. And this code, you know, it is quite easy to write this code. How? Like this, copy, and then I will go to paste this code, and here if you go, the first argument is the amount of inches that has to be added to the distance, and the second argument is the distance itself. Okay, so here you see you are overloading again. Yeah, it is doing something like this. So I can also write something like this: see out the new overloaded friend function has been called. Okay, I can write something like this, and then I add a new line to it. Okay, all right. Yeah, I do something like this. So this is, I have just, you know, I have added this cout statement print, you know, for just proving this, that this function is actually getting called. So over here, once when I write 40, d3 is equal to 40 plus d1, then, you know, clean and build. And then once when I go and run this application, see what is the output. The new overloaded friend function has been called. The friend function for adding inches to distance has been called, and then again it is performing the same thing, and then the output is again 8 feet and 10 inches. Okay, it is something like this, and this is, you know, it can be a classic example of what you call as operator overloading, or you can understand what do you actually understand by overloading. So you have the same function over here. You see, you have the same function. The same function is the operator plus function over here, you know, but you are having two overloaded version of the same function. One is having first an argument as integer, and then the second argument as distance, and this function is having the first argument as of type distance and the second argument as of type int. So these are two overloaded function, and depending upon the argument list that you supply, the exact version of the overloaded function will be called. Suppose I say d1 plus 40. If I say something like this, then, you know, this line, the new overloaded function has been called, will not be printed on the console. If you just go and clean and build this, and then when you go and run this application, see, the friend function for adding inches to distance has been called. So that means which overloaded friend function was called? This particular overloaded friend function was called. So yeah. So in this way, you see, friend functions can add some flexibility, because once when you say d1 plus 40, then, you know, you can do it with the help of instance functions of the class. But once when you say 40 plus d1, then it is not possible, because on the LHS you are having an integer. An integer cannot make a call. It can never be a current object. So this way, friend functions, you know, overloading through friend functions can add some flexibility to your operator overloading. Okay. So inheritance, it's it's one of the cornerstones of object-oriented programming, and any object programming language you choose, whether C++, Java. So inheritance is the most prominent feature of any object-oriented programming language. So what is inheritance? So in order to understand inheritance, let us I'll just go to the next slide. So okay, over here. All right. So inheritance is a generalization to specialization strategy. Inheritance is a parent-child relationship. The child is a type of parent, and inheritance is used to enable code reuse while designing classes. So all that I have written, but how can we understand all this? So in order to understand this, let us take one example. Suppose I have a vehicle. So vehicle can be of two types. It can be either an automobile, or it can either be a pulled vehicle. Similarly, an automobile can be a car, or it can be a scooter. Similarly, a pulled vehicle can be a rickshaw, or it can be a bicycle. So if you go to the previous slide, So notice the first point. What I have said, inheritance is a generalization to specialization strategy. How it is a generalization to specialization strategy? For example, here you see that vehicle is a kind of very generalized class. Okay, it does not have many features. But if you go to the scooter, then it is very specialized class. How it is a specialized class? Because in the scooter we know, because scooter is, because vehicle can be of any type of vehicle, it is very generalized phenomenon. But scooter, I know that scooter, if you're talking about scooter, then it runs on two wheels. Okay, then it is, it doesn't resemble the structure of a bike. And then if you talk about a car, then car has the car has specific features. For example, car has four wheels, then car has some music system, then car has inbuilt AC, then car has an auto lock. So these are features that are specific to a car. So these are specialized features of a car. Okay, so we are moving from the generalized classes, then we are moving to the very specialized classes. For example, if you see a bicycle, then bicycle is a kind of specialized class. How it is a specialized class? Because we know, because bicycles, generally they don't run on any kind of fuel. You have to pedal a bicycle. And rickshaw, they have a special features that they are of, it is it is of three wheels. So these are the specific features of the rickshaw. So it is a kind of, we can observe, it is a kind of generalization to specialization strategy. So how come this generalization to specialization strategy is helpful in designing classes? See, if you construct a building, let us take a very layman example. If you construct a building, so when you construct a building, it is not like that you construct the top floor. It is not like that. First you what do you say in Hindi? You say, if you are aware of Hindi में बोलते हैं कि पहले ज़मीन की खुदाई होती है और पहले नींव रखी जाती है. First you plug the land, and then you make a proper setup in the land, and step by step you go upwards. You start from the ground level, then you move up, and then you move up to the top floor. So it is a kind of, you start building things from the very bottom, and then you go up. So that is the phenomenon in life also, my dear friends. If you want to be successful in life, then first of all your base should be very strong. If you have a strong base, then you can move up in life. So similarly, that was on a side note. But in case of inheritance, in the context of inheritance, you first build the base classes, and then from those base classes you make the derived classes. Okay, it is something like that. For example, I have another structure. Suppose an animal can be a type of mammal, and animal can also be a fish. A mammal can be of type bird or tiger, and the bird can be of parrot and dove. So it is another example stating how inheritance is working in this. So these are all inheritance relationships. Then the second point is that inheritance is a parent-child relationship. So how come it is a parent-child relationship? See, over here if you go, so you can say that bird is a kind of, it is a kind of parent, and there are two classes that are deriving from this parent, the parent and the dove, the parrot and the dove class. And the inheritance is always is a relationship. So is a kind of test for inheritance. For example, I can say that a mammal is an animal, a fish is an animal. Okay, I can say that a bird is a mammal, and tiger is a mammal, a parrot is a bird, a dove is a bird. Okay, and this is a relationship can also extend upwards the inheritance strategy. For example, suppose I can say parrot is a bird also, and parrot is a mammal also, and parrot is an animal also. But this is a relationship is not between sibling. For example, I cannot say that mammal is a fish. See, mammal and fish are two siblings. They are the child of animal class. But is a relationship does not exist between them. Okay, so always remember the test for inheritance is a test for inheritance. Okay, so this is what is inheritance all about. So now let us go and try to understand about inheritance. Okay, over here. So one of the key advantages of inheritance is code reuse. So what is code reuse? Code reuse means that you have designed some class, and now you want to add some extra feature to the class. Okay, you want to add some extra feature to the class. If you want to add some extra features to the class, then suppose I have a class, suppose student. Okay, I have a student class, and suppose I have a class, alright, student class, and I say that public and void eats. Okay, and in over here I can write cout the student is eating. Okay, I can say something like this, and then I will give a new line marker. So this is very simple. I have just designed a student class. Okay, like this. All right, sorry, yeah. So I've designed a student class. Now a student has a behavior that it eats, and suppose I say that student has a behavior that copy paste, that a student also, I say a student sleeps. Okay, the student is sleeping. So these are the two behavior that are specific to the student class. Okay, a student has these two behavior. Now I want to add one more behavior to the student. Suppose a student dancing. Suppose a student dances also. Okay, so I have two options. One of the options is that I will add one more method over here, and I will say that this method is the what method? It is the dances method. Okay, a student dances also, but this in many cases it cannot be possible. Why? Because my requirement sometimes may be like that I have already designed the student class, and now I do not want to make any changes to the student class. And in many cases, you may not be given the student class to make any modifications in the existing class. So for that purpose, if I want to add a new behavior to the student, what I can do is that I can derive a class from the student class. How I can do it? I can do it something like this. Suppose I can make a new class. Suppose the new class is dancing student. Okay, dancing student, and it is, I can write public. I will explain this what I say what I mean when I say public student. I will explain this, but before this, let me explain it. I will just suppose dances, and this is the dances method. Okay, and then I will add the semicolon over here, semicolon. Okay, so now you have a student that is a dancing student. So a dancing student, my dear friends, it is also a kind of student. A dancing student is also a student. All right, so over here, if I go to the main method, and first of all I will say return 0, and then suppose I say I create an object of the dancing student. How will I make? What is the name of the class? Dancing student. And suppose I make an object d1, then I can say d1 dot eats, d1 dot sleeps, and d1 dot what? Dances. Okay, so I know that you also dance many times. When we are happy, then we dance. Okay, so we should be always happy so that we can dance always. Okay, and if you eat and sleep properly, then automatically you will get the energy to dance. All right, I'll just run this. You see, the student is eating, student is sleeping, and student is dancing. But now, my dear friends, if I just observe this class, for example, I will not go into the details of inheritance, what is public, accessibility modifier, visibility modes. I will not go into all these terms in this lecture. We'll do it in future lectures. But here just try to understand that I have created an object of which class? I have created an object of the dancing student class. But how come a dancing student, in the dancing student class, my dear friends, if you go there, the dancing student can only dance. But how come I have created an object of the dancing student class d1, and how come through the object I can perform the eat and sleeps operation? How can I perform these operations? I can perform these operations, my dear friends, because dancing student is a student. So when dancing student is a student, it can dance also, and it can also do what a student can do, because a dancing student is inheriting from which class? It is inheriting from the student class. Okay, so over here you see that the dancing student can also sleep, it can also eat, and of course I have added one more feature, that is the dances feature. Okay, so here you say, so I have extended the functionality of student, I have extended the functionality of student. Okay, suppose I say normally students don't like to study, but I can say something like this. Suppose I go over here, I just make a copy, and then I say normally this will not be true, students generally do not study, but I say study student. Okay, the student studies. So if I make an object of this class, suppose study student, I make an object of the study student class, then I can say d1 dot what, study. Okay, and if you just go and suppose clean and build this application. Oh, build failed. Why it is failing? Okay, yeah, let me do something like this. Dancing student. Okay, I will explain it graphically also, I will explain it, don't worry. Clean and build, and then I will just run this application. Okay, run. Yes, the student is eating, sleeping, dancing, and what? It is studying also. Okay, so it's a rare combination. But if we try to understand this, how is it working? Let us open a new paint file. I don't want to save the changes. So here, if you observe, it is a kind of sorry, yeah. Suppose I'll just take the brush, and here if I go, then I have one. Okay, all right, yeah, I have one class, that is the student. Okay, this is the student class. So student is eat, student sleeps. Then I have one class that is being derived from the student class. See, it is the dancing student. So I can write dancing. Please ignore my writing. I'm trying to do the best what I can do. So a dancing student, it is inheriting from which class? It is inheriting from student class. So it inherits the behavior of student class. That means it can have the eat method, it will have the sleep method, and it can also add some functionality on its own. And it has added a functionality. What functionality it has added? Dances. Now suppose I go and I inherited one more class. I have created one more class, and this class I have inherited from the dancing student, and I have this class is the study student class. Study student. Okay, so the study student class inheriting from the dancing student, so it can eat, it can sleep, it can dance, and what it can do also, it can study also. So I've already said that this is a very rare combination. Okay. Normally, today's student, if they study, then they don't remember to be happy and dance and eat properly and sleep properly. But I would say that if you go all these four things, you eat properly, you have proper rest, and you joyfully dance and you study also, then your life will be a success. Okay, like this. All right. So here I've explained the basic meaning of inheritance. Please just ignore what I've written over here, how I've written public and then student. Just remember that there is one student class. The dancing student class is inheriting from the student class, and the study student class is inheriting from the dancing student class. If I just say, my dear friends, suppose I say over here, I don't say, suppose the study student is inheriting not from the dancing student, it is inheriting from the student class. then why you have this red mark over here? Why you are having this red mark over here? Can you tell me why you are having this red mark over here? You are having this red mark over here because now in this case the study student is not inheriting from the dancing student. It is inheriting directly from which class? The student class. So that means it does not have the dances method. Okay, all right. I think I'm clear. See, okay, I'll explain it. So so that things are just in this case, this dancing student class is not inheriting, the study student is not inheriting from the dancing student. So it is having the method sleep, eat, sleep, and then one method what? Study. It does not have the dances method. That is why it is giving a compile time error. Okay. This video we will study about the accessibility modifiers. So when you talk about C++, so there are three kinds of accessibility modifiers in C++. One is a public, the other is a private, and then the protected accessibility modifier. So let us try to understand them. And so what I've done, I have designed a table, and we will keep on filling this table. So suppose I have a private accessibility modifier. Suppose private accessibility modifier means that suppose you have a class, and in that class one variable is private. So is that variable accessible from within the class? See, I've written over here the same class. Let us go and test it out. Okay, so how will we test it out? All right, I'll jump to the ID, and then over here suppose now I create, there is one student class, and I create an object of the student class. Suppose student class S1, I create an object, and then I say S1 dot display. Okay, let us see what is the output of this program. I'll just go, and then I will clean and build, and then I will run this application. Oh, it is having some error. All right, yeah, I just some typo errors are there. Let us remove them. Save the changes. Again, I'm going to clean and build this application, and then I'm going to run this application. So let us see what is output. The name of the student is okay. So I have not initialized the name, so let us do one thing. Let us make a constructor of the class, student name, and then I can write this arrow name is equal to name. Okay, and then I will create an object, suppose of the class in the main method, and then suppose the name is Krishna. Suppose, oh sorry, name is Krishna. Okay, now let us go and okay, just some typos are there. I'm sorry for that, it is taking a lot of time. It's trivial issues. So all right, we will run this program. I think now there will be no errors, and we will just keep on filling the table. All right, now I'll clean and build this application, and it's taking some time. So basically what I want to do is that I want to fill up this table. I want to fill up this table. I want to see whether private members are accessible in the same class, derived class, or in the outside class, similarly for protected and public members. So clean and build, and then I go and run this application. Okay, so yeah, the name of the student is Krishna. So here you see I have one variable, and what kind of variable was it? It was a private variable, and what was a private variable? The name. And inside the class I was trying to access the name. How? You see, inside the display method I was trying to access the name. Okay, so inside, and I called s1.display method, and I got the output. The name of student was Krishna. That means inside the same class private members are always accessible. Okay, so I will go and I will take the brush, and I'll just check it. Correct. Okay, so in the same class private members are always accessible, and you also know it. I don't need to explain it. I'm just trying to show you, but still that private members are only accessible from within the class. They are never accessible from outside the class. Okay, now suppose I say that now you have the second the second thing. Are private members accessible in the derived class? Let us go and test it out. For example, suppose I say this is the student1 class, and the student1 class is deriving from what class? It is being derived from the student class. And in the student1 class I have one method, that is the show details method. And now in the show details method, let us try and access the variable. What is the name of the variable? Name, you see. And this variable is private. Let us just go and clean and build and run this application. Just let us go. I'll just, oh sorry, projects. I'll just clean and build. Let us see. There are some errors associated. There is one problem. What the problem is that this variable name is this variable name is private, so you cannot access this member from outside the class. So this is a problem. So now this is not possible, so I will remove it from here. Now let us try to do one thing. I will try to access from outside the class. Suppose I say s1 dot I can access s1 dot display, but can I access the name from outside the class? I cannot do it. Why I cannot do it? Unable to resolve the identifier name. Why? Because name is private. If suppose the name was public, public, okay, public, then it was possible. If I go and save these changes, then it was possible, to work it out, because if I go and clean and build this, it is going to run. Okay, build successful. But because it was private, it was not accessible from outside the class. So we all know this, that public members are never accessible from outside the class, anywhere outside the class. So if I just go to over here, I can say something like this, that they are not accessible in the derived class and they are not accessible from outside the class, okay, in which they are declared. So now we will talk about the protected members. So let us go over here and quickly make this member what? Make this member protected. Okay, now this member is protected. So name over here is protected. So is it accessible from within the class? Okay, I'll just remove it. All right, now is it this name variable, is it accessible from within the class? See, in the display method I am outputting the name. Is it accessible? I am creating an object of the student class, and then I am calling the display method. Let us see what happens. Clean and build. And then once I go and run this application, you see, name of the student is Krishna. So Krishna was private, and inside the display method it is being accessible. So the protected members are also, they are accessible from within the class. But are they accessible in derived class? Let us go and test it out. So suppose this variable is name, and inside the show details method, inside this class, the student1 class, which is derived from the student class, in this now over here, if you observe, in the show details method, this is the derived class. Which class? The student1 class. Is derived from which class? It is derived from the show details method. Okay, and now over here also I'm trying to access the protected member. And how I am trying to do it? I am trying to do it something like this. Name of the student is, for example, I say, and go then name. Okay, now let us do one thing. Let us make an object of the student1 class. Okay, and suppose here I can create a constructor of the student1 class also, student1 and name, and I can write something like this arrow name is equal to name. Okay, now okay, string name. All right, now something like this. I have created a constructor of the student1 class also. Now let us create an object of the student1 class. So I have created an object of which class? I have created an object of the student1 class. See, I have created an object of the student1 class, and now inside this object, from this object, I try to access the s1 dot which method? The show details method. Okay, so this show details method belongs to which class? The show details method belongs to the student1 class, and inside this class I am trying to access what? I am trying to access the name, and name is a protected member of which class? It is a member of the student class. But student1 class is being derived from the student class. So let us see if it is accessible. I just go and clean and build this, and then I go to run this application. See, the name of the student is Krishna. It is giving the output. So that means it is accessible from even, protected members are accessible from the class in which they are declared. In the student class also it is accessible, and from any derived class. Okay. So this is the very specific behavior of protected members. They are just like private members, but they are also accessible in any class that is derived from them. Okay. And then from outside class, are protected members accessible from outside the class? Let us go and test it out. How I will do it? Suppose I have created an object, suppose a student class. There is an object of the student class. Suppose object of the student class, and then inside this object, now you have an object of which class? You have an object of the student class, and from the object, suppose you try to access variable. Suppose you try to access name. Okay, is it possible? So you see, this name is what kind of, it is a protected member of the student class, and I have created an object of which class? I have created an object of the student class. When I have created an object of the student class, I am trying to access the name, but name, my dear friend, it is a protected member, so it is not accessible from outside the class. Clean and build. So always remember, when you talk about protected members, and protected members are like private members, but they have a different behavior when it comes to classes that are derived from them. So once you derive any classes once you derive a class, then the protected members will be accessible in the derived class. But protected members like private members are never accessible from outside the class. So here I can write something like this. All right. So like this. And public members, they are accessible from anywhere, that is why they are called public. Okay, I will remove this. So here I will make this name what? I will make this name public. Okay, now when the name is public, it is accessible from anywhere outside the class. So here you see, suppose I call the s1 dot, so it is trivial, but still, maybe some students will be freshers, or they will be just trying to learn C++. So I'll just display it quickly, s1 dot display. So it is working fine, So now the student, inside the student class, there was one variable that was, the public variable, and I called the display method. So in display method, I was accessing name, and name is accessible. That is why public members are accessible from within the class. Now let us go and test it out for derived class. Suppose this student1 class, and inside the student1 class, I am having the show details method, in which again I am trying to access the public member of the student class, that is the name variable. So I create an object of the student1 class, and inside the student1 class, suppose I call s1 dot which? s1 dot show details. Suppose I call s1 dot show details. So let us test it out. Clean and build. And then once I go and suppose I run this application, let us see what is output. Yeah, it is coming out. So the name of the student is Krishna. Okay, like this also. And now suppose, are they accessible from outside the class? They are also accessible from outside the class. Suppose you have a student object. Suppose you have an object of the student class. Suppose this is the object of the student class. And then S1 through S1, you try to access the name. And then you write something like this. Cout S1 dot name. And then you can write, a new line marker after this. Is it accessible? Let us try to test it out. Clean and build. And then I go to, now I'll just go and run this application. Yeah, it is giving the output Krishna. So it is even accessible from outside the class. So when I talk about public members, so they are accessible in the same class, they are accessible in the derived class, and they are accessible even from outside the class. Okay, so this I've done. See, the name was what kind of variable? It was a public variable. So it is a public variable, so it is accessible from even from outside the class. How? Over here. All right. So when you talk about the accessibility modifiers in C++, always remember the three accessibility modifiers: the private, protected, and the public. The private are only accessible from within the class. The protected members are almost like private members because they are only accessible from within the class, given one exception. What exception? That if you derive any class, then in that derived class, protected members will also be accessible. And then when you talk about public members, they are accessible from anywhere, even within the class, even any derived class, and even from outside the class. Okay. So as far as inheritance is concerned, so we studied about inheritance, that the child class takes on the properties of the parent class, or it derives from the parent class. So in let me first of all tell you about the access modes, and then the way you do inheritance in C++. What is the syntax for doing inheritance in C++? So in C++, when you specifically talk about C++ and inheritance in C++, in C++, there are three access modes. One is the public access mode, that is the most frequently used, then the private access mode, and then there is the protected access mode. Okay, so suppose you have a class, and suppose the class is A, and now you want to derive a class out of this class, suppose say class B. Then how do you derive a class B from class A? You write something like this. Now you write, first of all you write a semicolon, and then you write the accessibility mode. Suppose I say that the accessibility mode over here is public. So this means that class B publicly inherits from class A. Okay, and if say about class B, suppose inherits from class B through protected inheritance, then what will I write? I will write something like this. And if it is private, then I will write, okay, like this. So most frequently used, is the public inheritance. So we will study public inheritance first, and then in the upcoming videos we will study about what is private and what is protected inheritance. Okay, so what happens when the accessibility mode is private, and what happens when the accessibility mode is public. So when the accessibility mode is public, then all the public members of the base class become public members of the derived class, and all the protected members of the base class become protected members of the derived class, and the private members of the base class are not affected because they are not visible in the derived class. Okay, so private members, the first rule of contract with private members is that they are only visible from within the class. Okay, so what flexibility does any member variable or any member function, if it is public, what flexibility does it offers to me? The flexibility that is offered to me is that I can access that from outside the class using the object of the class. For example, in this case, even I can access even.setName. See, and I pass the value, say suppose Nikhil. There will be no issues with it. Why there will be no issues with it? Because even is an object of employee class, and setName, which is a member function of the employee class, is a public function. So that is accessible from outside the class. But we cannot do something like this. Even.name. This is not valid, my dear friends. This will never be valid. You see, it is already giving a compile time error. If you go and actually run this program, it will never run and compile. Okay, like this. Now what I will do is that let me do one thing. Let me make it protected, and then I will make it private also. Okay, so in employee class there is a member variable that is protected, and the name is protected. Okay, now I will create a class, suppose permanent employee. Okay, and this permanent employee is derived from the class, which class? Employee, and through public inheritance. What kind of inheritance? It is derived from the employee class through public inheritance. Now my dear friends, what did I say to you about public inheritance? If you even go to this PowerPoint presentation, then you will get an idea. When the access specifier for base class is public, then all the public members of the base class become public members of the derived class, and all the protected members of the base class become protected members of the derived class. So it is like this. So now in this case, you have in the base class you have one protected member. What is a protected member? Name is one protected member. So that this protected member will become the protected members in the derived class, and the set name, which is the public member in the base class, will become the public member of the derived class also. Okay, so let me do one thing. Here I create one public, I use the public public accessibility modifier, and now what I write, I write suppose I write something like this: cout the name of the employee is, suppose and then I write name, and then I give a new line mark. Okay, it is something like this. Now if you observe, my dear friends, then name is a protected member of which class? It is a protected member of employee class. And now once name is a protected member of the employee class, I am trying to access it in the derived class. Will I be able to access it? Yes, I will be able to access it. Why I will be able to access it? Because permanent employee class is derived from the employee class using public inheritance, and in public inheritance the protected members of the base class become protected members of the derived class. So in this case, name is a protected members of the base class, that is the employee class. So it has now become a protected members of the derived class also. That is why as a protected member, it is accessible from within the class. But now suppose I try to write something like this. Okay, so now I just remove it. I'm not going to of course run it. I will create an object of permanent employee. Suppose permanent employee, and p1 is the object. Okay, then I say suppose p1 dot set name, and I say Nikhil. Will I be able to access p1 dot set name from outside the class? Yes, I will be able to access. Why? Because set name is public member of employee class, and in the permanent employee, which is being publicly derived from the employee class, in public inheritance, the public members of the base class become public members of the derived class. So that means set name has now become a public member of which class? The permanent employee class. That is why I can access it from outside the class. And then I will access p1 dot display. This I can always access because display is a public member of permanent employee class. So here, if I just try to run this application, clean and build, and then I go to run this application. Let us see what is output. The name of the employee is of course Nikhil. So through set name I was able to set the name of the employee, and through display method I was able to display the employee. But now can I do something like this? p1 dot suppose I say name. See, in the permanent employee class, the name variable was accessible. Okay, it was accessible, but I am not able to do something like this. p1 dot name. If I try to do it, let's suppose if I try to do it clean and build, then it will of course give compile time errors. Why it will give? Because it is not able to resolve it. Why? Because it is a protected members, and protected members, my dear friends, when you are asked about protected members, then protected members are just like private members. That is, they are only accessible from within the class, except the given exception that they are also accessible from a derived class also. So protected members are like private members because they are only accessible from within the class. But when you derive a class from the class in which there is a protected members, then in the derived class also you can access the protected members. We will see about the details of all this in the upcoming videos, but here it is very clear, because name is a protected members of which class? It is a protected member of permanent employee class. That is why it is not you are not able to access it from within outside the class, but within the class you can do it. How? Over here you have already done it. Okay, so now let me do one thing. I think it is correct. Okay, now let me, I just giving one error. I'll just clean and build it once again so that I can verify everything is correct. Yeah, everything is correct. Now let me do one thing. I will not make this I will remove name being protected members, and I will make it a private member. So can you guess what will be the problem in this case? Yeah, the problem in this case will be something like this, because the name variable is public in which class? It is public, it is private in the employee class. Okay, the name is now private in employee class. Once the name is private in employee class, that means in the derived class now it will not be visible. Why it will not be visible? If you just go to this this PowerPoint presentation, then what I have written over here, the base private elements remain private to the base and are not accessible by members of the derived class. You just see the last line, this line. The base private members remain private to the base and are not accessible by members of the derived class. So that means what? This means something like this. This means something like this, because name is a private member of employee class, so it is not visible in which class? The permanent employee class. That is why when I try to access name in the display method in the permanent employee class, I am not able to access it. Why I am not able to access it? Because it is not visible, as it is a private member of employee class. Okay, so this is clear. But now let us try to understand the, the kind of purpose behind public inheritance. Why do we actually do public inheritance? Why it is done? What is the, the benefit of doing public inheritance? Let us try to understand it. Sorry, to understand public inheritance, let me do one thing. I will suppose say that the employee has salary also, okay, and I will just make them now protected, okay, for the sake of simplicity. I will make the salary also, protected. But now what I will do, void set salary. Suppose there is one method and integer, suppose salary, and this I can write very easily, this arrow salary equal to salary. Okay, so there is one more member variable in the employee class. Suppose I say the salary of the employee. Now there is a method, the calculate tax method, and calculate tax method returns the tax of the employee. So I suppose I say that the tax is 10% of the salary. So what I will say, salary into 0.1. okay, this is I'm going to write. So to calculate the tax of the employee, I can write salary into 0.1. Now this is the method to calculate the tax of the employee, but I also need to calculate the tax of what? I also need to calculate the tax of permanent employee. Okay, okay, I have added 3 e's in the over here, so it's not a correct spelling. I will just, it's a kind of, I don't know, typo mistake. Anyway, all right. So calc tax is a public member of employee class. So my dear friends, calc tax can also be said that is a service that is associated with the employee class. It is a kind of service that is associated with the employee class, and I also want this service to be associated with the permanent employee, because for the permanent employee I also need to calculate what? I also need to calculate his tax. So that is why I do public inheritance over here. Why? Because calc tax is a public member of employee class. So in public inheritance, if you do public inheritance from employee class, then calc tax will become the public member of permanent employee class also. So in that case, if you create an object of permanent employee, then through permanent employee you will be able to get the you will be able to get the tax of this employee. How? Like this. Okay, suppose then for that you'll have to say p1 dot set salary. Suppose I say the salary is whatever it may be. It is quite high because it is my salary. Okay, so I will be able to do it. So just let me make it more clear. If you are not able to get it, this is simple. I'm just trying to bring this one point into your notice, that calc tax is a service that is associated with employee, and I also want this service to be associated with permanent employees. So for that I will be using public inheritance. Why? Because this is a public member, so it will become a public member of permanent employee also, the calc tax method, and then I will be able to access this method from outside the class using the object of permanent employee. So that is that is the purpose why we do public inheritance. Okay, and in this video we will try to understand what is private inheritance, or when the access mode is private, what all happens. Okay, so let me open a notepad, and inside the notepad, so what I want to explain, private inheritance. So suppose you have a class A and then you have a class B that is doing private inheritance from which class? It is doing private inheritance from which class? So here the access mode is what? The access mode is private, and we want to understand what is private inheritance in C++. So private inheritance, when you access the derived class using the private, when you derive using private inheritance, then all the public and all the protected members of the base class become the private members of the derived class. Okay, is it clear? All the public and all the protected members of the base class become the private members of the derived class. It is different from public inheritance. What we studied in public inheritance, the public member of the base class become public member of the derived class. The protected members of the base class become protected members of the derived class. But in private inheritance, what happens? All the public and all the protected members of the base class become private members of the derived class. Okay, so here if you can see,
So let us first of all try to understand what is the, why do we exactly do private inheritance. So here I will not be doing public inheritance. What kind of inheritance I will be doing? I will be definitely doing private inheritance. Okay, so this is my permanent employee. Okay, this is my permanent employee. Let us first of all do public inheritance and understand the problem which can arise. Okay, I am doing public inheritance. Now suppose here you say suppose here you have also one method void display. Okay, there is one method, and see out suppose I say name equals suppose name, and then you write salary equal to say suppose salary. Okay, like this, and then I will give a new line marker also, of course, something like this. All right, now this is my permanent employee, and I want to say that my organization has very good HR policy. Normally when you work in organization, your HR organization sucks. It tries to suck the blood out of you, but all the policies and everything, in many cases it's like that. Many cases it may not be like that, but this company it's a very good company, and it has an organization policy. And what is the organization policy for any permanent employee? For any permanent employee, the salary cannot be less than 50,000. See, they are generously paying to their employees. So they say that for any permanent employee, we cannot pay less than 50,000. Okay. So now what I do, I create an object of the permanent employee. Suppose like this, I create an object of the permanent employee, and I say set the object is P1, and then I say P1 dot set the name. Suppose I say name is Nikhil, and then I say P1 dot set salary. Suppose I say P1 dot set salary. But for any permanent employee, the salary cannot be less than 50,000. But over here, suppose I say the salary to be 20,000. Okay, and then I say P1 dot display. So here, my dear friends, if you try to run it, it will run successfully. Why it will run successfully? You can just see the output. Okay, clean and build, and then I go to run this application. You see, name Nikhil and salary is 20,000. But for our permanent employee, the organization policy was that the salary cannot be less than 20,000. But here I am able to set it. Why? Because I am doing public inheritance. What kind of inheritance? Public inheritance. So if I am doing public inheritance, then the set salary is a public member of which class? It is a public member of employee class. Then it will become a public member of what class? It will become a public member of the derived class also. So one set salary is now a public member of the derived class. So if set salary is a public member of the derived class, then I will be able to access that set salary method from outside the class using the object of the class. But now I don't want to do it. So what I will do, I will not make this public inheritance. I will make this inheritance. What kind of inheritance? I will make it a private inheritance. Okay, so now you can see it is right away it is showing some compile time errors. Why it is showing compile time errors? Because once you do private inheritance, all the public and all the protected members of the base class become the private members of the derived class. I repeat, all the public and protected members of the base class become private members of the derived class. So in this case, all these members, they were public member of which class? They were the public members of the employee class. Now they have become what? Now they have become protected sorry, these were the public members in the base class, and now they have become private members in the derived class. Okay, private members in the derived class. So here I write something like this: public. Suppose I create a method set permanent employee salary. Okay, I will set the permanent employee salary through this integer sal, and now in this I can make a check. What check I can make? I can make this check. Suppose the argument that you supplied for setting the salary, if this is less than, if it is greater than 30, if it is less than 30,000, say suppose. So I said the organization policy is at 50,000. No permanent employee salary can be set for less than 50,000. So I can say something like this: the permanent employee cannot get salary less than what? 50,000. Okay, and then I will give a new line marker. Else what I will do, I will say what? Set
salary, and then I will give the argument. So now you see I am able to access set salary from here. I am able to access set salary from this permanent class. Why? Because now set salary is a private members, and private members are only accessible in the permanent in the class in which they are, you know. So set salary is a private members of the permanent employee class. That means it is accessible from only from within the class. So here now if I say, now if I want to set the salary of any, you know, any permanent employee, then what can I say? I can say something like this: p1 dot set permanent employee salary. Now if I set the salary less than, you know, I set the salary 20,000, then what will be the output, you know? Of course, according to what I have written, the salary will not be set. The salary of the employee will not be set. Clean and build. Then once when I go and run this application, if I try to run this application, run. Okay, the permanent employee cannot get salary less than 50,000. Okay, it is something like this. Now, so this is very clear, है ना? So now you can observe. You now suppose you try to do something like this. P1 dot set the salary from outside. Suppose you try to do something like this. You will not be able to do it. Why you will not be able to do it? Can you tell me? You will not be able to do it because, you know, set salary was public members in the base class. Then you did private inheritance, and in the private, because of private inheritance, set salary became the private members of the permanent employee class. That is why you can never access a private member from outside the class. And now suppose you make to make things more clear, you make these members protected. Okay, now when you make these members protected, then you will be able to access in, you know, they will be accessible in permanent employee class also. Suppose you say cout, suppose you make one method and void function function1, and inside this function you can write something like this: cout what, suppose you say name. You will be able to do it. See, this is giving, I mean, if you run this application, if you just run this application, there will be no compile time errors, you know. That means, you know, everything is fine. If you just run this application, there will be no compile time errors. Just let me go and run this application. See, it is building and compiling successfully. There are no compile time errors. So over here I have created a function, and in this function I am trying to access name, and name is what? It is a protected members of employee class. So now it has become a private members of which class? It has become a private member of the permanent employee class. So now again, if I do something like this, I create an object of permanent employee, suppose permanent employee and p1, and then I suppose p1 dot name. Will I be able to do it? I will not be able to do it because name is now, it is now a private members of permanent employee class, so it cannot be accessed from outside the class. So this is private inheritance. So in private inheritance, always remember that all the public and protected members of the base class become private members of which class? The derived class. Okay, thank you so much for watching my videos, and in the next video we will study about protected inheritance, and then we will also see some more, you know, some interesting techniques in which, you know, you can resolve these if there are multiple inheritance hierarchies, then you can resolve them easily. We will study a technique also. Okay, so to understand protected inheritance, let us first of all see what actually happens when you when you use protected inheritance, and when you derive a child class, you know, using the protected inheritance. Then in protected inheritance, the public and protected members of the base class become the protected members of the derived class, like this. Okay, it's like this. So when you use protected inheritance, then all the public and protected members of the base class become the protected members of the derived class. Okay, So in protected inheritance, like private inheritance, if you do private inheritance, then all the public and protected members of the base class become private member of the derived class. Similarly, in protected inheritance, all the public and protected members of the base class become protected members of the derived class. Okay, it is like this. Now we will switch on to our example, and here you can see. Okay, so suppose you have this class A, and then you are making a class B by using protected inheritance from class A. So it's B is a derived class. Okay, so now over here, if you observe that I and J are protected members of class A, and this type of inheritance is protected inheritance. So that is why I and J will become what kind of member? They will become protected members of class B. Similarly, when you observe set Ij and set show Ij are public members of class A. If they are public members of class A, then now if this is a case of protected inheritance, then they will become what kind of members? They will become protected members of class B. If you are still not sure, then we can write something like this. Okay, suppose the usual approach that we follow. I have two classes, and I have a B class that is, you know, protectively deriving from class A, and in class A, suppose I have a few private members, then I have few protected members, and then I have few public members. Let us write them down. In class A, I have two protected members. What are the protected members? They are I and J. So I can write I comma J. Now in class A, if you observe, they set Ij and show Ij are two public members. So I can write what? Set Ij, and it is taking two arguments, suppose A comma B, and then show Ij. These are the two what members? These are the public members of class A. And now if you go to class B, then there is a private member. What is the private member? K is a private member. So I will write it down. Okay, this is the private members of class B, protected members of class B, and then the public members of class B. So in private members, there is one private member in class B, that is K, and then protected members in class B, there are no protected members right now. We will see using inheritance there will be some protected members in class B, but as of now set K and show all are two private members of class B. Okay, so set K is one member function that is public, and show all. Okay, there is one show all member function, this is also public. Okay, now because class B is being derived as protectedly from class A, so all the protected and public members will become what? They will become protected members of class B. Okay, so class A is having I and J as protected members, so they will also become, class B will also have two protected members, that is I and J, and then set Ij and show Ij will also become what? They will become set Ij A comma B, and then show Ij. Okay, these two will become the protected members. So now if you observe this class B, it is having Ij, set Ij and show Ij as protected members, and set K and show all as the public members. Now in this set K method, you are what you are doing, you are calling set Ij. Will you be able to access set Ij in this? Yes, you will be able to access. Why you will be able to access? Because set Ij is a protected members of class B. So you are able to access. This is the rule, because protected members are always accessible from within the class. And now you are writing K is equal to I into J. Is this correct? Yeah, it is correct, because I and J are what? They are protected members of class B, and it is valid to access protected members from within the class. Okay, this is valid. And then you are outputting K. So K is a private variable. So again, you know, you can access a private variable from within the class. Now I will write down something. You just keep on telling me that whether what I am writing is correct or whether what I am writing is wrong. Suppose now I create an object of class B, suppose B1. Okay, alright, B, and I create an object of B, suppose B1 object. Then I write B1 dot set Ij, and then I pass the argument 2, 3. Is it valid? Is this, suppose if I write like this, will it be valid? You just go to this notepad. It is not valid, because set Ij is what kind of member? Set Ij is a protected members of class B. So that is why it is not accessible from outside the class by creating an object of the class. So this will not work. Now I will write ob dot set B1 dot set K. Suppose I write B1 dot set K. Is it valid? It is valid. Why? Because if you observe, then set k, this observe, just set k is a public member of class B, so it is accessible from outside. If I write b1 dot show all, b1 dot show all, is it valid? Yeah, it is valid, because show all is also a what kind of member? It is a public member, so it is accessible from outside. And if I write b1 dot show ij, b1 dot show ij, is it valid? No, it is not valid, because show ij is what kind of member? Show ij is a protected member of class B, so it is not accessible from outside the class. Okay, so again this will not work. All right, so this is, in a way, this is protected inheritance. And now what we'll do is that just quickly we will solve one more inheritance hierarchy, so that things become very clear in your mind. Okay, so what I'm going to do, I've already done something previously. Let me just minimize this, and I'll just all right, yeah, over here if I go and I copy this code, okay, I'll just copy this code, copy, and then I'll remove all this. Let me remove all this, and then I'll paste it. Okay, now see over here, this is class A. So let us solve this inheritance hierarchy as well. So if I go over here, see, if you are not you can skip this part of the video also. If you feel comfortable with all this, then you can skip this video, but just for some amount of practice I'm doing it, so let me do it. Okay, so here I'm having three classes, and all right, one is the A class. A class will also be having some private, it will be having some protected, and then it will be having some public members. Okay, and then let me copy it, then I will say for the B class, then I will say for the C class. So suppose this is your B class, and then this is your which class? This is the C class. Now B class is inheriting from, I'll just minimize it, and then B class is inheriting from A class using private inheritance, so I will write private A, and then C class is inheriting from B class using public inheritance, so I will write public what? B. Okay, like this. Now in A class, what are the private members? There are no private members. In A class there are two protected members, and what are the protected members? I and J. I face a difficulty when I pronounce protected. I don't know, somehow I'm not able to do it. Alright, that doesn't matter. So A class is also having one public method, A comma B, and then it is having show also as one public method. Now you go to class B, there is one private member, that is K, and then there are two public members, set K and show K. Yeah, set K and show K. Show K. These are the two public members. Now B class is doing private inheritance from class A. That means all the protected and all the public members of class A will become the private members of class B. So that means now class B will have the following private members. It will have one private member I, it will have another private member J, then that are inherited from class A. Then it will have a private member set what? Set A comma B, and then it will have a private member show. Okay, these are the private members of class B. Now I am done with class B, and now I go to class C. Okay, in class C, what is a private member? So if you observe just class C, there is one private member, that is M, and then there is a public member, that is show M. Yeah. Now so in class C, that is being publicly derived from class B. So if the inheritance is of type public, then all the public members of class B will become the public members of class C. You see, class C is publicly deriving from class B, so that means all the public members of class B will become now the public members of class C. So besides show M, class C will have set K as one of the public methods and show K as another public method. And now if you talk about protected members, then there are no protected members in class B, so that means there will be no protected members in class C also. Okay, now all right, suppose if I say something like this, first let me write something like this. if I say void set m and m equal to I minus j, will this kind of declaration be valid? It will not be valid. Why it will not be valid? Just observe this. I and j are not to be found in class, they are not in class C. If you observe, they are neither the private members nor protected nor public members. None of the members of I and j are not visible in class C, in any of the accessibility modifier ways, either private, protected or public. So if you write this, then it will result in a compile time error. Okay, now over here I go to the main method, and then I make two objects. I make suppose an object of class B, suppose B1, and then I make an object of class C, suppose C1. Okay, so I created two objects, one of class B and another of class C. Now suppose I write B1 dot set B1 dot set. Suppose I write B1 dot set 1 comma 2. Will it be a valid? Will it be valid? Will it be valid? So you can test it out. You can just see B1 dot set 1 comma 2. Is there any set method in 1 comma 2? Yes, there is a set method in B1, but that method is what kind of method? It is a private. This method is private to class B. So you cannot access this method from outside the class using the using the object of the class. This is not possible. See, in class B itself, I can do something like this. I can say set 1 comma 2. This is perfectly valid. I can do something like this, because set 1 comma 2 is a private member of class B. It can be accessible from class B itself. But once when I create an object of class B, and then through the object I try to do B1 dot set 1 comma 2, because set 1 comma 2 is a private member of class B, so it will not be accessible. Then suppose I say B1 dot show. Suppose I write B1 dot show. So when you call B1 dot show also, suppose you write over here B1 dot show. Suppose you do like this. If you do like this, then also it will not be valid. Why will not be valid? Because show, again, it is a private member of class B, so it is not accessible from outside the class. So this will also not be valid. Now suppose I remove all these two declarations, and then I say suppose C1 dot set 3 comma 4. So it will not be valid. Suppose I say C1 dot set 3 comma 4. Will it be valid? It will not be valid. Why? Because if you observe this C class, C1 is an object of C class, and there is no set method in C class. There are show m, set k, show k methods are there, but there are no set methods. And then similarly, but I can do always something like this. I can do suppose C1 dot show k. I can do something like this. C1 dot show. See, show k, show m, these two methods are there, so I can always write something like this, show k. And then about set k, C1 dot set set k. I can also use set k. Then I can use show m also. I can use C1 dot show m. Okay, this is also valid, because if you observe this in C class, I am having these three are the public functions of class C, so they can be accessible from outside the class by creating an object of which class? By creating an object of class C. Okay, we discussed about the order of execution of constructors and destructors, and we also saw how can we call the base class constructors in a derived class. Now suppose there is a class, and we have already discussed this class. This is the box class, and inside the box class there are three member variables. These are the length, breadth and height. And then I am, this is the constructor of box class, and this is the instance function that is calculating the volume of the box class. Now I create a class. Suppose the name of the class is weighted box. Okay, and this weighted box is publicly inheriting from which class? It is inheriting from the box class. So weighted class is adding a weight to the box. Okay, it is adding also one variable, that is weight, to the box. Now inside the public, I will create constructor of which class? I will create constructor for the weighted box class. So I will write something like this, paste, and this is not the box, it is the weighted box. Over here also, this is not the box, but this is the weighted box. So now if you just observe the weighted box class, the weighted box class is publicly being derived from the box class. So that means if it is publicly derived from the box class, then the protected members of the box class will become the protected members of which class? They will become protected members of the weighted box class. So that means in the weighted box there will be length, breadth and height, plus I have added one more variable, that is the weight. So what I will write, integer weight, the weight of the box. Now if you observe, there is code repetition in this program. And what kind of code repetition is there in this program? See, here I am initializing length, breadth and height, and here also I am doing what? Here also I am initializing what? Here also I am initializing length, breadth and height. I'll just let me write one thing. This is not the box class, this is the weighted box class. Okay, the weighted box class. Similarly here also this is the weighted box class. This is not the box class. So there is code repetition. So in this class, if you observe the weighted box class, I need to initialize these four variables. What? The length, breadth, height and the weight. So here if you observe, this code is being repeated because length, breadth and height are specific to the box class. So I need to initialize in them in which class? In the box class. So here I will make a call to the box class 3 argument constructor. And how will I make the call? I will make the call something like this. You see, box and then integer length, comma integer breadth and then integer height. Okay, so once length, breadth and height are being initialized in the box class, then I do not need to write the code for that over here also. Okay, so now this is my which class? This is my weighted box class, and inside this weighted box class I can create one member function. And what can be the member function? It can be to calculate the volume of the it can be to calculate the, say suppose density of the box. So density is equal to what? It is equal to mass upon volume. So here we have the weight and then we can calculate the volume also. So what we can say? Return weight divided by what? Weight divided by length into what? Breadth into, okay, something like this. Alright, so we have done this calculate density method also. Now I create another class. Suppose the class is the colored box class, and this colored box is being publicly derived from this class, the weighted box class. Alright, now this colored box is adding one more property. And what property it is adding? It is adding the color property also. Suppose it is giving a color to the box also. So now I will create constructor of which class? I will create constructor of the colored box. So here if I go and I will add constructor for which class? I will add constructor for the colored box. So here this is not the weighted box, it is the colored box. Colored box, okay. And here also if you go, it is not the weighted box, instead it is the colored box, okay. And then so colored box is publicly inheriting from the weighted box, and so it will have length, breadth, height, weight which belong to the weighted box, and then it will also have the color. So here I will take one more argument, and that is the color of the box. So how will I write it? Suppose string color, okay. And then inside it you want to, so length, breadth, height and weight you can initialize through the weighted box 4 argument constructor. So how will you do it? Here you just observe, this is not the 4 argument constructor, this is not the weighted box 3 argument constructor, this is the 4 argument constructor. And here I will write, this is not the weighted box constructor, this is the colored box constructor. Colored box constructor, and here also I will write the colored box constructor. Colored box, this is the 5 argument constructor, the length, breadth, height, weight and the color. So here I can call the weighted box constructor, and how will I call it? Weighted box. I will pass the length, breadth, height and what? The color. So length, breadth, height and the weight. These 4 arguments I will pass to the weighted box. So I mean, you do not, because you have already specified the data types in your constructor, so you don't need to write something like this. You just need to write the name of the variables. What are the name of variables? The length, the breadth, and the height. Okay, something like this. So now you have created a proper inheritance hierarchy. Now I create an object of which class? I create an object of the colored box class. Suppose the C1 is the name of the object. Suppose 4 is the length and 5 is the breadth and 6 is the height. And then suppose I say the weighted 100 and then I say the color is, say, suppose orange. Okay, it is something like this. Then can you guess what will be the output of this program? Let us go and run this program. Clean and build. Oh, it is giving some kind of error. Let us see what is the error that is associated with it. Only constructors take member initializers. Okay. Now I think it will run fine. There was a spell mistake. Now I think it will run for. I will just clean and build this application. Oh, again it is having some errors. Okay. Colored box. Alright. Okay, now I think it will run successfully. Clean and build this application. Again. Okay, what is the error? Okay, I need to write public. Okay, constructor public, and here also I have already made the constructor public over here, so I think there is no need for it. Alright, so the weighted box class was, it was protected. So it was, if it was protected, then that means it cannot be accessed from outside the class. So that means I cannot create an object of the weighted box from outside the class. Again, I will go and clean and build this application. I think now it should run fine. Yeah, it is running fine. Now I will run this application. So just let us go and see what is the output. You see, in the box class 3 argument constructor, in the weighted box class 4 argument constructor, in colored box class 5 argument constructor. Why? Because you are creating an object of which class? You are creating an object of the colored box class. So it is calling the 5 argument constructor. But here you have made an explicit call to the weighted box 4 argument constructor. You are passing the length, breadth, height and weight, because these are the protected members of weighted box class. And now inside the weighted box class 4 argument constructor, you are making an explicit call to the box class 3 argument constructor, length, breadth and height, because these properties are specific to which class? These properties are specific to the box class. So inside the box class 3 argument constructor is called, and in the box class you are initializing the length, breadth and height. Then inside the weighted box you are initializing the weight, and then inside the colored box, then you are, sorry, here I will initialize not the weight but the color. Okay, equal to color. Okay, I think it is correct now. Yeah, so it is correct now. Okay, and then you can do something like this also. You can write a method to display the the length, breadth, height and the color. Suppose cout the length of the box is, suppose what, this length, and then I will I'll just copy this code, paste and breadth, and this will become the height, and here also I will write breadth, here I will write the height, and then I will display the weight. How will I display the weight? I will write something like weight, and then I will display what? I'll display the color of the box. So color, and then I will write color. Okay, so make the output from formatted. You can add this also, and then okay, I'll just copy it, paste, 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 and then paste. Alright, now if you go and run this application, suppose I say c1 dot display, okay, like this. Now if we actually go and run this application, what will be the output? Clean and build, and then I go and run this application. You see the length of the box is 4, breadth is 5, height is 6, and the weight is 4. Let me see what is the issue. I have not initialized weight over here. Okay, this arrow weight equal to, okay, this arrow weight is equal to what? Is equal to, if I say something like this, it will work. Okay, let us see again what is output. I'll just clean and build this application, and then I'll run this application. Run. You can see the weight of the box is 4. Why the weight of the box is always coming out to be 4? Length, breadth, and height. And passing the weight also, you know. Length, breadth, height, weight, and color. Length, breadth, height, weight, and I'm passing the weight. So it should come out. Okay, I'm sorry. Okay, I've just said length over here. I should say, okay, I should say weight over here. Okay, like this. I will again go and run this application, clean and build, and then just go and run this application. I'll run this application. So let us see what is output. You know, the weight is 100 and the color of the box is orange. So that is, in this way I'll just end this class. So thank you so much for watching this video. So we saw, you know, complex, and one more thing, you know, just I'll take just some amount of your time more. I do not make the colored box object like this. So I create an object using the default constructor. Colored box C1, and now what will be the output? Can you guess what will be the output? Just go and run the program. Clean and build this application, and then you go and run this application. So let us see. You can see in box class no argument constructor, in weighted box class default no argument constructor, and in the colored box default no argument constructor. And you know, because you haven't, you know, in default constructor you are not, you know, initializing the values, so values are being set to some garbage. Okay, so we studied about inheritance, and now in this video I will, you know, just give you a kind of way in which you can easily, you know, work with inheritance hierarchies. And you know, if there are some questions in your placements in which there can be some, you know, some complex question based on inheritance hierarchy, you can easily answer those questions. So let us start doing it. So okay, I will open a notepad, and I have a class A, then I have a class B, and then I have a class C. See, this is the inheritance hierarchy. I have a class A, over here I have a class A, and then I have a class B. This is my class B, and then I have a class, you know, class B is inheriting, doing public inheritance from class A. Class C is doing public inheritance from class B. So this is our inheritance hierarchy tree. And then in each class, you know, there are some public, there are some private, and there are some protected members. So let us write them down. Suppose in A class I have some I'll be having some private members, I will be having some protected members, and then I'll be having some public members. Similarly in B class I'll be having some private members, I'll be having protected members, and I'll be having public members. Similarly for C class, there will be some members that will be private, there will be some members that will be protected, and there will be some members which will be like public. Okay, so I have 3 classes. Now let us start. So when you have class A, if you observe, if you just go to class A, what are the protected members? In class A there are 2 protected variables, and they are I and j. So I will just write it down. Okay, I and j. Then there are there are 2 public members, set A and B. The public we talk about public, then there is a method, the set method, and it is taking 2 arguments, A comma B, and then there is the show method. Okay, so now you have the show method. Alright, now you go to class B. In class B, there is one private member. When there is no accessibility modifier specified, by default, the default accessibility modifier in class is private. So you have one private variable k, and then you have two public functions, that is the set k and the show k. So here I can write which function, set k function and the show k function. Okay, like this. Now, yeah. So now if you observe, class B is inheriting from which class? It is inheriting publicly from class A. If it is inheriting publicly from class A, then the protected members of class A will become protected members of class B, and the public members of class A will become public members of class B. Okay, so alright. So now here you go. What will be the protected members of class B? Protected members of class B will be the protected members of class A. So they will be I, j. Okay, and then the public members will be the public members of class A will also become the public members of class B. So here, if there will be which method, set A, B and show. Okay, set A, B and then the show method. Okay, you have this. So now if you observe class B, so in class B you are writing k is equal to I into j. Is this valid? Yeah, this is valid. Why this is valid? This is valid because I and j are what kind of members of class B? They are they are the protected members. So you are trying to access protected members from within the class. So this is valid and this is legal. You will be able to do it. Okay, like this. Now if you go to class C, and then in class C we will also identify what are the public, what are the protected and what are the public members. So in class C, if you just observe, by just observing class C, there is one private member. What is the name of the private member? It is M. And then there are two public methods, set M and show M. So public methods are set M, okay, and then the show M method. Alright, now in class C, if you observe, it is publicly inheriting from which class? Publicly inheriting from class B. So that means all the protected members of class B will become protected members of class C, and all the public members of class C will become the public members of class, all the protected members of class B will become the protected members of class C, and all the public members of class B will become the public members of class C. Okay, why? Because class C is publicly inheriting from class B. So now if you just observe, in B class there I and J are protected members. So that means in C class also I and J will become what kind of member? They will become the protected members. Now if you observe, in class B there are these are the following public members: set K, show K, set A, B and show. Okay, these are the public members, and because C is inheriting publicly from which class? Publicly from class B. That is why all these members will become the public members of which class? The public members of the C class. So I can write something like this also. Okay, so now it is something like this. Okay, like this. I can write like this also. B is publicly inheriting from class A. See, just to make it, I am not writing the exact way you write code in C++. Just some snippets of code so that things are clear. Okay, so like this. So now if you observe, C class has one private members, two protected members, and then these 6 are his public functions. Now in C class you are trying to access M equal to I minus J. Is this valid? Yeah, this is valid. Why this is valid? Because I and J are what kind of members of class C? They are the protected members of class C. That is why I am able to access them. Okay, so they are protected members. That means I will be able to access these members from within the class. So that is what I am doing. I am trying to access I and J from within the class. So this is valid. Now if you go, you have created an object of class B, the OB1 object. So now from OB1 object, are you able to access set? Yes, I will be able to access set. Okay, you see, I am able to access set over here. Yeah, there is one method. Is it valid to have OB1.show? If you go over it, is it valid to have OB1.show? Yes, because show is a public member of B class. Then is it valid to have set K? Yeah, it is valid. Then it is valid to have show K? Yeah, it is valid, because all these are the public members of class B, and if they are public members of class B, that means they are accessible by an object of class B outside the class. Okay, then you see in C class these 6 are the public functions. So over here, if you just observe, OB2 is an object of which class? OB2. Suppose I write OB2 is an object of C class. So over here in C class, I am trying to access these functions: set, show, set k, set m, show k, show m. All these are, you know, the public members of class C, and so I am able to access these members outside the class using an object of class C. So if you are, you know, if somehow if there are some multiple inheritance hierarchy and you get confused, then you can, you know, you can follow, although this is not, you know, necessary or mandatory that you have to do it, but this is a kind of, you know, an easy approach you can follow to you know, solve complicated inheritance hierarchy. These kind of inheritance hierarchy are, you know, in some kind of placement questions or some kind of you know, interviews, if they are asked, then you can write it like this. Okay, the order of execution of constructors and destructors in an inheritance hierarchy. Okay, so when constructors and destructors are executed in an inheritance hierarchy, this we will study. And we studied about inheritance in the very first class. I told you that inheritance is a generalization to specialization strategy. That means first you construct the most generalized entity, and through the generalized entity you go on to create the most specialized entity. And there can be layman example also. For example, is that suppose you want to construct a building. So if you want to construct the building, first of all you construct the ground floor, and from the ground floor gradually, you know, you move up. So for construction you move from bottom to up. Okay, and now if you want to destroy the building, it is not that you go on to destroy the ground floor, because if you destroy the ground floor, the whole building will collapse. So you construct that, you destroy the top floor and then the floor below it. In this way you keep on destroying it. Okay, so destruction is from top to bottom. So similarly it's a case with, you know, in inheritance hierarchy. Suppose I say that there is an inheritance hierarchy. What kind of inheritance hierarchy? Something like this. Suppose you have a animal class, and from animal mammal class is inherited, and from a mammal a concrete class dog is inherited. Okay, something like this. So dog is the most specialized class and animal is the most generalized class. So what is the order of derivation? The order of derivation is from animal to dog. So once you create an object of dog class, which class? You create an object of dog class. So if you want to create an object of dog class, so first of all the properties that are specific to animal must be executed. That means the animal class constructor must run first, and then the mammal class constructor will run, and then the dog class constructor will run. And the reverse is the case if you want to, you know, destroy the dog object. So if you are able to not understand it, then let me practically demonstrate it. For example, suppose I say that I have a class, and suppose the name of the class is A. Alright, so this is my class, and in this class I construct a inside the public accessibility modifier I create a constructor. And what do I write? I write something like this: in A class constructor. Okay, and then I give a new line. Alright, something like this. And then I create the destructor for class A. How do I create the destructor? Something like this. Okay, followed by a tilde sign. Now I will have two more classes, and I'll just copy it, and then I'll paste it over here, and then I'll paste it over here. So I'll call this class, suppose B, and this class B, suppose it publicly inherits from class A, and this is the B class constructor, this is the B class destructor, and here I will write B class inside B class constructor, and inside B class this is not the constructor, this is the destructor. Okay, and here also in B class, what? Not the constructor but the destructor. Okay, and then you have a, suppose the class C class, and C class, you know, it publicly inherits from class, say suppose B. Then this is the constructor for C class, and this is the destructor for C class. And what do I say? Public. Okay, and what do I say? In C class constructor, and then, you know, in C class what? In C class destructor. Okay, something like, okay, like this. So now I have created an inheritance hierarchy, and now I will go to the main method, and inside the main method I will construct an object of which class? I will create an object of suppose C1 class, C class, and the name of the object is say suppose C1. So if you actually go and run this application, what will be the output? What will be the output? Let us go and run it and see what is the output. Suppose I clean and build it. And now suppose I run this application. So what is the output? You see in A class constructor, in a B class constructor, and C class constructor, and then the destructor are called in reverse order of derivation. So what was the order of derivation? At the topmost level was the class A, and B class were derived from A class, and then C class was derived from B class. So what was the order of derivation? The order of derivation was something like this. It was something like this. Okay, first there was the A class, and from A class B class was derived, and from B class which class was derived? The C class was derived. So this was the order of derivation. So it is now clear. The constructors are called in order of derivation. Okay, like this. Now so that means you are creating an object of which class? You are creating an object of C class. See, here is your main method. I'll just move it upwards. And now you are creating an object of C class. When you create an object of C class, that means which class constructor is being called? The C class constructor will be called. This we saw in previous videos. In constructor videos, we saw that whenever you create an object of class, the constructor of the class is always called. This is a fact. But now how come B and A class constructor are called? Because you see over here, this C class constructor is calling the B class constructor, and this B class constructor is in turn calling the A class constructor. So we have not written any constructor calls over here. Then how come they are being called? For example, in C class constructor, I am not giving an explicit call to B class constructor. Then how come the B class constructor is being called? It is called because the compiler is by default inserting a constructor call to the base class constructor. So here comes a very important rule, and I will use a notepad to write this rule. Okay, you just make a note of it. Okay, I'll open the notepad. If there is no explicit call to the base class constructor in the derived class, then the compiler inserts a call to the default no args constructor of the base class. What does this mean? If there is no explicit call to the base class constructor in the derived class, then in the derived class I would say constructor. Okay, something like this. Then the compiler inserts a call to the default no args constructor of the base class. So this is what this means. See over here in this constructor, which is the derived class, and it is derived from class C. C class is derived from class B. So there is no explicit call to the B class constructor. So what the compiler will do, it will automatically insert a call to the default no argument constructor of B class, because it is being derived from which class? It is being derived from B class. Now if you go to B class, then is there any explicit call? Explicit call means that you are actually writing code to call the constructor of the base class, but there is no such call. So the compiler will insert a call to the default no argument constructor of the base class. And what is the base class for B? It is A. Then for A, it is it is at the topmost position of inheritance hierarchy. So it does not have a base class, so its constructor will execute, and then B class constructor will execute, and then C class constructor will execute. Now why the destructors are being executed? Because when you go out of the scope of main method, the C object gets destroyed, and when it gets destroyed, the destructor is called. Okay, it is something like this. Now what I will do, I will write one program, and you have to guess what is the error in this program. Okay, you have to guess the error in this program. So I will just open this program, and you tell me what is the error in this program. I'll just copy it. Okay, and now I'll open, I'll just write it, okay. Let us see what is the output of this program. Paste. Okay, yeah. Now this is one employee class, and I am going to, I'm going to remove all this, and I don't want all this. I just want a very simple thing, I just want very simple employee class. This is all this is what I have, I've already taught you, and this is very simple class. And now look at this inheritance hierarchy. Suppose I make these members protected. I make them protected. Okay. Now, if you observe, and in the main method, I will create an object of the permanent employee. Suppose P1 is the name of the object. So I do something like this. Now, what is the problem with this piece of code? If I observe this piece of code, then there is employee class, and this employee class is two protected members, the name and the salary, and then there is the constructor of which class? The constructor of the employee class, that is taking name and salary, and then there is a permanent employee class, and inside the permanent employee class, I'm just, I'm not giving any parameterized constructor. Instead, I'm just creating a default constructor of which class? The permanent employee class. Now, I don't think there will be any errors with this program, because, code is pretty simple, and it does not look out that there can be some kind of errors with this program. So can you guess the errors? Let me go and run the program and see if there are some errors with this program. I'll just go and clean and build it. Oh, clean, successful. But now, my dear friends, you see there are some problems with this program. What is the problem with this program? You see no matching function for call employee. So this is the name of the employee, the name of the class, then the scope resolution operator, and then it is asking for the default no argument constructor of employee class. Why it is asking for the default no argument constructor for employee class? See over here, the error is somewhere over here. It is not being resolved at somewhere over here. Why is this error? Because permanent employee class is being derived from which class? It is being derived from the employee class, and once it is being derived from the employee class, it will call the base constructor. It will call the constructor of the base class, because for the permanent employee is the base class. And we saw what I have written over here in this notepad, that if there is no explicit call, then the default no argument constructor of the employee class will be called. But my dear friends, is there any default no argument constructor in the employee class? There is no default no argument constructor in the employee class. That is why it is asking for the same. Now if I do one thing, if I just add the default no argument constructor in the employee class, and I save it, and now I run it, then let us see what is the output. Clean and build, and then I go and run this application. So it is running fine. And if you really want to, if you really want to observe the output, then you can do something like this. Suppose here I write cout, and what do I write? In permanent employee class constructor, and then I will give a new line, and then I will copy it, and then I'll paste it over here. Okay, something like this, and in employee class constructor. Now if I actually go and run this program, what will be the output? Can you guess the output? Yes, it is very simple. I'll just clean and build this application, and now I will run this program. Let us see what is the output. See, in employee class constructor, and then in the permanent employee class constructor. Okay, now I think it is clear. Now what I do, I create a parameterized constructor in the permanent employee class. How do I create a parameterized constructor in the in this class? I will say, suppose string name, and integer is what? Salary. Okay, and now cout in permanent class parameterized constructor. Okay, and then I will give a new line, and now I copy this code and I paste it over here. Suppose I also say something like this. suppose this is the employee class parameterized constructor. This is the employee class parameterized constructor, and now I say that because you see the employee class is having two protected members, the name and the salary, and permanent employee is being derived as publicly from employee class. That means name and salary will be protected members of which class? They will become protected members of permanent employee class. If they are protected members, and that means they can be accessed from within the class. So what do I write? This arrow name equal to what? It is equal to name, and this arrow salary equal to what? It is equal to salary. Okay. I will just not do. I'll copy this code. I'll remove it from here and I'll paste it over here. Now can you guess? Now what I do? I create an object of the permanent employee class, but now I pass the name and the salary. Suppose the name is Govind and the salary is, say, suppose 2 lakhs. So Govind is one of the names of God. So God, like us, is not in need of some salary, but still we say like Govind is some employee and he's getting some salary, but he's getting some handsome salary, 2,000 to 20,000, then 2 lakhs, and say it is per month, okay, not per year. Okay, now like that we have created an object of permanent employee class. And now if I run this program, what will be the output, my dear friends? What will be the output? If you actually go and run this program, let us see what is the output. I clean and build this application, and then I run this application. See, in the employee class constructor, and then it is calling the permanent employee parameterized constructor. Why it is happening like this? Because you are creating an object of permanent employee class and you are passing two arguments. So the matching overloaded constructor is being called, but in this constructor also, is there any call to the super base class constructor? There is no call to the base class constructor. So that means there will be a default call that will be inserted by the compiler to the default no argument constructor of the base class. And what is the class? The employee class. And there is one default no argument constructor in the base class. That is the employee default no argument constructor, which is just printing out in the employee class constructor. Okay, so there is still one problem with this program. And what is this one problem? Suppose I say that if employee is permanent, then that employee will also get some kind of suppose commission. So I write so if there is a permanent employee, then in addition to salary he will get the commission also. So I will write something like this. I will remove this permanent employee. I will not create this object right now. I will say I want the permanent employee's name, salary, and then his what? His commission. Okay, I also want the commission. And now over here I will also set what? This arrow what? Commission equal to what? It is equal to commission. Okay, but my dear friend, this program will run fine. It will run perfectly well. But there is some kind of code repetition in this program. If you observe, then there is some kind of code repetition in this program. Can you just see what kind of code repetition is there in this program? See, over here also I am initializing the name and salary, and over here also I am doing what? I am initializing the name and salary. So this name and salary are specific to the employee class. So why not this initialization of name and salary be always there in the employee class? And this commission, which is specific to the permanent employee, that be initialized in which class? That be initialized in the permanent employee class constructor. So for doing it, I will explicitly, now I said it over here, if there is no explicit call, but now what I will do, I will make an explicit call to what? I will make an explicit call. See, in this case there was no explicit call, but now I will make an explicit call to the base class constructor. And how will I make the explicit call to base class constructor? I will do it something like this. You add a semicolon, then you give the name of the class. The name of the class is employee, and then you pass the arguments. So what the arguments are? Name and salary. So now you do not need to initialize name and salary. You just need to initialize the commission in this case. Okay, and now can you guess what will be the output? Suppose I create an object of the permanent employee class. Suppose an object of the permanent employee class P1, and again suppose the name is Madhav, and Madhav is again one name of God. Okay, and his salary is suppose 2 lakhs, and then I say his commission is also very big. Suppose his commission is 50,000. Okay, all right. Now can you guess what will be the output in this case? Just go and run this program. I will clean and build this application, and then I'll just go and run. Sorry, it started to debug. Okay, I will run this application and let us see what is the output when I run this application. See what is output in employee class parameterized constructor and in the permanent employee class parameterized constructor. Why is this output coming? Because in this permanent employee I am making an explicit call to the employee class 2 argument constructor. Had not been I have written this piece of code, then the employee class default no argument constructor was called, that we saw in the previous case. But now I made an explicit call, so that is why this employee class constructor is taking the responsibility of initializing the name and salary of the employee, and the commission, which is specific to the permanent employee, is being initialized by which class? It is being initialized by the permanent employee class, this way. Okay, so I'll just end this video over here. So what was overloading? So for overloading to happen, we in the same class, if you have two functions with the same name but different argument list, then that is method overloading. But overriding is something different. So for overriding to happen, you need two classes, and there should be inheritance between the two classes. One is a base class and one is a derived class. So overriding exactly means that you declare one function in the base class and the same prototype function you define in the derived class. So that method is overridden. So let us go to this presentation and try to see what is method overriding. Inheritance should be there. Function overriding cannot be done within a class. For this we require a derived class and a base class. So I already said that if you want function overriding to happen, then you need two classes. One is the derived class and one is the base class. Function that is redefined must have exactly the same declaration in both base and the derived class. That means same name, return type, and the same parameter list. Let us try to understand this. I will just go to the ID, and suppose I have a class, and suppose the name of the class is animal. Okay, so this is my class, and in the animal class I will write the public accessibility modifier, and then suppose there is one method, the sleep method, and inside the sleep method I say the animal is sleeping. Okay, I say something like this and I give the inline marker. Okay, so this is my animal class. Alright, this is my animal class, and now I create one more class, suppose a dog class. Okay, suppose this is the dog class, and dog class is publicly inheriting from the animal class. Alright, and again in this dog class I have this public accessibility modifier, and inside this again I write the sleep method, and this sleep method, what do I write in the sleep method? I write something like this: cout the dog is sleeping. Okay, and then I write a new line. Now here you see that there are two classes, the animal class and the dog class, and the dog class is publicly inheriting from the animal class. Now if you go to the animal class, then I have declared one method. What is the method? The sleep method is there. So sleep method, you see what is the return type? It is void. What is the name of the method? Sleep, and then it is taking no arguments. And then you have observed the sleep method in the dog class, then this is also having the same name, and it has having this this is also taking no arguments. So that means that is the exact prototype declaration that was there in the main class. So we have overridden this is the overridden definition of the sleep method in the dog class. So for overridden methods, you can have your own definition in the derived class. For example, in the base class, I am writing the animal is sleeping, and now in the derived class, what I am writing, the dog is sleeping. Okay, so you can have your own definition in the overridden method. Alright, but the prototype has to always to be same, and the function prototype means that the same name and the same type and argument list. So that has to be same. Now what I do, I create, suppose, an object of the dog class. Suppose an object of dog class. Suppose I say d1 is the object of dog class, and I say d1 dot sleep. Alright. Now please tell me that this dog class is publicly inheriting from animal class, and because it is publicly inheriting from animal class, all the public members of the animal class will become public members of dog class. So effectively, if you observe, dog class will have two sleep methods, one that is specific to the dog and one that belongs to the animal class. So what will be the output? The output will be something like this. Clean and build, and let us observe what is the output, and then I'll go and run this application. Suppose when I run this application, you see what is the output. The dog is sleeping. See, the dog specific version is called. Why this is happening? This is happening because of the third rule. Call to overridden method depends upon the type of object. So here you see in the dog class there were two overridden methods. One was belonging sleep method that belonged to the animal class, and one sleep method that is specific to which class? That is specific to the dog class. So I said that the call to overridden methods depend upon the type of object. So what is the type of object over here? The type of object is dog. So that is why the sleep method that is specific to dog, that will be called. Okay, here again I'll repeat, the object type is call to overridden method depends upon the type of object, and here the type of object is of type dog. So that is why the sleep method that is specific to the dog class will be called, and that is that is what we want, because when a dog is sleeping, then we want the specific behavior of that dog. I want the dog, the specific behavior pertaining to the dog. I want that behavior to happen. And what is the specific behavior for sleeping of a dog? The dog is sleeping. This is more of a kind of, when in animal class, when I write this, define this, the sleep method, then the animal is sleeping is more like a kind of generalized method, generalized behavior. But here in the dog class, it is, it is more of a kind of specialized behavior. For example, I can write something like this. Suppose I create another class, and this one is, say, suppose the cat class, and inside the cat class, suppose I write something like this. The cat is sleeping, and then what I do, I create an object of which class? I create an object of now cat class. If I create an object of cat class, then again this rule will hold true. The call to overridden method depends upon the type of object. So here, what is the type of object? It belongs to class cat. That is why when I run it, let us see what will be the output. Suppose I clean and build this application. And now then once I go and run this application, so see what is the output. The cat is sleeping. Okay. So you always remember this third rule, what I've said, call to overridden method depends upon the type of object. And what is overriding? When methods declared in the base and the derived class have the same prototype, means the same name and the same type and number of argument list. Now I will do one thing. Suppose there is one function 1, and inside function 1, suppose it says something like this: cout in function 1 of animal class, and then I will give a new line marker. Now here in the dog class, again I will write the function 1, but here I will give one argument, suppose integer argument a, and then I will write in function 1 of dog class. Okay, so now here if you observe, what was method overloading? What was method overloading? Method overloading was that, my dear friends, that if two functions in a class have the same name, but they have different number and type of arguments. So here two function, dog class is publicly inheriting from which class? It is publicly inheriting from an animal class. That is why it will have one function 1 from the animal class, and then it is having one more function, that is function 1, that is specific to the dog class. And in this function 1 I am taking one integer argument. Now let me do one thing. I don't need this cat class now. This was just for for some kind of demo behavior. Let me again create an object of the dog class. So I create an object of dog class. Now I do one thing. d1 dot function 1, and suppose I pass the argument 5. I pass this argument. Then what will be the output? Let us see what is the output. Suppose I go and clean and build this application. And now if I again run this application, see, when I called d1.sleep, then the dog is sleeping, and when I call d1.function1 and passed an integer argument, then the function 1 of dog class was called. Now what I do, something very specific, something different and something special. So I write something like this: d1.function1. See, function 1 also belongs to d1 class. Why it does belongs? It belongs because dog class is publicly inheriting from animal class, and animal class is having one function 1. So dog class is inheriting function 1 from animal class. Now if I do something like this, now if I try to run this application, I clean and build this application. Oh, now it will not compile, my dear friends. It will not compile, See, no matching function for call dog function 1. So this is not this is not an example of method overloading. See, method overloading will only take place within the same class. Okay, but this is a classical example of method hiding. I will write these terminologies. I will open a notepad, and then method overriding, then method overloading, and then there is method hiding. Okay, method hiding. So this is the example of method hiding. Why? Because in the dog class, this function 1 with no argument is hidden. Okay, it's hidden from the dog object. Why? Because once you are calling this function 1 with no argument, it is going to the dog class, and it is encountering this function 1 which takes an integer argument, and it is not able to find this function 1. So this is an example of method hiding. Okay, this is not an example of method overloading. Why? For method overloading, you need to overload the functions in the same class. It is not that you can overload two functions, one in the base class and the other function in the derived class. This is not possible. So that is an example of method hiding. Okay, so it is like this. And again, if we return to method overriding, so method overriding, when I call the sleep method of the dog class, then the behavior specific to dog is called, and that is what I want. All right. So before trying to understand friend function, let us try to understand the need behind friend. So in general, suppose you have a family and there are some close family members like your mothers, your father, the brothers, sisters. They all form a unit. But there are also some friends of the family which can come inside the family and they can meet the family members. So this is the case with my object-oriented programming in C++ also. Like I have a class, and inside a class, suppose I have a private variable. And suppose the variable is, say, suppose x. I have one private variable. So what does private variable means? Private variable means that it is only accessible from within the class. I cannot access a private variable from outside the class. See, if I make an object of my class, say suppose m1, then I cannot write something like this, m1.x. I cannot do it. Because why? Because x is private to the class. But this private variable cannot be accessed from outside the class. But there is one provision, that is a provision of friend function. So friend function of a class have this friend functions of a class are allowed to access the private members of a class. So how do we declare friend functions, and how do we create friend functions? All this we will see in this video lecture. So before studying friend function, I will just try to first of all present it, and let us look at some point of friend functions. So friend functions are not member functions of a class to which it is a friend. Okay. And friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Friend function can access any member of a class to which it is a friend. So let me do one thing. Suppose this is my class. What is the name of my class? My class. So over here I will create a function. Suppose the name of the function is function1. But now this function is not an ordinary function. It is a friend function. You see, if you go to this presentation over here, then what I have written, friend functions are declared inside the class using the friend keyword. So whenever you want to make a function as the friend function, you in its declaration, you write the keyword, that is the friend keyword. So over here I have written the friend keyword. So over here my function, that is function1, this is the friend function. So I'm just going to remove it from here. So again, if you go over here, you can see friend functions are declared inside the class using the friend keyword, and they are defined outside the class. Okay. So friend functions are not member functions of the class. Okay. So what does all this mean? See, inside my class, I can just have a declaration of the friend function. I just declare the friend function. Then I need to define the friend function somewhere outside the class. So how am I going to define the friend function outside the class? This is what I'm going to tell you. So if you want to define the friend function outside the class, then what is the return type of this function? It is void. And what is the name of the function? It is function1. So first of all, over here, this is a friend function. Okay, function1, it is a friend function. So let us go point by point. Friend functions are not member functions of a class to which it is a friend. See, over here in this my class, the function1 is a friend function. This friend function does not belong to my class. It does not belong to my class. See, I cannot write something like this. M1 is an object of class. Which class? My class. Through M1, I cannot access function1. You see, if I write, then it results in a compile time error. Unable to resolve identifier function1. Because function1 does not belongs to the class, we cannot access function1 through the object of the class. So always remember that friend functions are a kind of very special type of functions which do not belong to the class but still have the capacity, or they are allowed to access the private members of a class. Okay, like this. Now what I do is that suppose this friend function takes an argument of my class. Suppose M, my class. This is just a declaration, and over here I write something like this, my class M, and now I write cout m.x. If I write like this, then what does this mean? Suppose in this class I also declare a constructor. So how will I declare the constructor? My class integer x. Now we have studied about this pointer, so I can use this pointer, this dot x equal to x. See, over here my instance variable name is x. What is the name of the instance variable? It is x. And what is the name of this variable? This local variable is also x. So I can write this arrow x is equal to x. Alright. So when I write this arrow x, that means the x of the current object, and this x is the local variable. Alright. So I have created a constructor of the class. So now I can do something like this, 10. Alright. Now that means for object M1, the value of x is 10. Now there is a function. What is the name of the function? Function 1. This function 1 is not a member function of my class. Instead, it is declared in the global scope. You see, it is defined in the global scope. So if I need to call function 1, what will I do? I will just write the name of function and then I will pass the argument. And what is that argument? It is an argument of type of object of my class. So I have an object of my class, that is m1, and this function 1 is expecting an argument of what class? It is expecting an argument of my class. So over here this m1 gets passed on to m, and then I print m dot x. So you can see this x is a private variable. If this x is a private variable and my class is ending over here, see, this class only is from here to here. Okay, and I am accessing this x variable from outside the class. I am accessing this x variable from outside the class. If x is a private variable, then generally it is not allowed, but friend function can do this. Okay, like if there is some family friend, then he can come inside your family and he can, you know, have some personal interactions with the members of the family. Similarly, the friend function can access the private variables of a class, private members of a class. All right. So now I will clean and build this application. Build successful. And then once I go to, I will just run this application. So let us see what is output. CC 10, it is coming out. So I can write something like this. Inside the friend function, the value of x is, all right, like this, and then I will I will give a new line marker like this. All right, and then again I will go to clean and build this application, and then I will run this application. So once when I run this application, inside the friend function, the value of x is 10. See, x is a private variable and the value that has been set for m1.x was 10. m1's x was 10, and that x is, I am accessing somewhere outside the class. So this is a friend function. Which function? The function 1, it is a friend function. So again, let us go to my presentation. Friend functions are not members of a class, or not member functions of a class to which it is belongs. Yeah, we saw that just because if I were to write m1 dot function 1, then it was giving an error. See, m1 dot function m1 dot function 1. If I write like this, then it will result in a compile time error. I cannot do this. That means function 1 does not belong to the class because it cannot be accessed through the object of the class. Friend functions are declared inside the class. Yes, I declared my friend functions inside the class. How I declared my friend function inside the class? I did it like this, and then I defined my friend function in the global scope outside the class. Okay, like this. Friend function can access any member of the class to which it is a friend. So over here, this function 1 is a friend to my class. So it has access to all the member variables and functions inside my class. So here the thing is that x is a private variable, but inside the friend function I can access the private variable. But there is a specific condition. What is the specific condition? I cannot do something like this. I cannot directly access x. See, x is a private variable. I cannot write directly accessing x. The value is, suppose I cannot directly access x. Okay, if I do like this, then it will result in an error. It is giving a compile time error, unable to resolve the identifier x. So you cannot directly refer an instance variable inside a friend function. You only do it indirectly through the object of the class to which the friend function belongs. See over here, friend functions are not associated with any objects. And then if you see the last point, friend functions access the members of a class to the object of the class. So if I want to access this private variable x, I cannot directly access. I cannot write cout as we saw. I cannot write like this. If I want to access x, then I have to write something like this. I have to access it through the object of my class. See, friend function belongs to my class, it is a friend of my class. Then if I want to access the private variables of my class, then I need to have an object of my class. And what is in this case object of my class, my dear friends? It is M. So these are friend functions. So in the next video also we will study about friend functions. We will create a friend functions that will belong to two class, and that will then access the private members of both the classes. So we will see it in the next lecture. In this video we will continue our discussion of virtual functions and polymorphism. And this is exactly what we have done till the previous video. If you have not gone through the previous video, then please go through it. So we have created a class animal, and then we are deriving a class dog through the animal class, and then we have declared this function virtual, the dog, the sleep method in the animal class. I have declared it to be virtual. So once you declare the virtual is a keyword that is, that is declared in the base class. So once you have declared a function virtual in the base class, then when you override the function in the derived class, you do not need to write that keyword virtual. Okay, it is automatic, the function is automatically considered to be virtual. Okay, so now let me do one thing. I will create in the class, and that is the, suppose I say the cat class. Okay, so this is the cat class, and cat is also an animal, so I will write something like cat is sleeping, and then in the eat method I will write cat is eating. So now I have created two classes that are inheriting from the animal class. So this is just to show you the power of polymorphism and virtual functions. So how do we, let me create a pointer for the base class. And what is the base class? The animal class. I have created a pointer p for the base class. Now let us create an object of the dog class, suppose d1, and then create an object of the cat class, suppose it is c1. Now if p is pointing to the address of d1, okay, p is pointing to the address of d1, that means it is pointing to the dog object. Then if I call the sleep method, okay, then if I call the sleep method, so you see the sleep method is overridden over here. If you observe, the sleep method is overridden, and the sleep method is virtual. Why? Because in the base class I have provided the keyword virtual. So again, what will follow for this, the point that will follow for this is that something like this: when the overridden method is virtual, then the call to it will depend upon the type of object. So here if you observe, the sleep method is virtual and the call to it will depend upon the type of object. So what is the type of object that is p pointing to? It is pointing to an object of the dog class. That is why if I run this application, then what will be the output? The output will be dog is sleeping. Okay, clean and build the application. And then once when you go and run the application, see, dog is sleeping. Now let me do one thing. Let me do something like this. P is equal to address of, say, suppose the cat object, and then once when I call p arrow sleep method, then what will happen? Interesting, huh? So if I again clean and build this application, and then once when I run this application, you can see what is the output. See, dog is sleeping and the output is cat is sleeping. Why this kind of output? See, call to overridden virtual function is decided by the type of object. So here p is containing the address of d1. That is mean it is containing the object address of a dog object. So here the p arrow sleep method, the overridden sleep method belonging to the dog class will be called. Now I have said something like this: p is equal to address of c1. That means p is containing the address of a cat object. So once when I call p arrow sleep, that means it will call the sleep method that is in the cat class. Okay, so that is why the output will be something like this: the cat is sleeping. In any case, if I try to do something like this, suppose p arrow eat, and here also suppose I say p arrow eat. If I call the eat method, then what will be the output? I think this is all we have discussed in the previous video also, but still, it's always good to revise some concepts so that you have solid understanding. if I run this application, then what will be the output? So the eating method of the animal class is always called. Why the eating method of an animal class is always called? Because of early binding over here. Why? Because eat method has not been declared to be virtual. Okay, eat method has not been declared to be virtual. Alright, so this much is clear. And now the point which I want to bring up in your notice is that you are using a base class pointer, and base class pointer can point to a derived class object, but we can also use base class references. Okay, like we use base class pointer, we can use base class references. So what will I do? I will first of all I will comment out this code. Okay, I have commented out this code, and now I will create a function. I will create a function in the global scope that is taking a reference of type animal. Okay, that is taking a reference of which class? The animal class. And inside the method, just the sleep method is being called. Okay, so this is different from pointers. When you access the member variables and functions through pointers, you use the arrow operator, but when you use the references, then you use the dot operator. Now I will just remove this also. Now if I create an object of the dog class, okay, I do not need to create it because I've already created it. Okay, yeah, fine. Now I'll remove this. Alright, and now I have two objects. One is the one is the dog object, and then second is the cat object. Now suppose I call function 1 and I pass the dog object. So this dog object is being passed to the function 1, and that is being collected in a reference. That reference belongs to the animal class. That reference belongs to which class? It belongs to the animal class. And see what I have written over here. In C++, base class pointer or reference, okay, can point to a derived class object. So that means the same work we can do with references also. So here, when I call the function with the object of the dog class, and when I call function 1 with the object of the, say, suppose the cat class, then what will be the output? Inside both of them, I am calling the sleep method. I am calling the sleep method. So let us see what is the output. If I clean and build this application, and then once when I go and run this application, let us see what is the output. See, dog is sleeping and cat is sleeping. That means the specific version within the dog class and the cat class was called. So this proves my point that you can achieve polymorphic behavior through base class references also and through base class pointers also. So the pointers we already saw, but now we create base class reference. How? Animal class, we created a reference of animal class, and then base class reference can point to derived class object. So dog and cat class are derived from which class? They are derived from the animal class. See, over here the cat class is derived from the animal class. So I pass a dog object, and this is being collected in the animal reference. Why? Because base class reference can point to a derived class object. Okay, and depending upon the type of object, not the type of reference. See, over here the type of reference is of animal class, but the call to overridden virtual function is decided by the type of object. So depending upon the type of object, the specific version of sleep method is called. So when I pass the dog object, the sleep method of the dog class is called. So what are abstract classes? So my dear friends, in many situations there may be a case where you are not sure how to design, because the base class is so much generalized. When you are going to design a class, the class may be so generalized that you do not know how to define some functions in the class. For example, suppose I go to my IDE and I create a class, suppose a shape class, and I want to compute the area of the shape. So inside the public accessibility modifier, I will write one method area, but we do not know what is the shape is exactly like. We do not know what is the kind of the shape. It may be a triangle, it may be a square, it may be a rectangle, it may be anything. So we are not sure about the shape, what kind of shape it may be. That is why we cannot define the area method over here. See, if it was decided that shape was something like, if suppose I say that the shape was kind of rectangle, then I would have said I would have said that return length into breadth, because the area of a rectangle is equal to length into breadth. But we are creating a more a kind of more generalized class. Suppose the shape class, and inside the shape class we are not sure how can we what should be the definition of the area method. For example, in the paint, suppose it is something like this. We have a class, the shape class, okay, the shape class, and we want to compute the area of the shape. Now but we are not sure how will the area method be. So I cannot give definition of area method over here. So what can I do? But yeah, there is one more thing. Suppose I create a class, suppose the rectangle class, and now inside the rectangle class I derive it from the shape class. Once I derived it from the shape class, then in the rectangle class I know, if I create an area method inside the rectangle class, then I know that the area of a rectangle is equal to what? It is equal to length into breadth. This is all I know. So that means this area method has to be overridden. So that means it has to be virtual. It has to be virtual. Okay, because it is going to be overridden in the derived classes. It is going to be overridden in the derived classes. That is why I have to declare it to be virtual. But I'll just remove this rectangle class from here. But we do not know the definition of this area method over here. When the shape class is being designed, we have no definition for the area method. That is why I will make it a pure virtual function. And how do you make a pure virtual function in a class? If you write something like this, you equate the function to 0, that means this function will become a pure virtual function. See, there are two things. You use the keyword virtual in front of the function, in front of the prototype of function, and then you equate it to 0. So that means it becomes a pure virtual function. And any class that has at least one pure virtual function is an abstract class. See, this is what I have written over here. A class containing one or more pure virtual function is called an abstract class. So now the shape class is an abstract class. And now the second important point is that abstract classes cannot be instantiated. So when I say that abstract classes cannot be instantiated, that means that you cannot create an object of an abstract class. See, if I try to do something like this, I create an object of this class, suppose the shape class, and now this shape class is having a pure virtual function. That means it is an abstract class, and now I am trying to create an object of the abstract class. I clean and build this application. See, there are some errors. This is not working, and this is the point where some errors are coming. Why? Because you can never instantiate an abstract class. Why we cannot instantiate an abstract class? See, we cannot instantiate an abstract class because this is this was a decision that was purposefully taken by the makers of C++. Those persons who designed C++, they make this they made this decision. Why they made this decision? Because if you are able to create an object of, suppose, say, abstract class, then if you are able to make an object of abstract class, then you can call the virtual function, you can call that pure virtual function. Okay, through the object I can call that pure virtual function. I can say something like this. Suppose I say s1 dot area. I can say something like this. But my dear friends, we just saw over here that this area method is a pure virtual function. So that means it has no definition. So what is the point in calling calling this area method when it has no definition? So that is why, to prevent this from happening, the makers of C++ purposefully decided that you can never create an object of an abstract class. Okay, an object of abstract class can never be created. So this can never be done. So what we already saw, if we try to do this, it will give a compile time error. But yeah, there is one more point that is to be noted over here. We can always create a pointer of a abstract class. Suppose I do something like this. I do not create an object of the shape class. I create a pointer to the shape class. See, pointer is, it can have an object, address of an object. So it is always valid to create a pointer to an abstract class, pointer of abstract class. But it is never valid to create an object of abstract class. See, this is running fine. It is giving no errors. Okay, so we can always create a pointer of an abstract class. Now, the point to be noted, the third point which I want to make into your notice, which I want you to notice, is that it is something like this. Suppose if a class inherited from an abstract class fails to override the pure virtual function, then that class itself become abstract. Okay. So now what I do over here is that I create another class, suppose a rectangle class, and inside the rectangle class I suppose I derive it from the shape class. Okay, this is my rectangle class. But see, in this rectangle class, is there any overridden definition of area? I mean, I am not writing something like this area and something like C out in area rectangle in area method of rectangle. I'm not writing anything like this. This is the definition, that is overridden definition of area method I am providing in rectangle, but I am not giving this at this point of time. So this is what I have written over here. What I have written, if a class inherited from abstract class fails to override the pure virtual function, then that class itself become abstract. See, shape class is the abstract class, and now rectangle class is being derived from the shape class, but it is not overriding the area method. So in this case, this rectangle class will also become a abstract class. In order to prove this, I will try to create an object of the rectangle class. Okay, how? I will create an object of the rectangle class. Suppose rectangle class, I created one object, and that is a R1 object. And now if I go and run this application, I will clean and build it. See, there are some errors. Error is over here, and now if I try to see the error, clean and build. If you just try to see the error, what is the error? Okay, cannot declare variable R1 to be of abstract type rectangle. See, it is saying that rectangle is of abstract type. So that means rectangle is also now become an abstract class. But if I do something like this, if I do suppose integer area, and inside area I write suppose cout in rectangle area method, and then because its return type is of integer, then I say return 10. If I do something like this, so now you see shape is an abstract class and rectangle class is inheriting from that abstract class, but it is providing the definition for the pure virtual function. So in this case, a rectangle class will no more be an abstract class. It has now become a concrete class. Okay, so now if I try to run this application, clean and build, see, now it is running fine, because now rectangle class is no more, it is no more an abstract class. So I can create an object of the of the rectangle class, and our rule is that we cannot create an object of an abstract class. Okay, so that we saw what we have seen till now. We have seen that you can never create an object of an abstract class. If there is one function that is virtual and that is equated to 0, then that becomes a pure virtual function. Okay. And why we cannot create an object of an abstract class? Because if you can create an object of an abstract class, then through that object you can access the pure virtual function. But we saw that pure virtual functions have no definition, so that is why we can never create objects of a abstract class. Now let us move forward and do some more interesting stuff. So I have already created this rectangle class over here, and in this rectangle class I really want to calculate the area. So rectangle will have length, it will have the breadth also. Okay, rectangle will have these two protected variables, and inside the public accessibility modifier, let me create an constructor for rectangle class. Then I will take 2. Okay, and then what I will say something like this arrow length. Okay, this arrow length is equal to length, and this arrow breadth equal to breadth. Alright, and then inside the area, when I want to compute the area for a rectangle, and then I will do something like this. I will, I will properly format it. And that, what is the area of a rectangle? It is equal to the length into the okay, it is equal to length into breadth. Alright, so now I've created the area of rectangle also. What is the problem over here? Okay, alright, this, now it is okay. So now I've created this rectangle class. Now I will create one more class, and suppose this is a triangle class. Okay, so I'll paste it over here, and this is, say, suppose my triangle class. So I will write like this. See, this triangle class is also, it is inheriting from the shape class, and triangle also has length and breadth. And suppose this is the constructor for my triangle class, triangle. Okay, and then once I want to compute the area of a triangle, then area of a triangle is equal to half into length into breadth. So what I will say, I will say something like this. Okay, length into breadth into 0.5, that means half of length and breadth. So you can also, you can also do something like this. You can have a class, say, suppose a square class. Okay, and square class also, so square means, you will only have length. So I mean, okay, so here I will create the constructor for the square class, and I only need the length, because square has, same dimensions, okay, of length and breadth. Okay, and then the area will be equal to what? Okay, it will be length into length. Okay, alright, so this is square. So now what you see that there is one class, that is the shape class. This is my abstract class, and it has having one pure virtual function. So now I created three concrete classes, the rectangle class, and this is providing a definition for area method. That is why rectangle class is no longer, it is no longer an abstract class, it is a concrete class. Alright, triangle is also a concrete class because it is providing an implementation for area, and square is also a concrete class because it is providing an implementation for the area method. Now here in the main method, suppose I create so we already saw that for an abstract class we can never create an object, but we can always create a pointer for an abstract class. Suppose this is my abstract class, and I create a pointer for the abstract class. Now I say there is a rectangle, and suppose the dimensions of the rectangle are 10 and 5, means 10 is the length and breadth is 5. Then P is pointing to an address of R1. And then once when I call P arrow area, then what will be the output? So let me, copy this code and paste it, and then again paste it. So here I will create a triangle. Suppose the name of the triangle object is T1, and then P is containing the address of T1. Then again I am calculating P arrow area, and then I am having, suppose, square. Okay, suppose S1, and then P is pointing to the square object. So what is happening over here? First you are creating a rectangle object, then the pointer is pointing to an object of the rectangle, because we saw base class pointer can point to a derived class object. So P is containing the address of the rectangle object, and then I'm calling P arrow area. Then again I have created a triangle object, then P is pointing to an object of triangle, and then I compute P arrow area. And then again the same thing I have done with the shape object also. So if you just observe what will be the output. So I'll make some changes over here, I have missed it out. So I will write over here not the rectangle, but what will I write in the triangle area method? Triangle area method. And over here what will I write in the square area method? Okay, so and for I will write the inline markers also over here, and similarly for here also, and that also same for this rectangle class area method also. Okay, something like this. Now if I go and run this application, clean and build, and now if you run this application, what is the output you see? It is giving some errors. Let me fix out the errors. Okay, the square class, it is only taking one parameter. Okay, now clean and build it. what is the output? I run this application. See, oh, 1 minute, huh? I have to write C out over here also. C out, and then endl. Okay, I'll copy it, paste, and then paste. Alright. Now let us again run this application. Clean and build. Now once when I go and run this application, what will be the output? See, in rectangle area method, and the area of the rectangle is 50. In triangle area method, and the area of triangle is 25. And then square area method, and the area of the square is 100. So now this output is very clear. You are just outputting the area, because p arrow area, this area method is having a return type of int, and you are just returning the area from that method. But now I will explain one more important concept. And if you have watched the first video of polymorphism, in which I gave an introduction of polymorphism, then I said that polymorphism is one interface, many forms. This is the literal definition of polymorphism. Why do I say that polymorphism is one interface, many form? Okay, polymorphism is one interface and many forms. Why do I say that polymorphism is one interface and many forms? See, here if you observe these three lines, this line, and then this line, and this line. Okay, in all three lines I am saying p arrow area. Okay, I am just saying p arrow area. Here also I am saying what? Here also I am saying p arrow area, and here also I am saying what? Here also I am saying p arrow area. But depending upon the type of object P is pointing to, that specific area method is being called. For example, over here P is pointing to an object of the rectangle class. That is why when I call P arrow area, that means the area method of the rectangle class is being called over here. Similarly, when P is pointing to an object of the triangle class, so when I say P arrow area, then the area method of triangle class is being called. So why polymorphism is called one interface in many forms? It is called one interface many forms over here because you are calling P arrow area, and this is just one interface. Everywhere it is the same P arrow area. In three places it is just the same, but depending upon the type of object it is pointing to, P is pointing to, it is taking many forms and it is giving many outputs. You see, different outputs. Okay, here if you just go and run this application, it is giving different outputs. That is why polymorphism is called one interface many forms. See, it is giving outputs 50, 25, 100. Although every time I call P arrow area, but the outputs are different. Okay, so interface is same, but forms are different. That is why polymorphism is also called one interface and many forms. Okay, thank you. And yeah, before completing this video, I just want to check out if everything has been covered. So this is this kind of polymorphism is an example of runtime polymorphism. Why runtime polymorphism? Because this call, P arrow area, the which area method will it bind to? Which area, if I say P arrow area, then which exact area method will be called? You see, in this whole hierarchy there are 4 area methods. There are 4 area methods. But which specific area version will be called is deferred until the runtime, or this decision is taken at the runtime. That is why this is called as runtime polymorphism. Okay, so method overriding is an implementation of runtime polymorphism. Okay, or sorry, runtime polymorphism. Runtime polymorphism is an example of method, and I'm sorry I'm not able to present it. But when you do method overriding, then that is runtime polymorphism. Okay. The first property of virtual function is that virtual functions are hierarchical. So what does this mean? This means that no matter how many times a virtual function is inherited, it remains to be virtual. Let us try and test it out. What does this exactly means? So I have taken a class hierarchy. And in this class hierarchy, there's a class, and suppose the class is A, and then there is a class that is being inherited from class A, that is a B class, and then there is a C class which is being inherited from the B class. So it is an inheritance hierarchy. What kind of inheritance hierarchy? In which B class is being inherited from A class, and then C class is being inherited from which class? B class. Now, if you observe over here in this A class, I have declared a virtual function, and that is a display function. So once I override this function, then I need not to give the keyword virtual, because I have already given in this base class, I have declared this function to be virtual. But I want to ask one thing, and what do I want to ask? I want to ask that if B class is overriding this function, then B's display method is a virtual function. But is it true for class C also? That means no matter deep down the inheritance hierarchy you go, the virtual functions remain to be virtual. Let us try and test it out. So what I will do, inside the main method, so this is a quick video, inside the main method, I am going to create a pointer of the base class, and suppose the base class name is A. Then I create an object of the B class, and then I create an object of the C class. Suppose P is equal to address of B1. Once I say P is equal to address of B1, and I call the P arrow display method, and display method, and then P is equal to address of, say, suppose C1, and then I call the P arrow display method. Okay, something like this. Then let us see what is the output. Clean and build, and then if I go and run this application, what is the output? See, okay, I'll do one thing. I will add the new line markers over here so that the output is better formatted. So I will add the inline markers over here. I have added the inline markers. Now let us see what is the output. I will clean and build this application, and then I will run this application. Okay. When I run this application, see, in B class display method, and then what it is displaying in C class display method. See, so when you call the C, when you point the object, when you point the pointer of the base class to an object of C class, then also when you call the display function, the virtual attribute is being inherited by the display function. So okay, so virtual functions are always hierarchical. So no matter how many times virtual function is inherited, they remain to be virtual. Okay, then when you see the second point, when the derived class fails to override the virtual function, the first redefinition found in reverse order of derivation is used. What does this mean over here? Suppose over here, if I do comment out this piece of code, suppose I comment out this piece of code. Now, in B class, you see this class has overridden the virtual function. Okay, this class has already overridden the virtual function, but now in C class I am not overriding the virtual function. Okay, now if I create an object of C class C1, and there is a pointer of the base class, and now what I do, I make the pointer point to the object of C class, and then when I call the display method, I'll just hide this. I'll just comment out this piece of code. The pointer pointing to an object of B class, and calling the display method through it. I'll comment out this piece of code, and I'll only use this piece of code. Okay, when the pointer is pointing to an object of C class, and then I call the display method. So what will be the output? Let us see what is the output. Clean and build the application, and then when I go and run this application, you see in B class display method, and that is what I have written over here. If when the derived class fails to override the virtual function, the first redefinition found in reverse order of derivation is used, and that is what is being happening over here. See, this is the order of derivation from A to B to C, but what is the reverse order of derivation? From C to B to A, and this class C is failing to override the display function. The first definition found in reverse order of derivation will be called. So that is of class B display method. That means the display method of class B will be called. So these are two very important properties, of virtual functions that you can keep in your mind. Although, they are not very frequently, maybe you may be using in some kind of inheritance hierarchy, but it is good to have a knowledge of them. Okay. So before studying copy constructor, we have already studied constructor, and we saw that whenever an object of a class is created, the constructor of the class is always called. For example, over here, if I have a class, and what is the name of the class? It is my class, and inside this my class I have two constructors. Okay, So if I go to create an object of the class, how will I create the object of the class? My class, suppose M1, and I have created an object, and then there is one display method also, so I call M1.display. Okay, so this is very simple, and yeah, over here I'm just going to move it up so that you know, everything is in one screen, and so over here I think I will just format it. Just give me a few minutes so that you know you can get a whole picture of what is happening over here. So yeah, so now I create an object of the class M1 class, and because I have created an object, the constructor will be called clean and build. And now suppose I go and run this application. Okay, the one argument constructor of my class has been called, and the value of x is, it is supposed to be 10. All right, now what I do is that I have already said that when you create an object of the class, the constructor of the class is called. So I create an object of the class, and now it is the M2 object, and I do not create this object by passing argument. For example, I pass the argument 20. If I pass the argument 20, then constructor for M2, when I create M2, the constructor will be called. But I create M2 in a different way. I create M2 by initializing it from some other object. Suppose I do one thing, that I create M2, and while creating M2, I initialize it from M1. And we have said that whenever you create an object, the constructor for the class is called. Okay. Now if I go and run this application, clean and build, and now if suppose I run this application, you see the one argument constructor of my class has been called. You see, I have created two objects. M1 and M2. I can also do something like this, M1 dot display, and I can write M2 dot display. I can do something like this. Two objects have been created, clean and build, and now once when I run this application, see the value of x for M1 is 10, the value of x for M2 is 10, but for M1 the constructor has been called, but for M2 the constructor has not been called. So my dear friends, in this case, when we use one object to initialize another object, then the constructor for the class is not called. Instead, the copy constructor for the class is called. Okay. So, and one important thing over here to keep in mind is that if you do not have any copy constructor in the class, then the compiler will automatically and implicitly insert a copy constructor in your class that will perform a default bit by bit copying of the objects. What does this mean? This simply means something like this. If I go to Paint, I will just, I will take a new file. Don't want to save the changes. So when you write something like this, suppose you write my class M2 equal to M1, and M1 over here is allocated. Suppose this is M1 and M1 is having x as 10. Then once you said my class M2 equal to M1, then M2 is created by default bit by bit copying of M1 into M2. So M2 will have the x of also 10. That is why, my dear friends, if you run this example, you are getting, if you run it, then for M1 and M2, both of them, the value of x remains to be 10. Okay, like this. So over here, when you say like this, then the copy constructor is being called. And which copy constructor? The copy constructor that has been implicitly inserted by the compiler itself. Okay, so I'll go to the PowerPoint presentation. Then if you go to the second point, then what I have written, if you do not create a copy constructor, then the compiler inserts a default copy constructor which performs a bit by bit copy of object. So this is what was happening over here. If you go to here, then default copy constructor was doing what task? It was just copying the contents of M1 into M2. This was the task of default copy constructor. And now copy constructors can be overloaded. So we have studied about overloading. Now there is one copy constructor that is provided by the compiler, but I can overload this default constructor implementation. And how I am going to do it? See, it is a constructor. So whenever you create a constructor, I already said that it will have the same name as the name of the class. So what is the name of the class? It is my class. Then you write something like this, and you take a reference of my class, suppose M, and this M which you have taken as reference will be used to initialize the new object. So over here, if I write something like this, the copy constructor has been called, okay, and then I write a new line, and then what I do, I say this arrow x, that means the x of the current object, and I set it to m dot x, which is a reference to the object that has been passed as an argument, like this. So what does this mean? This means when you are writing this particular piece of code, okay, alright, when you are writing this particular piece of code, that means my class M2, when you are writing this, then the current object is the M2 object. The current object is the M2 object. That is why when you say this arrow x, that means whose x? The x of M2. And this M1 is being passed as a reference. So m dot x, when it is m dot x, it will be equal to 10. That means M2's x will also be set to 10. So if I just go and run this application, clean and build, and now if I go to run this application, so what will be the output? You see, the one argument constructor of my class has been called, and then the copy constructor, the copy constructor that we have overloaded, the copy constructor has been called. Okay, the output is something like this. If you just observe it, when you create M1, then the one argument constructor was called. When you initialize M2 through M1, then the copy constructor was called. And what copy constructor did? It set the value of x to be the value of M1's x. I can also do something like this. Suppose I don't want, I say something like this, m dot x plus 1. So in this case, what will be the output? Suppose I clean and build this application, and now I run this application. See, in M2's case, the value of x is now 11. So you can see that the copy constructor was called. And you know, the default copying is just bit by bit copying. So M1's x will be equal to M2's x. But we can overload this behavior, and we can, you know, perform the copying in the way we want, like that. And so now if you go and you observe this function, which function? The function 1. And this function 1 has something very specific. It is taking an argument. It is not taking a primitive argument. It is taking an argument of the class, my class itself, to which it belongs. Now what I do, I will remove this, and I will say, suppose I have created M1, and now I say function 1, and inside the argument I pass M1. Why I write this particular piece of code? Because function 1 is a instance member of my class, then it will be called through an object of my class, and it is taking an object of my class. So I have just passed M1. Okay, like that. Now if I go and just observe, what will be the output? Clean and build, and then if I run this application, then you see what will be the output. The one argument constructor has been called when I created M1, and when I said, I'll just remove it, and now when I said M1 dot function M1, then the copy constructor was called. Why the copy constructor was called in this case, I will try to explain graphically. Suppose I will take a new pen document. Inside this, suppose if I go over here, then suppose this is the scope of your main function. This is the scope of your main function, and inside the main function you have created an object, and which object? The M1 object. And suppose here if you go, and now this is the scope of the function 1. Okay, function 1, and inside function 1 you are creating a temporary object, the MOBJ, and what you are calling M1 dot function m1, and inside this argument you are passing m1, and this m1 is getting collected into mobj. So over here also you see when you create mobj, it is being initialized through m1. So in this case also the copy constructor will be called. The copy constructor will also be called in this case. Alright, that is why you are getting this output. What kind of output you are getting? You are getting this kind of output. The copy constructor has been called. I'll just end it. And okay. So here if you go, I have written copy constructor is called, the first point, the copy constructor is called when one object is used to initialize another object. We saw my class m2 is equal to m1. When we were writing it, the copy constructor was called. And then when I'm writing, when an object is passed as an argument to a function, then also, you know, the copy constructor is called. As you saw in this case, it is verified that in this case also the copy constructor is being called. Okay. So I'll end with my video with this. So in the next video, we will continue our discussion of copy constructors, and we will see that in which case exactly do we require copy constructor in a class. So in this video, we will continue our discussion of copy constructors, and copy constructors which we saw were used to initialize one object. We saw in the previous video that if one object is used to initialize another object, then a constructor is not called. Instead, a copy constructor is called. This much is clear. And now I also said, if you remember the previous video, I said something like this, that if you have dynamic memory allocation in your class, then it is important that you overload the copy constructor, because it can result in some kind of erroneous situation. So what kind of erroneous situation it can result? Let us try to understand this. For example, over here I have a class, and what is the name of the class? It is the student class, and inside the student class I am not keeping a string, I am instead creating a pointer to a string. I am not keeping a string, instead it is a pointer to a string. So let us go and create an object of the class. What is the name of the class? Student. And suppose I create an object of the class and say its name is Nikhil, and age is, say, suppose 21, this way I write, and s1 dot display student. Okay, this is what I do. And if I just go clean and build and run this application, so the output is very clear. This is just the simple beginning when we are trying to understand this. So if I run this, you know, the name of the student is Nikhil and the age of student is 21. So I will just go to print and I will take a new, I don't want to save it, and I will take a new, suppose my object I have created, that is the s1 object. S1 object, and S1 object is saving a pointer. That means it is saving an address. Suppose the address is 2050 and it is saving the name as Nikhil, and to which, so 2050 is the address of the string name, and that I have initialized it to Nikhil. Okay, it is something like this. Alright, so now your object is not containing the string Nikhil. Instead, I have created, you see, I have created a pointer to a string. I have created a pointer to a string. When you create an integer pointer, it is a pointer to integer. Similarly, when you create a pointer to a string, that means it will store the address of a string. So that is happening in this case. Suppose Nikhil, the string, is stored at memory location 2050. Then over here also we see that the S1 object is not containing Nikhil, it is containing the address, that is 2050. Now I use the copy, I write something like this. I create another object of student class S2 and initialize it through S1. That means the default copy constructor will be called, which we saw in the previous video. So if the default copy constructor will be called, so that means S2 will, over here the default copy constructor will perform the bit by bit copying, and once it performs a bit by bit copying, it will write over here 2050 and it will write over here something like this, 21. Over here it is correct, and suppose I write s2 dot display student. If I write like this, then it is clean and build, and once I run this application, you see for both of them the name is Nikhil and the age is 21. But now what I do, so what problem it can have over here is that suppose you access the name of this student, then you cannot access the name directly, you have the address to the name, and inside the address if you go and you change the name to be Nikhil, it was initially Nikhil, and you change it to be, suppose you change it to suppose you changed it to Nitin. Okay, you have changed this name to Nitin. That means now S2 is also containing the address 2050, and for S2 the name will also become what? It will become Nitin. If you are not able to understand, then I will write an instance method over here. What instance method? Void change name and suppose age. Sorry, change name and age, and then inside this change name and age I will take a string name and I will take an argument age. Alright, and then I will write something like this. What I will write? The current object name, how will access it? This arrow name will be equal to suppose name, and here if you observe, this arrow name will give me the address, and star operator gives the value at address. So here if I say star this arrow name, then that what this will this mean, and I will just explain it graphically. I will just say this arrow age is equal to age. I will just something like this. Okay, so so now if I write something like this, s1 dot change name and age, and I change the name to be Nitin, and I change the age to be 25, what will this mean? When you call s1 dot change name and age, naturally this method will be called, and what you are writing in this method, if you just observe the first line, this arrow name, that means the name of the current object, and you are using the star operator, that means the value at this address will be equal to the new name, that is Nitin. That means over here instead of Nikhil, Nitin will be written. And now what you are saying, this arrow age, you are calling this s1 dot change and name. That means this arrow age will mean the age of s1, and now the age of s1 will become what? It will not be 21, it will become 25. Okay, like this. Now I copy it and I paste it over here, and then I write s1 dot display student and then s2 dot display student. If I do something like this, then can you guess what will be the output? Suppose I clean and build this application. Oh, there is some errors. Okay, what is, okay, I have not given the semicolon. Alright, I will just again run this application, and I will run this application. I think it will run now. Yeah, it is running fine. So now if you observe, when I'll just so that it is clear, I will move it over here. First you said s1 dot display student, for s1 name was Nikhil and the age was 21. Then you said s2 dot display student, and s2 was copied from s1, so the name is Nikhil and the age was 21. This was performed by the default copy constructor, which performed a bit by bit copying. Then I said s1 dot change name and age. Then when the address, at this address the name was changed to Nitin, and that address was stored in s2 also. So that means for s2 also the name has changed to Nitin, but see, the age of the s2 object is still 21, but its name has changed to Nitin. Why? Because for the name I was not storing the hard-coded name, I was storing the address. So in this case it is imperative for me to overload the default copy constructor. So how I am going to overload the default copy constructor? I am going to overload it like something like this. What is the name of the class? It is student, and then const student reference s. This reference s will be used to initialize the new object. So inside the new object, this arrow name, it will be equal to new string, and what's s dot name. I will try to explain what I have written over here. So s dot name, when I say s dot name, so s dot name means whose name. See, we are overloading the default copy, we are overloading copy constructor. That means when I'm at this line, the copy constructor is being called, and inside this copy constructor the s1 object is being passed as a reference to s. So when I say s dot name, that means what does it means? That means 2050. And when I write star s1 dot name, that it means the value at this address, and the value at this address is Nikhil. So now you are using the new operator. So when you are using the new operator, that means a new piece of memory will be allocated, and the address of that new piece of memory will be stored in the s2 object. So how will this happen? This will happen something like this. For example, the new memory location is, say, suppose 3070, and here also the value will be Nikhil, and here not 2050 will be stored, instead over here 3070 will be stored. Okay, the address of the new memory that was allocated, the address of the new memory. See, this was my new memory that was allocated. Okay, like this. All right, and then I will say the age is not dynamically allocated, so I can write equal to s dot age. This is valid. Okay, so this is perfectly valid. So now once when I go and run this application, I have overloaded the default copy constructor. Okay, so now if I go and run this application, clean and build, and now I run this application. Yes, see over here. Okay, yeah, when I said s1.display student, what was the output? Name is Nikhil, age is 21. When I said s2.display student, because copy constructor was called over here, because the copy constructor was called, the name was still Nikhil and the age was 21. However, now when I say it was s1.display student, because I have called s1.change name and age, that means at 2050 memory location Nitin was written, but my dear friend, was at 3070 memory location this value was overridden? No, it remained to be the same. That is why when you say s1.display student, it is displaying Nitin comma 25, and when you say s2.display student, it is displaying Nikhil and 21. So this way it is, you know, when you dynamically allocate memory, some memory in your class, then it is imperative, you know, that you overload the default copy constructor. So I can write it on notepad also. I can write something like this: when you dynamically allocate some memory, then it is for us to overload the default copy constructor. Okay, like this.